So good morning, everyone. Good morning. Welcome to the Wireless Global Congress Paris 2024. For those of you that don't know me, so my name is Thiago Rodrigues. I'm the CEO of the Wireless Broadband Alliance. Once more, a big welcome to the Congress and a pleasure to be with all of you today. Before I start with my presentation, just a couple announcements and housekeeping. So the health and safety policy for this event. So please take just a few seconds of attention. In some case of any accident may happen. Another important housekeeping situation is the Wi-Fi, almost as important as the health and safety. I think I need to twist one or two arms to have open roaming for next year. But if you want to connect to Wi-Fi, please, here are the details of the passwords and the SSID for the Wi-Fi of the event. Just a mention as well to our sponsors that make these events possible. So a big thank you to Airties, Uppercom, Boingo, Cisco, Intel, Cloud4Y, Cognitive Systems, EMEA, Fusion, Google Yamio, Juniper, Life Mode, Morse Micro, Quant Wi-Fi, Ruckus, and Wireless LAN Association. Okay, so jumping on my presentation, I just want to take a few minutes to talk about WBA. And how positive was 2024 for the Alliance. So we have a great year in terms of projects and technical programs. We had more than 20 deliverables on the technical groups. So a big thank you for all of you as members or my colleagues from my team that contributed to this. Our membership as well grew by 20%, very positive as well on that front. Thank you for joining and be part of the Alliance. Open roaming services continue to grow. We saw a growth of 100% on the adoption. Our marketing activities, they grew up as well, 150%. And throughout the three Wireless Global Congresses that we have, in Asia, Americas, and Europe, we had more than 2,500 attendees and registrants. Highlight the new members of the Alliance, companies that joined WBA during 2024. This is not an exhaustive list, but many of you that joined this year, welcome. Thank you for being part of this community. Your contributions and participation is essential for WBA to continue with its activities and programs. Doing a little bit more of information on the technical programs. Like I said, 20 deliverables. The membership participation on the technical programs continues to grow. The new members involved on the technical programs just suffer a quite significant increase by 60%. Our extranet users continue to grow quite well, so we have another 10% growth on our extranet registrants, as well on the meetings and the regular weekly calls and meetings that we have on the technical programs. They continue to grow on a rate of 10%. I want to highlight as well on the technical work some of the new outcomes that were produced by all of you that are members. One example is the open roaming maps. So this is a new activity of WBA, but as well a different type of work that we produce in the Alliance. So we are collecting information from a crowdsourcing tool. We are exposing this information to the public in general. So there is a lot of effort on this example of technical work. The other one is our continuation of increasing open source software available to the public. We have been producing from different technical programs, including open roaming, including radius assurance and other initiatives. We are producing more open software that we put it on a public GitHub, and anyone in the world can access the GitHub, they can do contributions. So once more, I want to highlight that this is a new type of work that we are doing in WBI, and kudos to all of you involved, but this has been quite significant in terms of exposing the work of WBI. A few minutes as well on the marketing. We have as well a significant amount of work on the marketing activities. Between myself and some of my colleagues at the leadership of WBI, we do more than 50 briefings to the media along the year. Of course, that's quite significant and relevant to expose WBI. Our number of white papers and documents that are downloaded from the website continues to increase. The number of articles mentioning WBI technical programs has increased more than almost 150%. And of course, our website and social media followers continues to grow. Same on events, between the 3 large wireless global congresses that we ran, we had almost 30 sponsors for the 3 events. The number of attendees, as I mentioned, overpassing the 2,500, more than 200 speakers between the 3 events. We saw a significant increase on the satisfaction ratings that all of you give to the events. The satisfaction rate is already quite high, and increasing this number has been quite challenging for us. But thank you for recognizing the efforts of the team on the events from WBI. And as well, an effort from my team to participate on third-party events. We try to participate as many events as possible across the world, and we distribute our time on these different geographies. And just to finish, if you are not part of the Alliance, and if you agree with the vision of seamless and interoperable Wi-Fi services, consider to join the community. We are a very friendly community. We have a wide group of companies involved. So if you are not a member, consider to be part of the Alliance. We'll be more than glad to welcome you and have you as part of this community. So thank you so much for your attention, and I will move on the agenda for the next speaker. Thank you, everyone. Okay, so we have a great agenda for the first part of the Congress this morning, and I would like to jump immediately to the next speaker, Dr. Amina Budbendir, from Head of Research and Standardization at Airbus Defence and Space. Dr. Amina, welcome.
Good morning, everyone. Welcome to Paris for those coming from far. I'm Amina Budbendir. I'm leading the research and standardization activities within Airbus Defence and Space. I would like, in this short keynote, to highlight some challenges, some perspectives on the 6G and non-terrestrial networks called NTN, and the perspective that we have behind this to target the direct-to-device from the satellite. And this goes with the objective to have global coverage and seamless mobility. So, because maybe you might wonder why Airbus is really interested in 6G and why do we work on 6G. Of course, Airbus is known for the aircrafts, civil aircrafts, but the communication part is structural in all flying platforms. So these are pillars, of course, that we have the ground connectivity, the maritime connectivity, but everything off the ground that is air, stratosphere, or space in every orbit is clearly at the heart of our activities. Satellite for communications, for civil communications, governmental, military, also Earth observation and space exploration, all these need communication. On the aero connectivity, of course, civil but also military aircrafts need to communicate before moving and while moving, so all of them rely on ground and space connectivity for operational and entertainment needs. The unmanned aerial solutions, known as drones or HAPS, are also platforms that provide connectivity, either as relay or as antennas, having antennas on board. Helicopters, with their mission-critical and usually very low altitude of flying and operation, need to rely on very reliable means of communications. Same goes for the public safety and security in urban areas, but also outside urban areas where first responders need to respond, to act, and also in maritime, for maritime connectivity, offshore, ship-to-ship, ship-to-coast, all kind of ship communications off coast. From there, when we look at all these platforms, when we put ourselves in a 6G non-terrestrial perspective or outlook, we also see a convergence of technologies. There is a need to have different technologies from the ground, from the space communications, coming together to answer the same needs that are getting higher requirements, not only in terms of bandwidth, but also in terms of security, etc. And these are relying on two words that have been separate until now. So we have the telco word, where we have IP, mature IP, all the generations for mobile networks. We have specifications that are well implemented, and interoperability between the countries. Roaming works very well. So the telco word has embraced already interoperability and standardization, and also started the digitalization. Of course, now it sounds obvious when we talk about cloud and IT and networks coming together. It's almost has been, as we say in French. So we somehow started in the telco world to embrace the digitalization wave. While in the aerospace world, with all the flying or non-terrestrial platforms for connectivity or for other purposes, we are still so much into silo world and with proprietary solutions. And the costs, the cycles for developing, the cycles for deploying, the cycle for embracing new solutions, it is very long. And also the life cycle of every platform is quite long. So we can talk of 30 years for a satellite, and for LEO from 10 to 15 years. While for a generation of mobile networks, we see a generation every 10 years. So these are inherent challenges to both words, and if we want to bring them together, of course, it is a journey. It doesn't come in 5 years as we can develop just a new solution. It's really different sectors, different technologies merging together. We have the satellite networks, the terrestrial networks, the mobile, but also the Wi-Fi, fiber, all connectivity on the ground, but also airborne networks, which also can play a role in private networks, but also still don't have a mature regulation yet. So these are sectors of technologies that don't have the same maturity in terms of regulation, interoperability, and adoption by the market. So going into the need of global connectivity, global coverage, extending the coverage that we already have in urban areas by satellite connectivity, then how can we go into this interconnection? In research, there is a lot of work already in research in Europe, as I know it, but also internationally. There's a strong initiative called HexaX in Europe that is starting its second phase, that is giving directions for Europe on how we should define 6G, and it starts with KPIs, but also KVIs. So what is the value added for society and for our daily life? The perspective is 2030. but it relies a lot on the standardization. So 2030, we assume that 6G will be mature in specification in 3GPP and has already integrated the three aspects. Why do we think so? If we look at the timeline and how standardization and partnerships also are playing a role in defining 6G NTN and direct-to-device, in 3GPP, we talk about NTN, so we cover satellites, HAPS, flying platforms, balloons, or stratospheric planes, and of course, traditional mobile networks. Release 16 and 17 have already introduced NTN and targeted the direct-to-handheld or direct-to-device, and has completed everything related to IoT. So IoT from space, from satellite, has already been specified. And it relies on what we call GEO or non-NGSO, geostationary satellites that are transparent. So we don't have any G node B on board of the satellite. This is passed. Now we're finishing release 18, has been published, and it was the integration of NTN with 5G, with more backhauling and hybrid access. Release 19, the main difference is the regenerative payload. So we do target LEO satellites with full G node B on board of the satellite in order to define a new specification for this integration. And it's going on. We're also already pushing use cases, and we're already talking about 6G and 3GPP. And I cannot not mention MSSA, which is the Mobile Satellite Services Association, which is really active in defining the direct-to-device specifications in existing bands, so mainly L and S bands, but also further. So MSSA and 3GPP should work together in this direction, and not to mention all the partnerships that we need. So 6G NTN and direct devices, so if we're not just providing a new system or specifying a new system, we're also thinking of how this is answering needs from customers or from use cases that we have identified. And from Airbus perspective, and we relate to, if maybe you recognize the wheel diagram from the IMT 2030, we think the global coverage of seamless mobility is really at the crossroads of those pillars. So mainly for us, the aero connectivity is number one. Like, we cannot continue building and selling aircraft without ensuring the connectivity that goes with it. And because planes go everywhere on Earth, they do need to roam in a seamless way. Today, they rely mainly on limited satellite communications for operational needs and limited in-cabin connectivity, in-flight connectivity. But we would like to target more use cases and air-to-ground, so relying on the mobile network when the airplane is on an urban area, for example. Same goes for helicopters and stratospheric planes. They all need to onboard new features for to have this global coverage. Satellite to device is also a strong need, mainly from mission-critical communication stakeholders. They today rely on different devices, SATCOM devices, but also traditional 3GPP devices, and they would like to rely on the same devices wherever they go. And this should become possible thanks to the direct-to-device. The agriculture or oil and gas or offshore platforms also call strongly for enhanced satellite communications and connectivity to the shore. We know in Europe, for example, the connected cars already have regulation for PNT, positioning, navigation, and timing. There are SIM cards onboarded in each car in Europe that need to call emergency in case of accident, and this is a regulation. These SIM cards, if we achieve the direct-to-device, can also connect to the satellite, so enhanced PNT plus any emergency calls or infotainment for the cars, not only in urban areas, of course, but also rural areas. Of course, maritime connectivity may seem obvious because we're away from any terrestrial mobile networks. They call strongly for satellite connectivity, and maybe looking at the geo situations, we have NATO strongly believing in how they can reuse 5G for new use cases. So linking to also we're active also in influencing standardization, as I said, but also the IMT20 use cases. And when we look at what all we need to do, of course, we need to collaborate more. It's making those words coming together, but in a seamless way. Today, they still are disconnected, but we do need more collaboration. The ecosystems, basically, the telco ecosystem, traditional, the GAFAM, all the digital players, but also the satellite players. The awareness is rising, but the synergies are not yet there. So it's also a call from my side to collaborate. So please reach out if you're interested. And thanks for listening.
Thank you, Dr. Amine. Okay, let's move on the agenda, and I'd like to invite my good friend Matt McPherson, wireless CTO at Cisco, and as well member of the board of WBA. Welcome, Matt.
Am I on? Good. So I don't know who that young guy is. I think I need to do a new picture with the little more gray in the beard. So I'm going to talk a little bit about determinism. You've heard me talk about this before, but I wanted to take a little bit of a dive, go a little bit deeper. You know, when I do these keynotes, I always have to worry about, you can definitely get too technical. But at the same time, if we go a little bit under the covers, we can see what's really happening in Wi-Fi 7 and what's really happening in the industry. And so I'm just going to do that. I'm going to scratch the surface a little bit, because people say, well, do you really need determinism? Do you really need predictability? Well, I'll tell you one thing. I talk to a lot of customers, and I hear this all the time. They want more predictability in their networks, especially when you talk to IT departments, people that run networks. Or if you look at this convergence we were talking about just a minute ago, one of the things that you really need when you start thinking about converging 5G and Wi-Fi is, can you do that with a predictable capability? In other words, if 5G is going to offload into some of these Wi-Fi networks, can you get a carrier class experience? I can remember in the early days of Wi-Fi, which by the way is not that long ago, you talk to some of the service providers and they say, well, how many Erlang am I going to get for a busy hour? And on Wi-Fi, and we would say, it depends. And that's not an answer they like. It depends. They want this to be more predictable. So as we converge these networks together, I think these things start to become really important. The other thing that I've noticed in talking to customers, even in the enterprise space, is if you ask them, do you have a mission critical application that you run on your network? And I've yet to have an enterprise tell me, no, we don't run any mission-critical applications. In fact, the message is always that something has to be prioritized over something else. And this is one of the things that I really see as a big difference between 5G and Wi-Fi, is that Wi-Fi, or in the enterprise environment, you don't want to be fair. You want to prioritize certain traffic. And so if you're in a hospital, you might prioritize that connection to the heart rate monitor or the medical equipment over what the guests are doing to watch YouTube or some of these other types of activity or web browsing. And so you get these differences in services, and so there's this policy component. And so can you apply the policy to that experience, and can you get a predictable end result? So to do that, there's two things that you have to achieve in wireless, because I talk to a lot of engineers, of course, being in the CTO organization, and how do you do this? Because people will often say, we're in an unlicensed environment. Predictability is off the table. Anybody can come in, anybody can generate interference. So what do you mean predictable? What do you mean deterministic? That's something that can't fundamentally be achieved. But what's interesting is that there's two things that are really happening in the industry to solve this and have to happen. One is you have to have a stack that can do it. And you know, if you look at Wi-Fi, and I'll take you through a little bit of a journey on Wi-Fi and what we've been able to do and what we've done in enhancement-wise, and I'll show you some of these stack changes or capabilities that are allowing us to do scheduling on the network to get this more predictable result. Now, the other thing that you have to make sure that you're doing is accommodating interference, because it is unlicensed. So again, I'm talking about Wi-Fi specifically here, and if it's operating in unlicensed, it doesn't matter how smart you are, all these things we do around radio resource management, all these things we do around scheduling, if you're getting broadsided by interference, then what's going to happen? It's going to up those error rates, you're going to retransmit, and your predictability just went out the window. You no longer can determine the latency of the network. In fact, you can't even determine the throughput. So this is something that's been happening in the enterprise space for a long time. So what do we need? We need scheduling. We need to be able to take a policy, and that policy needs to be to affect that lower layer scheduler, which is what happened really when we went into Wi-Fi 6. And in interference, we need to be able to avoid it, we need to be able to schedule it, and we need to be able to mitigate it. So how are we doing that? So you may have seen me present this before. I'm not going to spend too much time here. I want to actually dig into a little bit of the technology. I said I'd go a little bit under the covers. But here you can see sort of this very high level view of progression that's happened in Wi-Fi. Because if you go to Wi-Fi 5 and earlier, what we were really doing, because it was, and many people would say, hey, this is a best effort network. Right? If it's best effort, that kind of throws determinism, that kind of throws predictability out the window, right? And what we did in Wi-Fi, and it became extremely popular, in fact, it carries like 83% of the world's traffic. It's amazing. It's more popular than anyone imagined it would be when it was created. And so what happened is that you'd over-provision these networks and you'd under-subscribe them. Now, if you've run a network, and I know many of you here have, if you got up over 50% channel utilization in Wi-Fi, what happened? It started to degrade. And in fact, if it was a high-density network, you'd start getting these collisions, and then things would back off and retransmit. And if there's a lot, like I said, if the density of the devices, which is more and more common as we add things to these networks, smart buildings, all that stuff you're connecting at home, right to your light bulb, right? As you get more of these things, the probability of collision goes up. So how do we mitigate that and handle it? And one way is just completely over-provision it. So it's a little bit of a shotgun approach. We do a lot of engineering to make these networks work well. And what happens? You can have a well-done network, or you can have a poorly done network. So has anybody ever been on a bad Wi-Fi? No, maybe it was the Wi-Fi's fault, maybe it was the backhauls fault, right? There's a lot of different reasons. Whenever you have a bad experience, everyone says the Wi-Fi's broke, but it could be anything in that path. But this is why. There was a lot of latitude in what kind of a network that you would deploy. Now, as we went into Wi-Fi 6, everything changed, because what we did is we enabled an OFDMA stack, which means that we could schedule in the frequency domain as well as in the time domain. Now remember, if there's a lot of different devices vying for the network, they're waiting for people to transmit, and then when they hear the air go clear, listen before talk, then they start to transmit. Now what we got with OFDMA, with frequency division, is now multiple things can be talking in that frequency at the same time. Now if you're muxing on the frequency domain, the number of times you mux, for every one of those, you eliminated a potential collision. And so if you've eliminated collision, then you've eliminated that back off, and if you've eliminated that back off, then you've eliminated some of that non-deterministic type capability. So we added frequency division. The other thing that we added in Wi-Fi 6 is this ability to schedule from the network. So instead of just everything trying to vie for the network equally, and just listening to the air and then starting to transmit, in Wi-Fi 6, what we could do is we could say, you talk, now you talk. Now you talk, and we could coordinate that. Not only could we coordinate it, but we could take, remember I said that upper stack policy, and we could coordinate those communications based on the applications and services that were most mission critical to you. So with Wi-Fi 6, two big things, that frequency division and the ability to schedule from the network. We added puncturing, and I'll talk about puncturing in a minute. Now, the other thing that happened is Wi-Fi 6E. Remember I said we have the stack, and it has to be a capable stack, and we have to be able to address this interference that sometimes we can't control in an unlicensed environment that gives us that response. You know, what kind of performance we get, I don't know. That's what we're trying to eliminate. So Wi-Fi 6E, I hate to call it a shotgun approach, but one way to solve the interference problem is to throw a lot of spectrum at it, right? Now, every time we throw spectrum at Wi-Fi, it gobbles it up. So it's going to happen again. In fact, I think in 6 gigahertz, it's going to happen faster because we don't see just the .11 stack there. We see 15.4 stacks. So you see things like Matter, like Thread. You see, you know, traditional Zigbee type protocols. And what's happening is that these APs are becoming multi-radio platforms. Bluetooth is going into 6 gigahertz. VLP is in 6 gigahertz. So you have all these things that are vying for those resources. When you have all those things vying for resources, what happens? They start colliding again, right? And so adding more spectrum buys us some time, but it doesn't ultimately solve the problem in the end. So enter Wi-Fi 7. Now, I've read all sorts of articles on Wi-Fi 7 and what we're doing in 7. I call it 7 plus. Some of these things are specifically in 7. Some of them we're developing for 8. Some of them are actually across 7 and other protocols like QoS. But a lot happened in Wi-Fi 7, and you read these articles saying, well, Wi-Fi 7 doesn't really get you anything. You know, you can do this with the previous protocol stack. I'm going to show you some reasons why it really makes a difference, and I'm going to show you how applying these technologies can make a difference in determinism. All right, now, I broke the fundamental rule of keynotes on this slide. This slide's too busy. I know that, but stick with me for a second, because what I want to show you here is an example of how the development in the industry is addressing both the stack capability and the ability to manage for interference. Both of these are happening simultaneously. So we are moving into the domain of more predictable wireless. So WMM has been around for a long time, and we actually get some pretty good improvements. This is pretty universal. Everybody's using it. I'm going to show you what it gets us. If you look at TUA, or Triggered Uplink Access, what that does is it allows the device to say, I have this traffic to send, and if you have an extension on that, you can say, I have this traffic to send at this frequency. Since the network is doing the schedule, please schedule me at this frequency. So now there's this communication that's happening between the device and the network to coordinate their service. So again, this is something that we didn't have before. And remember, the uplink is really the hard one. In the downlink, we have this QoS management. I show low adoption here because this is some of the new features that are happening in QoS Release 2 over at the WFA. But there's been mechanisms in networks for a long time to handle the downlink. At Cisco, when we see the flows come down, we can choose when we get to the AP how to schedule that based on the policy of the network. But you know what was really hard to do? Was to get control on the uplink. When does the device talk, and how do you manage that? Because they just start talking on the network. So when we see technologies like TUA, what we're doing is we're addressing that uplink. Well, then we have MLO, multi-link operation. I'll show you a little bit about that in just a second. But multi-link operation does two things. Not only does it lower latency, so it's a stack improvement, but it's using multiple pieces of frequency. And why is that important? Because when we have interference in one piece of frequency, we can assure the packets get through on the other frequency, and then MLO can move these channels around based on where it's getting the best throughput in real time. So it's managing both the frequency domain and the ability to get a more resilient latency characteristic. RTWT, I'll show you a little bit about that. Puncturing is all about protecting interference. As we go into 6 gigahertz, we have a lot more spectrum. So what happens is that the wider your channel, say you're using an 80 or 160 megahertz channel, right, and you get a little 20 megahertz piece of interference, then that channel gets busted up. You have a problem. It has to stop transmitting. So you don't really want to stop a 160 megahertz channel because you're getting this little bit of interference. So what you can do is you can recognize the interference and then schedule on both sides. So you see what's happening here? What the industry is doing is they're solving both the stack scheduler problem by policy, and they're solving this problem of unlicensed in the interference domain. And if we can put these two things together, we get something that's far more predictable. So again, I know, busy slide, but I think this is the little bit under the covers of what's actually happening and what release it's being certified and whether it's mandatory or optional by the WFA when you do that certification. So just to show you a couple of other technologies that are happening, I don't know how many people have heard of L4S. And people heard of L4S, you're starting to see it. I think Apple, Dean has seen it. So Apple has been chairing this group, and it's interesting because now what we're doing is we're not only looking at the air interface, because it's the air interface that often congests, because you can almost think of an air interface as sort of a mux instead of a switch, but it's also congestion that you can have anywhere else in the network, including the WAN. The typical places that we get latency is either on the air interface or in the WAN. And what L4S does this actually have a pointer? Ah, it does. So what L4S does is, as you're going hop by hop across here, what it will do is if there's congestion at any point, say this is your SD-WAN router, and there's congestion going into the WAN, what it'll do is it'll mark a congestion indicator that when it gets all the way to the end, it gets to the server, that gets reflected back to the sender. Now, if you do that, now the sender knows, hey, there's congestion in my path. And for a lot of these next generation applications where you need low latency, it's often having to do with codecs that are doing things like WebEx. So it's a video codec or it's a voice codec, right? Or you're doing something like augmented reality or virtual reality. Those are all codecs. And if you see congestion, you can actually codec down. So you can degrade a little bit in quality in order to get a much more reliable latency experience. Now, if you have a lot of, if congestion is happening here, you're getting a lot of congestion indications back to the clients, which means now that all the clients together only have to slow down a little bit for everybody to solve everyone else's problem. So again, we look at this on the air interface, we're looking at this end to end, but this is how you get this deterministic behavior. Remember I said when the Wi-Fi doesn't work, people say the Wi-Fi's broke? Well, it might have been that SD-WAN connection and have nothing to do with the Wi-Fi, and these are ways that you can actually get that quality of experience all the way through. MLO I'll talk about in a minute, and I already talked a little bit about TUA and what we can do in the uplink and also restricted TWT. Now I don't know, and I'm going to be completely honest, I tend to be very open when it comes to technology. I don't know if restricted TWT will get adoption or not, and I'll show you why in a minute in the charts. But what it basically allows to have happen is that if you have a mission, if you have something that's very delay sensitive, like this headset, and you have all this other traffic that's happening, the headset can tell the AP, hey, I need to be serviced at a certain rate, and then the AP can actually reserve slots both in the time and frequency domain. And then nothing else, and what it'll do, that AP will tell everything else on the network, don't transmit during this slot. So it's reserving a little piece, you know, a little bit of opportunity to transmit. So you can see it's transmitting. Now this guy wants to transmit. He knows for that transmit opportunity, don't be bigger than this space because this mission critical communication needs to be able to get through. So these are the types of stack improvements. So what I'll say is, are we getting something for Wi-Fi 7? I would say yes, we are. How much of it gets implemented and how fast it's adopted, I think we can debate, but the technology is there. I'm going to be real quick because I'm really running out of time. So this is MLD or MLO, multi-link device or multi-link operation. There's a lot of different modes for this. The two that are the most important are this EMLSR, so this enhanced multi-link single radio where you can use both pieces of spectrum to receive and transmit, which means that you can go to a good channel if you're having interference on another channel. And this other one is simultaneous transmit and receive, which means that you're getting more throughput at the same time that you're getting the resiliency. So MLO, if people say Wi-Fi 7, MLO is almost always the next thing that they talk about, because this really makes a big difference. This is just an example of puncturing. What you see here is without puncturing, no interference, everything gets through the channel fine. Here in legacy networks, if you got interference, then what happened is you lost all this bandwidth, and the radio resource management would move to a smaller channel to avoid it, and you just wouldn't get this capacity. With puncturing, what you do is you say, I can't use this piece, so now I'll transmit on both sides. So these are big efficiencies to what we had before and how we can do things like mitigate interference. So I'm almost done. So this is the difference. So this is some of the testing that we've done and some of the data that we've pulled together. And what you can see here, that if we have a 50% channel utilization on a 40 megahertz channel, if we're doing no quality of service, this is actually pretty good. And this is how we built networks in the past. If you're under 50% utilization, no quality of service at all could get you, even in dense implementations around 20 milliseconds. That's not bad. That's really not bad, right? And then if you add WMM, we're down below 15, worst case, 99.9 percentile. If you do MLO, now you're getting resiliency and a little bit of an improvement. TUA brings it down further, and if you do RTWT, you're down to a couple milliseconds. Okay? So these are pretty significant in their changes. Now, what happens when you hit 90% channel utilization? And I know a lot of you design networks, and you're going to tell me, well, you don't never run at 90% utilization. Are you crazy? That breaks Wi-Fi. And you know what? It would in Wi-Fi 5. Right? But as we go into these next generation, it doesn't. Now, why am I showing 90% utilization? Because data traffic tends to be very bursty, and the way that devices go onto the network tend to be bursty. And what that means is that you get these perfect storms of transmission. So even though your overall channel utilization can be managed to be fairly low, you're going to get these bursts of high channel utilization. And when you get the burst, the legacy technologies break down. And that's where you get the retransmits, and that's where you start to get these really high latencies. So you can see here, 250 milliseconds latency during these bursts. And what does that do? That breaks some of your next generation real-time applications, right? Now you start to apply things. Look at the gain just in WMM. But the scale's a little bit different now. This is still 50 milliseconds. Well, 50 milliseconds doesn't solve what we want for WebEx, for video teleconferencing, and for some of these next generation applications for manufacturing. They want lower latency than this. MLO gets you resiliency and a little bit of an improvement. Look at TUA is right down there where we need to be for most services and applications. And then if we go all the way to RTWT, look at this, same traffic, 90% channel utilization, and for your mission critical traffic, down there at 1 millisecond. You couldn't do that in Wi-Fi 5. So does Wi-Fi 7 add new functionality and capability that can take us into the next generation of application and services? I would say most certainly yes. All right, so this is what's coming. Like I say, the technology's in there. We'll see how long it takes for things to start to adopt it. Some of these things require collaboration with the end device, but as we start to certify more and more of this, we end up in the right place. So with that, I'll wrap up.
Thank you. Time for one question to Matt. Anyone?
Too early.
Too early. Everyone is familiar with Wi-Fi 7 and all the new capabilities.
All right.
Okay, Matt, thank you. Good to see you. Thank you for coming and be part of the Congress. So next speaker is Eric McLaughlin, Vice President and GM for wireless solution and client computing at Intel. Welcome, Eric.
Thank you.
Thank you.
So I hate following Matt. Two reasons. One, he's really tall, and I'm clearly not. And second, he's wicked smart. and I'm clearly not. So I apologize for kind of bringing down the excitement in the room here. But I will say I'm ahead of you, Matt. My old face picture's on the slide. So Matt did a great job actually setting up my presentation. We didn't coordinate this, but he did a great job doing that. So Matt just talked about all the things that have happened and are happening within the standard, for stack and interference and everything else to improve the predictability, latency, and everything with regard to Wi-Fi on a network. But even with all of those improvements, even with all the things that we're all working on across all of those domains, couple of things to note. One, I don't think I'm wrong here. If I am, I won't speak next year. But there is no perfect network. There is no perfect device. And we all experience this every single day. Hopefully, if I talk fast enough, I'm going to share a real-world example of an experience I had at work with the fact that there is no perfect network or perfect device. So the last time I talked to this audience, I talked a little bit about AI and how, you have to talk about AI, right? So, and how connectivity plays a role. So obviously, when you're working on a device, you're doing work, whether it's, I'm showing a PC here because I work at Intel, but it could be a phone, could be other devices that you're using, IoT, et cetera. You've got data that you're working with. You've got hardware, various kinds of hardware that you're using, and you've got software. And all of that you're using to do the work you need to do, the connection you need to do, and everything that you need to do to get your job done, have fun, do social, whatever it is you happen to be doing. All of that, with connectivity, connects you to more data, more hardware, more software, more things, more information, and allows you to do even more. Then comes AI. AI adds a tremendous difference in data that's coming across your device. Your device is generating data, but a lot of information is flowing across that device that wants to get into some sort of AI engine, workload, machine learning, etc. So not all of those workloads are created equal. Some are going to be done and worked on a device, some on the edge, some in the cloud. And so you need great connectivity to get the information back and forth, right, to get those models back and forth. And per Matt's conversation we just had, determinism is a huge part of that. If you want accurate AI, you want accurate information coming out, you want to make accurate prediction based upon the models. If you're not getting that information in the right place at the right time, you make inaccurate decisions. So what's cool about that is you've got this great connectivity, right? You have all this data. You have this great connectivity that's not only passing data, but also generating new data real time. You can optimize all of that and you create kind of a virtuous cycle. So what does that look like on our products? So we're not new to AI. We have some solutions in the market today, Intel Connectivity Performance Suite, which runs on a lot of different laptops out there, desktops as well. We have Killer for gaming to reduce latencies, improve the user experience. All of those devices they build on top of all of the things that Matt talked about, recognizing that there's no perfect network, no perfect device, and it goes through it and helps with prioritization, AP selection, moves you to a different AP if there's a better one in the environment, and does all this without user intervention. And on top of that, gathers a ton of data. Okay, so what are we doing with all of that data? We have a solution that's been announced, and we're working with multiple partners. We started with our friends at Cisco over 3 years ago now, working on how do we take the data, the telemetry, and information that we're gathering from the connectivity on the client. The cool thing about connectivity on the client is where it sits. Where connectivity sits, it's the first place data comes in, and it's the last place data comes out of your device. It has access because it's below the OS, It has access to information about what's happening on your device that nobody else can give you. The OS vendors can't give it to you, network vendors can't give it to you, but the client device can give it to you. And if you add to that information coming off the network, you get this really cool thing where you can take all of the connectivity data. So we have 3 phases in our solution. Connectivity telemetry, where we take all this unique data that's coming off the device, we move it into an analytics engine, and then use that to start driving new experiences. And one of the new experiences that we're driving is what I want to focus on today. There's a white paper that was just published by Intel IT. So I'm really fortunate to work at a company like Intel, where we have a very progressive IT shop. We've been able to bring our own devices, and because we launch laptops and desktops and everything all the time, I'm updating I probably go through 6 to 8 laptops a year. And they actually allow me to self-provision my laptop onto the network. So when I went to IT and said, hey, look, we've got this cool solution, Intel Connectivity Analytics. We're working with Cisco, which was our infrastructure provider. We want to have you guys test this out and show us, and tell us how it works. How does this help? And they jumped at the chance. They said, we want to be customer zero. So all of the stuff that I'm showing you today is we have more customers in the market than Intel IT, but from a big IT shop perspective, they're our biggest customer. So I mentioned a minute ago, we have all this data that comes off the device, and you have all this information on the network. Having one tool where you can see all that information, and it allows you, it's not just data, it's actually insights. It's actually hints about what might be happening, is a game changer for IT. Let me show you what I mean. So the way this works is we have a client PC, right, in this case. It's got the Intel Wi-Fi driver. It's got our software application running on it as well to make sure that we're gathering all that analytics and telemetry. We're putting it through our streaming engine, and we get that either into AI models or into the Cisco management platform, where they can also run those AI models. And when that information comes together, all that information is automatically sent into the Cisco management platform in this case. So what happens in a situation that occurs every day, multiple times a day, at a company like Intel, where we manage about 150,000 devices? What happens is, in typical, end user has a problem, they call IT, they explain their problem, IT asks them a bunch of information, they may download a tool, they run that tool, they gather the logs, the IT admin has to review the logs, look at them, make some decisions, they see some hints, they see some things that they've seen before, maybe there's some other reports that have come in, and the next thing you know, 15 minutes later, and by the way, my experience, 20, 30 minutes later, you end up with, here's what you need to do to solve your problem. Your driver's out of date, let's get it updated. Now, with Intel Connectivity Analytics and Cisco, we're actually reducing that time to 10 to 15 seconds. So if you're an IT admin with 150,000 devices, and you're going to get multiple calls like this a day, if you can shorten the time frame from 10 to 15 minutes to 10 to 15 seconds to resolve that, who's happier? Me, the person with the problem, or Intel IT? It's probably a horse race, right, as far as who's more pleased. But if I can get a solution done in 10 to 15 seconds as opposed to 10 to 15 minutes, it's huge. And this is what they're seeing. This isn't just guesswork, right? This is actually happening today at Intel. So what if we have a bigger problem, right? What if multiple users are reporting an issue? It's probably not a driver issue at that point, but same thing, right? Bunch of people call into the help desk, bunch of people say, I've got a problem. Each are maybe different level of skill at telling the IT admin what the problem is. They have to run the tools, ask the questions, gather the data, do the assimilation, and at one point, they probably have to roll somebody out to the area to see what's happening. That can take days. Now, different story, right? All that information is being automatically sent, real time into the management console for Cisco. A bunch of users call in, the information's parsed, they see multiple people in a problem, similar problem, gather the machine data, correlate it, look at it, and in 10 to 15 seconds, they're like, we have an AP problem, we gotta go update, upgrade, change location, do something. Okay, so here's my real-time actual experience prior to implementation of this solution. Came home from a trip, out of town, came to work on a Friday, booted up my machine, nothing was working. I mean, it was on, it showed me connected, the task tray showed that I was connected, I went into the connection manager in Windows, showed I was connected, but nothing's happening. So, being the Wi-Fi guy at Intel, I decided to do some troubleshooting. So I started doing some stuff on the PC, started ruling out situations. After about 10, 15, 20 minutes of my own stuff on the PC, I realized I think this is a network issue because everything on the device says it's connected except the apps. The apps don't think they're connected. The apps aren't doing anything. Everything in my apps, Teams, Word, whatever, was saying you're not connected. Everything else on my device said it was. So I started moving around, went to another location. Once I got about 50 meters from my original spot, everything cleared up. Life was good. So I called IT. You know what they said? Can you give us your logs? Can you do this? Can you do that? I said, no, I've done your troubleshooting for you. I have a bunch of information. Let me give it to you. So I showed them all the stuff I had done. I walked them through all of it. They escalated me through about 3 levels of IT, and they told me they'd get back to me in a couple days. So what did I do? I just worked at a different part of the office for a few days. Really inconvenient. Couldn't work at my desk where I have all these monitors and everything I need. I had to work at a different part of the office. And a guy calls me back, goes through a bunch of troubleshooting steps, and he said, by the way, did you do this or did someone help you? And I said, no, I did it. And he goes, how do you know to do this stuff? And I said, well, I run Wi-Fi at Intel. And so he's like, oh my gosh, I'm super sorry. They sent a guy out, and he was like, hey, guess what? There's an AP problem. With that, it would have taken 15 seconds with ICA and Cisco. Me, it took 3 days to get to resolution. Real-time, actual example of what happens. So, we need premium connectivity, which a lot of folks in this room are doing and delivering. We're working on standards and in WFA and WBA to improve the experience through all of the things that Matt shared with us that are being worked on. We need the ability to take the data that's available on the devices and the network and make sure we get that information into the right types of tools. We then can use AI to do all sorts of great things, including remediation. Right now, there's still an IT person that will say, okay, you have a driver problem, let me authorize a driver download for you. Soon, it's going to just happen, right? No IT professional has to be there, depending on how IT configures your policy. You can get self-remediation, you can get instant remediation if this happens. So we have this great program, we have all this data. Any of you out there that are interested in working with us on these kind of solutions, we'd love to work with you. We're already working with several people here. So bottom line is, one of the reasons this works is because of groups like this, where we can get together. You know, Matt and I knew each other best when we started working in WBA and WFA and the other groups. This is the place where you can do that industry collaboration, start looking at how we can solve real problems together, and you go from an idea we had 3 years ago to actually solving problems in 10 to 15 seconds that used to take multiple days. So that's it for me today. It's a lot of fun to solve real problems. Thank you for your time.
Thank you, Eric. Any questions to Eric from anyone? There is one. There is a microphone, please.
I saw that you mentioned that you have a close partnership with Cisco on a lot of these analytics. Are you planning to make these available open source for anyone out there to integrate, or is it
Not open source yet, although I think over time we'll have some of this open source, but we are working with other folks. Extreme is announced. We just announced yesterday with Riverbed. So if you follow me on LinkedIn, you saw the Riverbed announcement that's using our solution for this. Ybot, who I think is here as well. So a lot of companies we're already working with. So it's SDK based. We can get up and running reasonably quickly.
Any other question? Okay, once more,
Thank you.
Eric. Thank you so much.
Thank you.
Thank you. Okay, before we move to the next speaker, so all of you that are on the back and standing up, feel free to come to the front. There are still a few open seats available. Please come to the front. Feel more comfortable instead of standing up during the Congress. Moving to the next speaker is Metin Taskin, founder and CEO of AirTies and member of the board of WBA. So welcome, Metin. Thank you.
Hello, everyone. Thanks for coming. It's quite busy today. This week is very important for us. We are a Parisian company. Our headquarters is here. And we have 3 important events happening in the same week. Purple Summit, that was Monday and Tuesday. Network X, and Wireless Broadband Alliance. And we are very active in all those 3 events. And it's very convenient for me to sleep in my bed and come in the morning. All right. We talk about AI today. We are a Wi-Fi network diagnostics and optimization company. We work with service providers, internet service providers around the world. We have customers like AT&T, Vodafone Group, Deutsche Telekom Group, Bouygues Telecom in France. We integrate a small software agent into the gateway, and that agent is optimizing the Wi-Fi network. It manages mesh network. If there is mesh network, it manages client connectivity, collects data, sends data to cloud, and cloud does a lot of diagnostics and optimizations for the home network. We've been doing all that, honestly, without AI. There are many companies who use AI or abuse AI as a name many years before there was, let's say, AI was so easily available to use. But now it's time. We see a need to use AI to optimize Wi-Fi networks, understand what user is experiencing, and provide intelligence to the service providers to basically ensure the best user experience all the time. And it happens to that our name starts with AI. That wasn't on purpose. I found this name 20 years ago. AI was not that popular at that time. So the role of AI in Wi-Fi management, we are transforming the Wi-Fi networks. Wi-Fi networks is becoming more and more difficult to manage. As the load is increasing, a lot of different applications running, different types of clients everywhere. You can no longer have one rule to optimize channel and that's it, right? That doesn't work. That works to some extent, but it becomes more and more difficult to be able to provide the right user experience with that. So what do we do with AI? So we have a number of things that are needed to understand the Wi-Fi network. The applications, the device types, the user profiles, how does the user is interacting with the network, And latency is a big thing to manage because more and more real-time applications are using Wi-Fi network, and Wi-Fi is as we all know, is the biggest bottleneck for latency. So what we did now, starting from expert systems, which is basically rule-based software conditional systems, we are more moving into AI and machine learning as we learn more about the network and the applications and the users to optimize the Wi-Fi performance or the network performance overall, not just Wi-Fi. We're also moving into the broadband measurements and performance optimizations. So the first thing we use AI for is understanding the user experience. User experience is something really difficult. We have tons of tools to measure network performance from the core network to edge networks, everything. But there is actually very little tools that is with the user. So here we come in because we have our software running in the home that is actually in the same place as the user is, and it is able to see what the user sees. In order to understand user experience, we are using a lot of AI-based machine learning algorithms to measure many parameters and understand what's going on in the field. We have something called Wi-Fi Experience Index that basically tries to understand how user is experiencing Wi-Fi. In order to do that, it's no longer Wi-Fi capacity or it's no longer airtime, this and that. It's more and more how does the applications perform for that user. When you start talking about this, you first need to understand what application user is using at the time. And that is what we call application intelligence. And that is basically because we cannot put a software in every device that the user is using, we are trying to understand that from the place where we are at, which is the gateway node. This is the router of the home. So I think I have more details on this. No, let me talk about it in this slide. So understanding application, understanding which device is running that application, and understanding the Wi-Fi connectivity performance of that device at that time with that application, with the right markings of that application packets going through the network, understanding broadband latency, understanding Wi-Fi latency, all this goes into the user experience measurement. And that is a complicated thing to do, and this is why we are using AI algorithms to be able to come up with an outcome or predicted outcome, what we call quality of outcome. It's actually a standard paper on that. IEEE has a paper about how to predict quality of outcome of the applications by looking at network data. So another important thing is anomaly detection. If you know what errors to expect from the system, you can write a software and understand if those errors happen. Memory overflow, or a reboot, or other things that you know. What about the things that you don't know? So those are the things that goes out of order because of a software error, or a broadband interruption, or whatever happens in Wi-Fi. So we are actually looking at a lot of parameters all the time to understand if something goes outstanding, there must be something wrong. We have had an experience recently where all of a sudden the extender numbers going down. The extenders who are installed, you normally have some customers leaving and churning or turning off extenders. You have certain ratio that should be okay. There's nothing to be alarmed about. If half of the extenders all of a sudden going down, there is something wrong. So we identified there was something wrong in the extender software that was causing extenders to go not rebootable anymore. That came out of the data. And that was the only way to find out this is happening, because unless you reproduce in the lab, you will not be able to find that issue. So anomaly detection is very important because it is not only Wi-Fi, it is not broadband only, it is everything that the user is experiencing, collecting data, understanding what goes abnormal in that user. Traffic and profiles with AI. So this is an interesting concept. we all are in standard committees. We have QoS work group in WBA. There is a lot of work going on with requesting priorities and granting priorities from the network. So if this goes like this, everybody will request priorities. If you grant priorities to everybody, then there is no priority. So in home networks, what we are doing is we are trying to understand what the user is trying to do at that time. Is it entertainment? Is it video conferencing? Is it work time? In every home, there is a pattern. And you need to understand that pattern by looking at past and predict what the future will be and adjust the network parameters based on that. So we have this also, again, comes with understanding the application, understanding clients, and on top of that, understanding user behavior. It's not the same for every user. It's not the same for every home. So we are using AI algorithms to be able to understand what the user is doing and what should be prioritized, what should we change in terms of network behavior. Should we steer that client or not steer that client, or what time we should steer that client to another IP or another band. So there is a lot of behavioral changes needed in order to be able to satisfy the customer based on what the customer is trying to do. I talked about cloud of outcome, so that was the slide. I thought it was the next slide. Cloud of outcome is an interesting concept. It's not one parameter. It's not about bandwidth. It's not about only latency. It's about the holistic approach to basically identify what this application will experience in terms of 0 to 100% quality based on the network parameters. And this is coming, actually, application providers has to provide that. Like, I want a latency profile like this. If the 80 percentile is less than 50 milliseconds, my experience will be 80%. If 90% of the 90% percentile of the latency is less than 60 milliseconds, I have a 90% of the quality of experience. So every application has a different requirement in terms of latency profile and bandwidth requirement. And by looking at these patterns, first identifying the application, measuring latency during the application time, and profiling the latency distribution, because there is no one number for latency. There is a distribution of latency of the packets. You cannot say that video conference latency has to be less than 100% all the time. It's never all the time. You will have some packets arriving late. You will have some packets arriving way earlier than that. So there is a profile that you need to be able to understand, and there is a outcome that you need to be able to calculate. So those are actually what we are doing in the router side, collecting that data, understanding the profile, and predicting what the quality of outcome is. If we see that quality of outcome is not going to be good, take actions. Could be prioritization, could be changing the steering decisions, changing some, throttling some of the traffic. So there is a lot of things the router can do in order to provide the user experience with different network behavior. I talked about that, app identification and device identification. Those are needed in order to be able to optimize the experience. There's a lot of side benefits of that also, understanding what users are using at home, what they are using as applications. There is a lot of insights that service providers can utilize in order to be able to upsell services or upsell mobile service, for example, devices. So there's a lot of business intelligence possible by knowing what the user is doing. So where do we see AI in the future? So we're just doing this kind of things as I explained here, but there's more and more opportunities coming up with AI. We are seeing that AI engines implemented in the router chips. Every chip vendor is now saying that they have AI engine in the gateway router. How do we use that? I don't know so much. I think we'll find ways to utilize and try to provide a better user experience in home. There is Gen AI use cases also for users interacting with the network. Every home broadband offer now, most of them comes with a mobile application where the user can change things and interact with the network with their own mobile device. So there is more and more opportunities here. But I think what we see is the biggest need is the network has to be able to adapt what the user is doing. And in order to do that, it needs to be able to understand what the user has, what kind of user profile it is, and what the network should do in order to provide the best user experience all the time. So I think that's all I have. Any questions, I'll be happy to answer. I don't know if I'm on time. Tiago?
No, we are on time.
All right.
Any questions from Martin, from anyone? Dean has a question. Microphone is coming.
Yeah.
Hi there. Whenever I hear prioritization in networks, the question I always have is, who defines importance and priority? So the user, the service provider, the application provider, an employer, a parent may all have very different ideas of what is the most important application or usage. And also, a given application can have different purposes. So if I'm watching a YouTube video of a cat, it could be entertainment, but maybe I'm doing vet training, or maybe I'm watching a political advert. Yeah. So the network can't know that. How do you reconcile all these different questions about what really is the priority?
Yeah, that's a very good question. Like I said during I was talking about user behavior, Wi-Fi Alliance has this Wi-Fi QoS standard, and we have a work group in the Wireless Broadband Alliance to see how we can utilize that. So that says that the application can determine who gets the priority, because application requests that I want priority now. If the network provides that, then that's the application, so network has nothing to say. According to standard, that's the case, which we say is not the right thing to do. If every application wants priority, there is no priority. So one step back, should network decide what the priority is? That's also a question again, like why should network decide on which one of my applications are the right ones to get the best quality and the rest can be suppressed? That's not the right thing to do too. This is why we put this AI engine in there. So we have a mobile application, and I cannot project here, but in this mobile application, maybe you can see, in my home, I can choose, prioritize entertainment, which is watching video, like YouTube, Netflix, this kind of applications gets prioritized. Or you can say, I'm working now, work. So we identified applications like work applications, Zoom, Teams, or other conferencing tools. Or I say gaming, and then you identify gaming applications and prioritize. So somebody needs to choose. So in this mobile application, the user can choose. They can say, prioritize video now because I'm watching my Netflix. I don't want anything else. My kid should not interrupt with my quality. But what we found was this is not even the best choice, because people prioritize, they forget. And after that, next day, they have a problem when they're working. So this is why we implemented AI, to be able to predict on behalf of the user what's the best thing to prioritize at this time. If that doesn't work, the user can always go and overwrite. But there needs to be an intelligence to do it on behalf of the user. In the end, user is the person who should prioritize it. But can they do a good job? A lot of times, no. This is why the auto mode is basically trying to, I could not open, to do that on their behalf.
Thank you.
All right.
Yeah. Another question there. Tunjai.
Metin, could you comment on, excuse me, the relevance of Wi-Fi management, AI-driven Wi-Fi management, in the context of Wi-Fi 7? And the background to that is there are claims by some chipset vendors and hardware vendors that because of the advances in Wi-Fi 7, you don't need Wi-Fi management. So I just leave it at that. And I want to hear your thoughts about that and what you see in the field.
Yeah. So it's a very good question. Every time there is a new Wi-Fi technology, we have bigger problems to solve. Even in Wi-Fi 6, we have clients that doesn't connect to Wi-Fi 6 gateways. They don't even attempt to connect because they do not understand the beacon is too long for them. They overflow, whatever the implementation problem they have. It's not a standard problem, it's an implementation problem. But unfortunately, they're there. Wi-Fi 7 will have even more clients falling into this kind of situations. I know in the US, for example, Vizio TVs doesn't connect to Wi-Fi 7 gateways. The standard says it's okay if we put extensions to the beacon or extensions to the probe response or those broadcast packets, and some clients are unfortunately very stupid. They get confused when they see something unexpected. So the management becomes more important to iron out these kind of issues. This is why understanding device is very important, so that you can change the Wi-Fi behavior towards that device in a way that that device will be able to connect, because the user will not say that, oh, sorry, my TV is badly implemented and it's not connecting to your gateway, it's my problem. No, it's going to be ISP's problem. You need to solve it. So I know some ISPs, they do not enable Wi-Fi 6 on 2.4 gigahertz because there are clients at 2.4 gigahertz that doesn't connect at all. They don't even attempt. If they attempt, you will know at least that they are trying to connect. So I think unfortunately the standards are good on paper, but sometimes they don't cover everything. Especially Wi-Fi world is very complicated, and that's why you need more intelligence from the network side. Network has to be accommodating for all the clients that are already there, paid for, and working for the user. So I think there is more importance of management in Wi-Fi 7. Of course, there is new features of Wi-Fi 7. We can use much better prioritization schemes there. I mean, prioritization is an easy word, but there is many ways of doing that. The default way in Wi-Fi is wireless multimedia extensions, which is more than 10 years old. It's not very efficient anymore. Now with Wi-Fi 6, we have scheduling and OFDMA features. Wi-Fi 7, we have MLO. We have a lot of advanced features. But those are all levers that you need to play with. Who turns those levers? It's the management software. So this is why you need more management software as the Wi-Fi gets more complicated.
Yeah. Thank you.
Thank you.
One final question. There is one more. Final one.
Is AirTice able to solve this issue with all our, let's say, stupid devices automatically without influencing the other devices in the network?
Yes and no. Some we solve, some we understand. So when we understand that there is a stupid device, you sometimes need to fall back to the lower standard just to have this home be happy. Some of them we solve because you can send a different management packet to a device that doesn't understand let's say, more complicated packets. But this thing is also changing. Some devices get updated and their behavior changes. So it's a learning and adapting play that's always going on. And homes are really, really the worst places for that, because there's all sorts of devices appearing there without any control. So that's why the home management is, maybe it's more difficult than enterprise network management. Thank you.
Metin, thank you so much.
Thank you.
Thank you.
My pleasure.
Okay, moving on the agenda. So next speaker, Dr. Derek Patterson, CTO at Boingo Wireless and co-chair of the Wireless Broadband Alliance. Derek, please come on stage. Thank you.
All right, I wanted to start with, we've been coming to these WBA things for a while. And last night we were sitting at dinner, and Tiago, I'm gonna call you out a little bit. Tiago's been, it's this month, 20 years ago, Tiago started at the WBA. I think that's pretty impressive. So it's good that I'm following Airties, because I was going to talk about something very similar and answering some of the questions from an enterprise perspective. For those of you who don't know me, I'm Derek Peterson. I'm the CTO for Boingo Wireless, and I'm also the co-chair of the WBA. I have a slide deck talking about Las Vegas, and we picked Las Vegas maybe because Mobile World Congress is happening in Las Vegas, and my CEO and a bunch of people are there today. But the main reason I picked it is because we're doing stuff in Vegas that's really talking about all the things that we've been talking about today. Is how do we make all this work? You know, it was 2012. I remember I sat up on one of these stages at the beginning with the WBA, and I brought up this idea of we should build smart networks. And I don't know how many of you remember the SMART acronym that I shared back then. Anybody? I know, Howard, you hopefully remember it. Come on. Some of you. So I said back then, I said, you know, our networks need to be secure. That's the S. That's the most important part, right? They need to be multi-platform, because we don't have a single kind of device that's trying to connect. We have multiple different devices connecting, and each of them require some kind of different connectivity possibly, or they require some kind of different quality of service. Cameras, TVs, our phones that we always talk about. All these things, they're multi-platform, and then that requires possibly in Wi-Fi different segmentation or different networks, cellular networks or Halo networks or whatever, Bluetooth, Zigbee, all those different networks. So that was the M. A, back in 2012, was analytics driven. And that was this: if I don't know what's going on with the network, how the heck am I going to manage it? Today we're calling it AI, but it's very important to have that analytics-driven capability in your network so you know what's going on. The R was responsive. We have to have a network that's going to be able to respond to the changes, because new devices come in, they're updating as was shared, and then all of a sudden they want a different kind of connection. They used to support WPA2, now they support WPA3. They used to have packet sizes this way, now they're doing it a different way. So you have to be responsive to that network and constantly making changes. And the last is tiered, and that's because not every location that you go to can afford to have all of the bells and whistles turned to build the network. So sometimes you're going to just take what's out of the box. Whatever Cisco gives me out of the box in their management interface, or a DAS network gives me, or a private network gives me, I'm just going to use that NMS and I'm just going to make it work, right? And so I'm going to tier my different solutions to manage that. And so when I look at the journey of building those smart networks, and to answer one of the questions that Dean had earlier, in 2014 we said, you know what, we need a gateway. And I focused in, and I was standing up here and I said, we're going to put deep packet inspection in every gateway across all of our airports, because we were using Wi-Fi 4 and 5, and we didn't have all these cool tricks in Wi-Fi 7, and we needed DPI and prioritization to be able to manage all that traffic. So we threw in DPI in every airport, and we started going, wow, we're getting really good at this managing stuff, and we're going to try to advance out from airports and do everywhere. So we're doing military bases and stadiums and all kinds of stuff, hospitals and everything now. But the idea has always been, how do we at Boingo try to figure out what kind of network is needed for whatever industry, whatever kind of location we go into, and being able to build that smart network. And so then I'm going to bring it back now to Las Vegas. And Las Vegas is a very interesting location, because this is just, hey, yeah, we're doing all this 5G and Wi-Fi, but at the end, I guess before I jump into Las Vegas, at the end, what we're trying to really do is get connectivity. You know, over 35 years ago, I was in the military. I was running around calling in airstrikes, and I'm sitting there trying to get on a radio and go, get me an airplane and let me figure out where somebody is so I can, and I'm playing around with networks back then. And the key thing was, how the heck do I get a connection so I can, have a good connection? And that was my focus. And it hasn't changed in 35 years. That's all I'm still figuring out is, what kind of connection can I help somebody build, whether it includes a satellite backhaul, a circuit backhaul, Wi-Fi, cellular, et cetera. And so that's where we're focused at Boingo, is really just trying to figure out how to help our partners, our customers, really, those enterprises that we work with across all those industry types, to give them great connectivity, whether it's using 5G, private or public, whether it's using Wi-Fi, whether it's using any unlicensed technology, and actually getting it to work. And so let's get into Vegas. So Vegas, we've been really focused on Vegas. So what we do is we go, hey, where can we go next to help with connectivity? We kind of have this mentality in my engineering department, is like, we've got to solve problems. So Vegas is very unique. Vegas, we got into Vegas a few years ago. We hadn't done a lot in Vegas, and we were like, boy, this place is booming. They've got the Formula F1. I went last year. It was great. The kind of technology that those vehicles use is amazing. You had the Super Bowl there last year. You have all these trade shows going on. Some of the largest trade shows, like CES, runs there every January. They're now having 3 Major League Baseball or Major League teams. They got football, hockey, and Major League Baseball. Bunch of people going in and out of Vegas. Very challenging environment. Connectivity was probably not a key thing for them years ago, because what happens in Vegas was supposed to stay in Vegas. Everybody knows that term, right? But now, connectivity in Vegas is hugely important because of all of these locations and all of this entertainment that's going on and all the visitors that's happening in there. So their demand in Vegas has skyrocketed. So we were like, oh, it's time to get into Vegas and start figuring out how to help in Vegas. So one of the things we did initially was, okay, what is some of the most challenging places in Vegas? And so for us, it was this Las Vegas Convention Center. It's a very large convention center. I would say it's one of the biggest in the world. Has 6 million people went through there with a bunch of different shows, and all of these shows are different. Some of them are like the biggest concrete show. Connectivity is a little bit different for a concrete show than it is for a CES show. And so we were like, okay, how could we get involved in this? And we ended up starting to talk to people in Vegas, and they were like, you know what, we're struggling with cellular connectivity because we have such this large location with multiple buildings, and how can we work on that? So recently, we ended up taking over managing the DAS there, and we're going through upgrades there. And why do we end up doing that? Because we know it's a challenging environment, and then we're trying to figure out how do we end up changing the network around to be able to meet these needs. So it started with a conversation with the convention center, with us, and saying, what are your needs now? What are you trying to connect? Let's go through every single one of your different conventions that you have go through there. What are the kind of questions that they're asking you, so that we could end up, to the point that was asked earlier, trying to figure out what the priority is going to be for each one of these different conventions, because it's not the same. And so you've got to adapt accordingly for that. And so, instead of just focusing in and just saying, I'm just going to put APs down the hallway, or all the same, there's certain areas and certain shows where you need a different kind of connectivity. You may need a massive amount of connectivity because they're doing something unique in that part of the show area. And so the redesign is not just, hey, go put antennas up. It's like, what kind of coverage, what kind of capacity, what kind of secure multi-platform, analytics-driven, responsive, and tiered solution do I need for this specific venue? And then it's about going and building that out and figuring out how you end up creating that for that location. And then possibly bringing in more things, which we are doing, than the DAS. So we realized we need more probes out there. So we're putting in probes right now so that we can measure the traffic for CES. We're going to probe the whole thing, a whole call, so that we can understand all the traffic, so that when we do that upgrade, we're ready with all the information to know how to build that network. And then once we get all those probes in there, we can see all that traffic and make those adjustments as appropriately. The other thing we wanted to do was really see how Wi-Fi 7 is going to work. So working with, I'm horrible with Nate, Mike Sherwood, who's the CIO of Las Vegas, we were like, hey, what are your challenges? What are you trying to do? And so he's part of working on an open roaming project right now where they're trying to get open roaming. Actually, they moved to Edge Roam, and I ended up talking last week. I was like, don't do Edge Roam, do open roaming. But the key thing is we were talking, and we were like, what can we do to help you with that and make that better for what you're trying to do? So Wi-Fi 7 has become very important showcase there, because the venues there housed so many people, and it was like, what can Wi-Fi 7 do for you? We could have put in Wi-Fi 6 with our gateway, but with some of the new capabilities, and again, if you don't control the device, and in public networks, you can't always control the device, then you have to rely sometimes on, you know, some of the tools that are available that you can add to improve your network. You know, when I'm using like a place where I control the devices, and you know, like I'm doing a military base and I'm doing a flight line, I control every device there. I can make that device work the way I want it to. I can make the network work the way I want it to. But in public networks, sometimes you can't. So taking advantage of some of the new technologies in Wi-Fi 7 in a place with only 685,000 people, but 60 whatever it was million people going in and out of that city, that means you're going to end up having to take advantage of some of these unique technologies that are coming available with Wi-Fi 7. So huge fan of Wi-Fi 7. We have it running. We're testing all these different capabilities to make public Wi-Fi really work well, using puncturing and MLO and big channels and small channels and all of those things, recognizing that you can't control the entire environment, and so you have to do it that way. And then lastly, the way we're doing that is through this innovation center. So we launched this innovation center, I think it was about 3 years ago, and the whole idea was to bring in different people throughout Las Vegas to come in and try different things. Let's go figure out the best way to be able to do security cameras. Let's go figure out the best way to manage betting systems, et cetera, and be able to create a place for us to figure out what works, what doesn't work, what technology should I use, and how do I adapt for that. And so we're excited about this innovation forum. It's actually, there's a bunch of people there today, and I wish I was there kind of with them. We've got the military guys in there today, and this CIO of the Air Force in there, because they're trying to figure out, you know, the same kind of challenges that they're trying to do when they start moving more towards public-private partnerships and establishing some of their communications and needs throughout the Air Force. So anyhow, that's the end result, I guess, is I'd just say setting up networks with all of the different technologies that we all have at our disposal. I think there's definitely a lot that we all learned. There's great technologies like we saw from Intel and from Cisco. You've got AirTie's working on it on the home. Kind of the same way AirTie's is working on the home, Boingo's working on it at these venues. You know, one of my favorite venues to talk about is the Sphere. You know, that network was built by the Sphere, and then it was after they built it, they go, you know what? Managing a network is different than building a network. And so we manage that network for them now for about a year. And the first thing we had to do was do things like put in a gateway so that my NOC could actually see the network, because the only way you could see the network is if you were actually on site. Well, if you have to be on site to manage a network, then that doesn't really work. So we had to put in gateways and out-of-bound routers and all this stuff, and then probes now, and now, you know, we're starting to do those tweaks that make it better. And those are the kind of things that you focus on. We realized they didn't have backup circuits, their UPSs were not quite right, so it's just going through and doing those things and making those kind of determinations about how to build all three of these different great technologies. So with that, I do have some books that we have out for different industries where we talk about how what it takes to put all these together. You know, healthcare is different than airports, different than sports and entertainment. There's different devices you're dealing with, which requires different technologies, probably different segmentation even on the same technology. You know, one of the things that we found is, you know, just to talk Wi-Fi, we found running at least 2 different types of Wi-Fi, a 2, 4, and a 5, and a 5 and a 6 is useful, because if you run 2, 4, and 5, you'll find a lot of devices that can't support WPA3, so you run a 2, 4, and a 5 that supports WPA2, and then you run a 5, 6 that supports WPA3 and does MLO and does all that stuff. So you've got to, you know, and it's different for each location, so you have to think that through. So with that, I'm done. I was right on time. I'm open for questions and answers, and back to Tiago.
Thank you, Derek. Any question to Derek from anyone? Okay. Looks like you did a good job, and everyone is looking for coffee. So now we'll break for coffee. We'll come back at 11:05 for the following session. Thank you, everyone.
Hello, and welcome back. I'm Dean Bubley, and I will be moderating this part of the day, running up to lunch. We've got a number of speakers, and then we have a panel as well. We're looking at various technology and service trends in next-gen Wi-Fi and wireless broadband. For those who don't know me, I'm an industry analyst and commentator, so I do everything look at everything from Wi-Fi to 5G and 6G, cloud, aspects of fiber networks, and an awful lot on things like broadband and spectrum policy as well. And so one of the things I'm very interested in is seeing the dynamics playing out around the evolution of Wi-Fi 7, what that means for the use of spectrum effectively, and also the relevance to other areas of development in networks and telecoms. So we heard a lot about enterprise, but one of the things that I'm watching is, particularly in Europe, the real push towards getting fiber out to homes. And at the moment, we see fiber just stopping at the front door. Most of the governments and also the EU have policies for homes passed rather than homes connected. And frankly, even if the home is connected, you still need to have connectivity inside as well. And the same is true of business premises. And so I think one of the things that perhaps Wi-Fi 7 does is allows fiber to come to life. So hopefully we may hear some about that. The other thing that I'm also very interested in is the interplay between different wireless technologies, whether that's public and private 5G, enterprise and consumer Wi-Fi. We heard about satellite and aviation-based connectivity, and also other technologies. And whether or not they're linked together, whether it's converged or whether they're, let's say, coexisting and interoperating at a different level, whether they're all tied together in the network. So hopefully we'll hear a lot more about things like open roaming, about some of the spectrum issues, and I'll probably be throwing in some nasty questions if no one else on the floor puts their hand up as well. And with that, I'd like to welcome our first speaker to the stage, and I'm just clicking through. That's the agenda for the session that we're going to have this morning. So a number of presentations and then the panel session. I'll be back for that as well. And first up, we have Maureen Gallagher from Wi-Fi Alliance. And I'm sure many of you will be familiar with WFA, but Maureen will give us an update. Thank you. Maureen.
comment allez-vous? Thank you, Tiago, and thank you, WBA. It's such a pleasure to be here. You know, we really value the partnership and the collaboration between the Wi-Fi Alliance and the Wireless Broadband Alliance. So, great partnership together. I'd like to start out today by reflecting on an incredible journey of Wi-Fi. It's taken 25 years, so we're celebrating the 25th birthday of Wi-Fi this year. So, yeah, so the founding of Wi-Fi. And so I'd kind of like us all to reflect on the past 25 years because there's been so many extraordinary achievements in wireless communication. So, you know, before, you know, I don't want to just talk about it. I'd like to show, you know, a brief video encapsulating all the incredible things that where Wi-Fi has come over the years.
In a world where connectivity is essential, one technology revolutionized our lives. 25 years ago, Wi-Fi emerged, liberating us from cables and unleashing the power of the internet. Wi-Fi granted us access to the world from anywhere. We could connect with people around the globe, stream entertainment, and access information instantaneously. Wi-Fi's impact on society is profound. It revolutionized industries, expanded communication, and spurred innovation, contributing trillions to the global economy. Education flourished and healthcare efficiency improved. Homes became smarter and safer. Businesses embraced flexible work and enabled greater employee productivity. Transportation segments delivered better passenger connectivity. Wi-Fi transcends boundaries, connecting people worldwide, fostering communication and collaboration on global initiatives. As we honor Wi-Fi's 25th anniversary, let us pause to marvel at its journey, from humble beginnings to the cornerstone of modern civilization. For in its legacy, we find not just technology, but the promise of a brighter, more connected future for all.
Okay, so happy birthday, Wi-Fi, and congratulations to everyone who's been in this industry all these years. So Wi-Fi extends beyond just mere connectivity. It also encompasses the economic, the social, and without saying the technological dimensions. So this 25 years of transformative technology is definitely a milestone that reminds us just how integral that Wi-Fi has become in our daily lives. And much of the value of Wi-Fi, it was never, ever envisioned from the outset. You know, it's come a long way from being an office networking protocol to one of the biggest, largest success stories of the technology era. And the reason for this success is that it allows almost anyone to innovate on top of it. So 25 years later, here we are in 2024, and we're taking a victory lap, you know. So what have we achieved this year in 2024? So we had the successful launch of Wi-Fi Certified 7. We had an unprecedented number of Wi-Fi devices in use, over 21 billion. So, and just looking at the economic aspects of Wi-Fi, we know that it delivers more than 4.3 trillion in economic value in US dollars. Its innovative and unique 6 gigahertz deployments in healthcare and esports just illustrates, you know, how far we're going in this new era. So what does the next 25 years of Wi-Fi look like for Wi-Fi? So in 2025, and we love numbers in the Wi-Fi Alliance, so I'm going to, you know, cite some of these stats here. 50 billion cumulative Wi-Fi shipments anticipated for 2025. 1.2 billion Wi-Fi 7 devices will ship in 2026, And in 2027, an expected 100,000 Wi-Fi certified products. In 2028, 5 billion in annual Wi-Fi device shipments. And by 2029, well, we know that the future generations of Wi-Fi are going to emerge. So Wi-Fi lays the foundation for future connectivity, and 6 gigahertz is going to take us there. So efficacy, you know, what are the results? What are we seeing? So we are seeing advanced use cases, particularly in AR and VR, and immersive 3D, medical training, flight simulations, high-definition video streaming, and a lot more. From an innovation perspective, there's endless possibilities that are happening. There's continuous advancements in 6 gigahertz, especially with the uncongested spectrum band and the capabilities that it's required for advanced use cases. We're seeing faster speeds, lower latency, higher efficiency, higher density, and of course, greater reliability, which we all want. From a confidence perspective, 6 gigahertz, it's giving users the trust that the high capacity applications with very stringent performance requirements, that they'll just work. It's scalable. It's going to support future technology advancements that allows enterprises to maintain the most cutting edge possibilities in their networks. And equal access, it's providing, full access to the 6 gigahertz band, giving the users the best Wi-Fi experience that they can expect. So 6 gigahertz really is the foundation of the next generation of Wi-Fi. And Wi-Fi Alliance, we're leading that charge and driving the propagation of 6 gigahertz. Why? Well, less interference, higher throughput, and density, it's a more reliable wireless experience. And who doesn't want reliability? We all want reliability. It's important for the regulators and the policymakers and companies in making sure that they understand that all the companies that are operating in different geographical locations, that they understand the importance of 6 gigahertz and the full use of it. Because 6 gigahertz means wider channels, and it's a much better proposition for the world. By the end of 2024, we'll see an increase in 6 gigahertz devices with an estimated 808 million shipments expected by the end of the year. And about 250 million of these will be Wi-Fi 7, making use of the 6 gigahertz band. And approximately 13 products have been Wi-Fi certified for 6 gigahertz year to date. So more users than ever will experience the power of 6 gigahertz. And we're seeing this increased proliferation as Apple and Samsung and Google and Motorola, all those phones, they're all supporting 6 gigahertz Wi-Fi now. So again, I mentioned that Wi-Fi certified, that Wi-Fi Alliance has certified more than 1,300 devices with 6 gigahertz Wi-Fi. And in 2024, 576 million Wi-Fi 6E devices are expected to ship. And 231 million Wi-Fi 7's devices will ship in 2024. So overall, 6 gigahertz Wi-Fi shipments will exceed 1.2 billion in 2025 and reaching 2.5 billion in 2028. So, we're seeing a number of these Wi-Fi certified devices hit the market, and they're starting to emerge. These are just a sample of some of the Wi-Fi 7 products that are out there. Obviously, we really encourage all of you to certify your devices if you are bringing Wi-Fi products to market. It's really important. We detect a lot of issues and through the certification process, so it's really, really important, and can't emphasize the certification process enough. So we're seeing everything from infrastructure to flagship smartphones that I mentioned, and part of what's driving this is the consistency of the experience. Okay, so we've got determinism, low latency. These are all increasingly important, and we're seeing tri-band phones as well. So the EU is obviously a very critical area for our advocacy efforts. So we just recently sponsored an industry report on Wi-Fi spectrum. We contracted with an independent research firm this year, and the study underscores the importance of achieving infrastructure goals. It explicitly focused on the EU and Wi-Fi spectrum. And the study notes that limiting Wi-Fi spectrum availability in Europe, it degrades the performance and it undermines gigabit infrastructure. As you all heard, the European Union is working to provide gigabit connectivity to every household by 2030. And as part of its digital decade 2030 strategy, big initiatives in the EU about gigabit everywhere, and huge investments in infrastructure doing fiber to the home and other approaches that everybody in the EU is coming to expect, so that everybody has high-speed internet across Europe. So our research explored what actually happens from a probability standpoint. What is the probability of achieving 250 megabits per second, 500 megabits per second, and multi-gigabit in actual European environments, like construction environments of apartments, condos, and multi-dwelling units. So we had significant findings with the study, and with access to only 5 of the 100 megahertz channels, the standard scenario, if you don't secure the entire band, you have about a 50% chance of delivering gigabit connectivity to any user. So the real potential lies in the leap to 10 channels, where the probability of achieving gigabit connectivity, it's really, in real-world environment, it really is significantly increases. This is a crucial understanding, especially when considering the co-interference from one apartment to the next. So the access to the 6 gigabit will be necessary to achieve these gigabit connectivity goals. I'm not going to get into all these details here, but basically what I'm trying to illustrate here is that, inadequate spectrum degrades Wi-Fi's performance, and it undermines the infrastructure investments that the EU is making and all of its benefits. So Europe is at risk of missing its target of delivering 1 gigabit per second connectivity across EU households by 2030. And the reality is that the vast majority in-home internet traffic, it reaches users through Wi-Fi. So again, to just finalize this study, it didn't analyze the Wi-Fi's performance in enterprise settings, but it's expected that the low number of non-overlapping channels greatly restricts the opportunities for high-density enterprise deployments Wi-Fi in Europe. We did another study, and this one had to do with sustainability. We had, in this study, had 2 different scenarios, assigning the entire 6 gigahertz band to Wi-Fi, and another scenario assigning only just the upper half of the band to mobile. The conclusion of all this study is that, again, the sufficient access to spectrum Wi-Fi outperforms cellular networks in delivering broadband connectivity with significant reductions in CO2 emissions, and allows Wi-Fi to essentially contribute to the sustainability movement. So another example, and I'm going to end with this because we're running out of time here, but I want to share something really exciting that the Wi-Fi Alliance is doing in conjunction with a hospital in Thailand. It's a teaching university in Bangkok, and they're currently going through a trial right now to demonstrate the value of 6 gigahertz, demonstrate high throughput, low latency, and doing this through AR and VR applications. So together, in July we hosted a demonstration along with Meta and HPE and Intel, and we showcased the uncongested bands of 6 gigahertz to support medical education and training and dense deployments. And again, we had multiple scenarios, but basically, at the end of the day, the demo underscored the importance of making the total 6 gigahertz available for Wi-Fi to deliver stringent latency requirements and data throughputs needed for optimal AR and VR user experience. So it's critical in the future of healthcare and critical for patient outcomes. So again, another example is in the gaming industry. Again, gaming industry is heavily dependent on Ethernet, but they also, there was another experiment this year with one of our member companies, Nokia, organizing the first esports event, again, demonstrating the value of 6 gigahertz. And, at the end of the day, all these gamers were very, very pleased with the outcome of doing their gaming activities with 6 gigahertz. So, again, we've got many examples, many new emerging products coming to market. I just want to say that the Wi-Fi Alliance, we're very committed to enabling a robust Wi-Fi ecosystem and one that provides superior experience by advocating worldwide adoption of 6 gigahertz. So thank you, everybody, and we invite all of you to come and celebrate this remarkable milestone of Wi-Fi this year with all of us in the Wi-Fi Alliance. So thank you very much.
Thank you very much, Maureen. I'm going to steal 30 seconds of time if there's any questions. I think you might have escaped this one, but we'll be coming back to 6 gigahertz on the panel, I know, later on. Thank you very much.
Thank you.
Next up, I'd like to introduce to the stage Ivan Muccini from Cloud4Y. I think that's how you pronounce the company name. Ivan, welcome to the stage.
All right. Welcome, everyone. My name is Ivan Muccini. I'm VP Product of Cloud4Y. And today I'm here to talk about challenges and opportunities that we see in the public Wi-Fi market, and not only, and share our perspective on ways to improve customer experience. To set the context, just a few words about Cloud4Y, who we are. So we are a SaaS company, and we specialize in providing businesses solutions for onboarding and manage access of unmanaged devices, including public Wi-Fi, bring your own device use cases, MDU, and so on. Over the past 10 years, we work with hundreds of organizations and dozens of large enterprises facing global scale deployments with all the complexity that comes with it from the operational compliance standpoint. And we're also, of course, a member of the WGC and a sponsor of this event. All right, we just seen in the video before what incredible journey Wi-Fi had in the past 25 years. And I'd like to start this presentation with a question and asking you to reflect on your journey in coming today in this meeting. And how many times have you looked for Wi-Fi? And how many times were you successful in getting online? So I'd like to start this by sharing my experience with you. I departed from Pisa, I'm from Italy, and I arrived early at the train station, and I looked for Wi-Fi. Well, this is the only hiccup I had in my journey, but to be honest, I clicked on the only public network, and it kept spinning. I wasn't able to go online. Honestly, I wasn't even sure if the Wi-Fi was from the city, from the train station. There is really no way to know it, right? But I was successful to connect at the airport, waiting for the airplane. And by the way, we provide the service to all the major airports all over Italy and more than 100 train stations also, excluding Pisa. Then, of course, I went on the airplane trying to connect, get online. Wi-Fi I had to pay for it. It wasn't really worth it for 1 hour flight, so didn't go online. But likely was offered. Same thing at the Orly airport, where I was not a long time ago, by the way, but I had to go through the onboarding once again, look for the advertisement. And During that time in the airport, I downloaded the app for buying the ticket for the metro. And then I discovered that also in the metro station I had Wi-Fi. Got to the hotel, looked for the Wi-Fi. Again, captive portal, clicked the thermal views. I got stuck because basically I couldn't go back. And I swiped up my pop-up browser, and the network turned auto join off. So some troubles there. But finally, I got to the venue yesterday where we had the WBA event, meetings, and all my devices automatically connected without doing anything. Because I previously onboarded my devices with a passpoint profile provided by our IDP services that could connect my devices to the Open Roaming network. All right, does it sound familiar? Right? So at the same time, I have in my pocket a technology that could write my entire speech, build my presentation, and all of that just by talking with this technology. And this feels two different experiences from two different centuries. And the reason is that this is the same experience I had 15 years ago. Right? Nothing changed. So we've seen the incredible evolution of Wi-Fi 7, AI, and all of that, but this is where we are today. So why all these portals, right? We need to admit one thing. Captive portals are great to onboarding people, especially if they don't have any alternative connectivity, and they allow businesses to fulfill their compliance requirements. The problem starts when you use the very same network also to connect the devices to the internet, because those networks are not secure. And so most devices nowadays tend to use a fake, not static MAC address. But the MAC address in captive portals is really important because it's the only way we have to recognize returning devices and connect them automatically without prompting portals over and over again. Some devices nowadays, like the one I have in my pocket, rotates the MAC address every 2 weeks. But all my colleagues and all their forums in the ecosystem, they agree that this is just going to be more and more frequent over time, up to 24 hours or more frequently. So we can basically say that we lost the remember me function for hotspots. And this doesn't have only implication on the customer experience, but also on the business side. The data intelligence is affected, data gets duplicated, the reports and analytics do not adapt anymore, troubleshooting and monitoring is more complicated. So what can we do about it? Well, captive portals are here to stay for a little while. We cannot get rid of them in one day, so we need to do the best as we can to mitigate the impact of MAC randomization and all the different things that get introduced that kind of disrupt the user experience. And then now is the right time to start planning for the future, right? Adopting new technologies, introducing them step by step, including Passpoint, and we will see also, other complementary technologies that today are the only solution for fulfilling certain use cases. Starting from captive portals, well, what can we do? Well, for sure, we cannot rely on MAC addresses anymore. So, there is a reason why single sign-on is so common in web services, because people don't want to have yet another set of credentials for every application, and nevertheless for every hotspot or hotspot provider. And so solutions like connecting with Apple ID on captive portals is a nice solution. We can't avoid prompting portals, but we can ease the user experience, especially returning users, and just connect them in one click or a face scan. We have also seen businesses now just securing their hotspot, just putting a Wi-Fi password in front of it. Probably the Wi-Fi in these places, the network access SID works in the same way. You have a password, and then you go to an hotspot. Well, the reason is that for some reasons, devices tend to do not rotate MAC address when the network is secure. And so in those cases where it's easy enough to share the Wi-Fi password, many businesses are doing this today. Although it's not really future-proof. It might change at every time. So what can we do for the future? Well, I'm going to talk about 4 different solutions that mainly rely on Passpoint as the foundation for the next generation public Wi-Fi services. And lastly, I'm going to also talk about one technology that yet is not standard, but is solving a very practical use case today. So let's start from mobile apps. Mobile apps are a great onboarding channel because, of course, they can use the APIs of the operating system. And so provisioning a passpoint profile in a device through a mobile app is really easy. Ultimately, it requires only one click from the user to install and activate that profile. And that's also why we see this use case getting adopted more and more, and usually most organizations, they start from this type of experience in their journey toward the adoption of Passpoint. We provide an SDK, all the toolkits and the telemetry reports, everything that we can to simplify the developer experience so that they can focus in creating the best enrollment experience that, as they can, because that experience is really essential to drive conversion. Now, another benefit that comes with this solution is that this type of technology, the deterministic connectivity to the network, empowers and unlocks additional real-time, location-aware use cases that ultimately they bring benefits also to the business department, the marketing departments, that not only becomes a stakeholder, but in some cases they might also finance these type of activities and projects. Now, not all businesses have a mobile app, and not all users download it. So what else can we do? Well, originally, Passpoint had something built in the standard called OSU port, online sign-up, designed to onboard people directly into the Passpoint network. Unfortunately, that was deprecated because of lack of ecosystem adoption. And so we need to use what's available today. And what is available today are onboarding through web portals. So, for example, while users attempt to go online by connecting through these captive portals, we can today invite users and prompt them with an option for a better Wi-Fi, more secure and more seamless. And although this experience is not very familiar with most users, and in some operating system is not even very friendly, well, those users that value a better Wi-Fi, that they don't want to get on these portals over and over, for example, in high-frequency venues, they at least have an option. And they are probably more willing to take the time to go through the enrollment until the end. There are also other options like online portals, simple web pages that allows users to get onboarded, that download their profiles, though it raises the problem how to share these URLs and these links. One example is the email I got from the WGC before coming here that invited me to visit an onboarding portal to download a Passpoint profile. So when I will get to the event, I could have been connected automatically to the Open Roaming network. Now, if onboarding is a challenge, why not relying on existing Passpoint identities, right? Well, that is what Open Roaming really gives us, right? A framework to manage the dynamics between identity providers that owns users and network providers. So, although we have more than almost 15,000 access points where we are deploying Open Roaming right now, we need to admit that there are some barriers to the adoption of Open Roaming. The most common one is that businesses are not ready to lose all the insights they get from their traditional captive portals. They want to know who is connecting to the networks. They want to use that portal to collect first-party data, fulfill their compliance requirements, and so on. So while we wait for more standard, widely adopted solution to emerge, maybe based on CAP-port or other technologies, we provide a solution that allows to meet the needs and requirements of all these different stakeholders. So we allow access networks to accept users with existing profiles to connect seamlessly to their network. But we also offer them the chance to prompt a portal to these users only the first time they visit. So they can use this portal to fulfill any of their desires, fulfilling compliance requirements, collecting first-party data, sponsoring products and services, and so on. And for users, in exchange for a one-time interaction with one of these portals, of course, they get, now moving forward, a seamless and automatic connectivity. Now, we can't, there is another use case, which is emerging. Like we all have headless devices with us more and more frequently, and in all type of situations, not only in hospitality or at work, but even in conferences like this. So how do, we believe that Passpoint in the long term might be even the best solution to onboard IoT devices. There are discussions and standards emerging to make that happen. Other solutions like Easy Connect or particular protocols of the Wi-Fi aware standard. But really, today, the vast majority of headless devices that you have, from your printers to your VR devices, can be connected only with a simple PSK. And so that's why a lot of Wi-Fi vendors, most of them, in the past years, they created a technology called personal pre-share key or dynamic multi-easy pre-share key. Everybody came up with their own name because really it's not a standard. And the great thing about this technology is nothing but the possibility to have different Wi-Fi password on the same SSID, so each one can be allocated to a different user and with an independent lifecycle management. And it's really easy to use. Right? Everybody can connect with the Wi-Fi password. Most devices can connect with it. It's more secure than an open network. And it's very easy to manage from the operational standpoint. That's why we also invested in this and trying to complement our onboarding solutions that primarily attempt to offer Passpoint onboarding also with the PPSK option. So, in every context, from MDU to student living in campuses, universities, also in some bring your own device use cases in some companies, we offer users the ability to self-onboard, get the chance to download the Passpoint profiles, but also get their own personal Wi-Fi password to connect their headless devices. Now, so we believe this is the best moment ever for public Wi-Fi in general to start transitioning toward Passpoint. And and this can be done, leveraging as many channels as possible, right? Including captive portals, online portals, and so on. At the same time, in every other situation where there is a user base that they may already have an account or have the opportunity to check in, for example, in hospitalities or members of loyalty programs, wherever there is already a digital touch point to reach that user base, it's easier to prompt for onboarding in other technologies such as Passpoint. But since Passpoint is not yet universally supported by all devices, including most of headless devices, PPSK is a good complement, right, to fulfill a very important use case, which is self-onboarding headless devices. And of course, mobile apps is a no-brainer use case to empower them with Passpoint because they provide a very simple and easy user experience and with a great benefit for the organizations. Now, before closing up, I'd like also to share, I was thinking, I started this presentation complaining, ironically, about my experience. So what would it be a nice experience for me? Something that I will be proud to go back in the office and share with my colleagues. Well, definitely not connecting manually to every SSID wherever I go, not sharing my data with a lot of companies and accepting tons of privacy policies that I will never know how to go back to. But also knowing who is providing me the service, right? And having the option to control what data I want to share or not. So maybe I would engage with one or a few providers that offer me this option so that when I arrive at the train stations, maybe I get a message saying, Wi-Fi, you're connected. Wi-Fi provided by Trenitalia. Click here to get to the timetable. Similarly to the message you got here when you travel from abroad and you got the SMS from your carrier saying, you're roaming on a different network. It's us, right? It's Orange or whatever. You're online thanks to us. And maybe in the same thing in all the other places, right? Be informed about who is providing me the service. And maybe I opted in to get something back, like useful information, like ability to get to the airport map. Or maybe when I arrive at the hotel, something telling me, welcome back, because I was there last year as well. You're on our free Wi-Fi plan. Click to enhance your experience. And to get your Wi-Fi posture so you can connect all your headless devices in your room, right? This will be a nice experience for me. Seamless, secure, informative, consented, and that will be something that I will be proud of. Now, that's why we encourage organizations to start assessing their use cases, especially in the public Wi-Fi space, consider the impact that including Passpoint, migrating to Passpoint can have on the customer experience. And these are new technologies, so we see most businesses want to experiment them and see them with their own eyes, and we understand it's not always easy. So companies like us are here for this reason, to facilitate this journey, to test these options. And ultimately also the deployment in production, it doesn't have to happen in one day, right? These usually are solutions and experiences that can be deployed in parallel with the existing legacy captive portals so that users get familiar with these technologies until these will become a mainstream experience for everybody. With that, I thank you for your attention, and I'd like to engage. If you have any questions, also feel free to reach us at this email address, and I'll be around for the rest of the conference. So thank you, everyone.
Great, thank you. Are there any questions? I'm certainly glad to see we're slowly getting rid of the captive portal. People who know me know that I absolutely detest them. So it's good to see that they're edging towards the exit door. Question though, on one of your slides, you're talking about the new approaches using, it was Passpoint rather than open roaming, but Passpoint relies on SIM authentication, doesn't it? So how does that apply to things like laptops, for example?
Well, Passpoint does not rely necessarily on SIM authentication, right? Every company, every IDP that owns user's identity can deploy a Passpoint profile with an identity. It doesn't have to be a SIM one, right?
So I thought it was open roaming that allowed you to do non-SIM identity. But okay, maybe
also
I'm wrong.
Passpoint, right?
Oh, okay.
Like IDPs like Cloud4Y, if you go in our portal, you don't load the Passpoint profile, it will automatically connect you to open roaming and Passpoint networks.
Well, one of the challenges is that the next step, the do you want a Passpoint profile, is it comes up, certainly on iOS when I did it in the past, with one of the do you want iOS to install a profile with a little cogwheel. And a lot of people go, ugh, yeah, what the hell's that? How close are we to fixing that?
Well, I can't talk about it, can't speak about that, but hopefully the point is if Apple and all the other players will see traction, demand from the market, that's why we encourage organizations to start now their journey, because if there is a pull from the industry, from the market, even the players like Apple and all the device manufacturers will simplify and they will care about the user experience and making that step easier, right? That's what we hope.
Great, thank you very much. Okay, thank you once again, Ivan. Thank you.
Thank you.
Okay. Next speaker is Mital Parekh from Ruckus. Yes, excellent. Thank you. Welcome to the stage. Thank you.
Thank you.
Cheers.
All right. Can you hear me okay? So, as I was coming here, I was thinking, AI is like sugar. You can only have so much in a day, okay? Your brain starts getting saturated. You don't want any more. So I'm going to try to dispel a few things. We are going to talk about beyond the hype, and logic is very simple, right? These days, even toothbrush has AI. But then when it comes to enterprise networking, right, what's real, what's hype? Let's talk a little bit more, unravel it. And of course, I am with a vendor, so I'm going to give you a little bit of pitch on Ruckus and how we are deploying AI. So if I scan the enterprise networking, these are some of the trends that are emerging, okay? I won't go through each and every here, but it's sufficient to say that AI has made its way into every single one of it in order to deliver the best end user experience. you will see that end users are more about AR, VR, and video. Applications are getting more and more latency sensitive. The idea is simple, right? We have solutions for those, Wi-Fi 7. We have solutions for latency sensitive. That's edge computing, so on and so forth. I can go through the whole list. But in every single circle, you will see that AI is playing a big role, okay? It is taking an active participation in ensuring the best end user experience as enterprise networking is evolving. If I double click on enterprise networking as we all know, this is important, right? I can go on and on about all the trends, but these are some of the things that we experience on daily basis. So let's talk about when you deploy an enterprise network. The very first thing is right from configuration to management, to troubleshooting, to optimization. Orchestration has taken a center stage, and that is you don't want to do it yourself. You want somebody else to do it, and it better be machine, and you want that machine to be rather more intelligent than you are. So enter AI, okay? One of the things that's emerging, and that is intent-based networking, and that is you don't have wherewithal with lean IT and very few IT staff with RF expertise. You are barely able to keep network on. How are you planning to let it read your mind and configure it itself? Well, AI is at play, and that's intent cognition. You're talking about optimization, and I'm going to touch upon this later, but if you have been in the industry, you know that with 2.4 gigahertz, there were only 3 non-overlapping channels. With 6 gigahertz, it is 59 in 20 megahertz. And number goes on and on. Try doing channel planning with pencil and a paper, and you will know where AI is required, okay? Network management. You know that as soon as you deploy a network, it starts changing. As more users, applications, devices get into your network, things start falling apart. Is your network able to keep itself humming dynamically as the load changes? AI comes into play. And last, and the most prevalent one, is troubleshooting, right? Dean asked a question about prioritization and who decides the prioritization. We are going to touch upon that one as to, are you able to identify what's wrong with your network? Are you able to understand once something is wrong, why it is wrong? And are you able to find out how to fix it? Again, AI. The use of AI in enterprise networking is exploding, and almost every vendor has solutions in one or more of these pentagon, okay? So I stole this one from AvidThink. I remember that I put AvidThink logo on this one, and somehow it got deleted, but I should give credit where it's due. And the logic is very simple. If you see the entire networking life cycle, AI has a role to play in almost every single step of the way, right from when you start designing your network. So I touched upon network planning or channel planning to deploying. You want AI to deploy your network. You don't want IT to do it. One of the things that I shared with you in the trends is that IT staff is getting leaner. In 2022 at Mobile World Congress, I ran a poll. How many of your IT engineers are RF engineers? And borderline answers were all over the spectrum. The most of it was lopsided. Big laughter. I said, what are you talking about? These days, IT engineers or Wi-Fi engineers are not RF engineers. How are you going to keep it? How are you going to configure it and manage it? Troubleshooting is getting way more complex with Wi-Fi 7 and 6 gigahertz. Optimizing as well as continuous improvement, right? Let's talk about just keep it humming first. Then we will optimize it. So the problem is really serious, and we see that AI is playing a role in every single box that you see here. So let's talk about something that is very near and dear to our hearts, is just keeping your network humming, keeping your network efficient, right? Talk about surfacing issues before they become service affecting. So you will see many vendors talking about alarms. Alarms are not incidents, right? You got to better understand what exactly, there will be hundreds of alarms, but only few of those, and after analyzing many of those, you come to a conclusion that something is happening, something is brewing somewhere, and that's an incident. Again, not every incident is going to be service affecting, right? I am very vocal. My iPad is down or it's not connecting, I'll call the help desk 17 times, I'll file 3 tickets under different names, different priorities, whereas, Mark here, he's a very chill guy. The whole building is falling apart and he's going to sit quietly filing a ticket. Who is IT going to tend to first? Probably me. But that's higher priority item, right? So the point here being, how do you surface issues before they become service affecting? Understanding the blast radius. It's beyond our capacity, human capacity. How do you identify after knowing that these are the incidents, maybe P1, and I'm sure, Dean, probably you are cooking up the question for me on this one, but the point here is, once you have identified the priority, how are you going to go and say, why did this happen? Root cause analysis, finding needle in the haystack, right? If you ask an average IT person or in an enterprise how many IT tools they have, it's probably 50 plus, right? I have done log analysis myself. I have taken logs from various different things and mapped even timestamp where there were milliseconds, no milliseconds, however, triangulation, and it's painful, right? How are you going to find that needle in the haystack? Last but not the least, once you have identified, are you equipped to solve it or fix it? What if AI told you that I understand exactly what's going on, I've seen it time and again, and these are the steps you got to follow in order to fix it? How many times have you heard your IT say that, you know what, we have made that change today morning because it's SAT or ACT time at the school, and hopefully everything is going to be okay, right? Hopefully everything is going to be okay, right? That's not an answer, right? Are they able to say, I'm going to make these configuration changes, I have made these, and I know exactly how those changes are going to behave, right? AI is right there for you, and vendors are implementing those things. And last but not the least is all about once your network has understood enough about itself, is your network able to tell you that I see an opportunity to optimize or to make your network better? If you are from IT, please tell me, how many times in a day, week, month, quarter, or a year, you take time out of your daily job to say, I'm going to tweak or optimize the network. I don't think it is running optimally. Really, this is, I have asked, I'm from CommScope, Ruckus, and we ask these questions of our IT people every single week. Answer is very simple. You know that they don't have time to tend to all the tickets. They're not going to go and optimize the network. What if AI kept telling you every morning that says, I have found opportunities to optimize your network, and here is some estimation on benefits you are going to derive in network efficiency. Click here to accept it, okay? And then I'm going to keep an eye, a very close eye, on changes that I have made myself. Well, computer is computer, it's not human. So now the systems are so smart that it's going to say sorry to you, unlike human being, right away. If really it messes up the network, it's going to roll itself back. That's the power of AI, okay? And that derives, or that gives you network efficiency. AI Ops, you're going to hear a whole lot about this one. It's all about deploying AI in order to ensure that you are able to automate almost everything, right? Pointless to go over each of these things because I believe I have only 5 more minutes and I do want to get to the point with how we are solving all these things. So I mentioned to you about Wi-Fi 7 and 6 gigahertz and how many non-overlapping channels are there, right? 3 in 2.4, and now we have Wi-Fi 7 and 6 gigahertz, where you have 59 in 20 megahertz, and then 29 and 40, and so on and so forth. The problem is this: if you take into consideration channel width, transmit power, so you have 3 parameters already, and you try to optimize or plan your network, your channels, you are never going to succeed. Okay? You will always doubt yourself. Let AI do this. This is the prime candidate for AI. So there is a nice monument right here. It looks like a needle, right? It's everybody from across the globe, they come to see that one. Their Wi-Fi network has ruckus. The channel planning for that is done using Ruckus AI. You'll see the APs are all coated, so it does not, those white APs don't stand out. They gel with the architecture. And this particular picture shows you how this network was. If I could show you this one, look at the interference and how we were able to clean up using AI. That's the power of AI. You want to clean your network so that it becomes more efficient. It's able to take in more devices. It's able to deliver more throughput per device. So let's talk about AI playing a role in digital twin. Some of you know this. Some of you probably will get introduced for the first time. Not every single time IT has luxury to dig their hand into real network and plug and pray, right? It's like, let me go do some things and see if it sticks. And enter digital twin, that is creating a replica of your real network into digital world and trying out, see war scenarios and see if it's going to stick, and then put it in real world. AI plays a big role in developing the digital twin model, configuring it, running scenarios, and bringing the results back as a recommendation into your real network. Okay? I mentioned to you intent-based networking, and that is very simple. Now, the world of enterprise network is moving from, let me configure this network and every single parameter such a way that I can have high density versus high throughput. Now, IT is trained to click on a radio button that says, I would like you to configure my network that tends to, or that answers to high density versus high throughput per client. And then let AI do whatever it needs to do in that dynamic network, right? It's not static in the dynamic network. Yes, I have 2 minutes. Okay. So I do believe that AI is taking us slowly to the promised land of fully autonomous enterprise networking. But the problem is this, right? We are going to be stuck for a while somewhere in between L3, L4, and L5, depending on comfort zone, because we are still not ready to cede control. I drive a Tesla that's full self-drive, but I don't let my car drive. I just don't have that confidence. I talk about one person and his car. Now we are talking about enterprise network and letting AI drive it. So we're going to be stuck somewhere in between, but sufficient to say that AI is taking a center stage on that one. Now I want to ask you this question. You see this person smiling. Would she be smiling if she had only one chopstick? It's very difficult to eat this food with one chopstick. Would you all agree? And that's why I say that it's not all about AI, guys, right? I will tell you right now, great AI cannot fix if you have bad Wi-Fi to start with, right? AI is good, but you need great underlying technology first. Maybe it's great Wi-Fi APs. It could be great switching, great IoT contraption, IT, OT, whatever you want to call it. AI it works when you start with a solid footing, right? That's what I meant. Remember, great AI cannot fix bad Wi-Fi. Okay, I've been telling you about AI can do this, but if you're starting with weak AI Wi-Fi, so what do we offer, right? We offer best of both worlds. when you come to Ruckus, you get a great Wi-Fi. That's what we started with 20 years ago. And now we have one of the best AI stacks in the industry. We continue to maintain our lead in Wi-Fi. So Maureen was generous enough to put a slide that says Wi-Fi 7 certified or Wi-Fi certified 7 devices. She forgot to mention one thing, is that Ruckus Wi-Fi AP is in the Wi-Fi certified 7 test bed. So if you tomorrow want your end client or end device to be Wi-Fi certified 7, you are testing it with Ruckus AP. And we are the only only commercial vendor to be part of that one, right? That's the testament to the technology. We won Innovation of the Year award, beating big name competitors. I'm not going to say it starts with C. Now let's talk about real Wi-Fi 7, okay? We have full Wi-Fi 7 stack, and with that comes all these new buzzwords that you're going to hear. I think somebody mentioned already, MLO, multi-link operations. Logic is very simple, guys. Up till now, the connection between your end client, your phone, your AP, or sorry, your iPad and your AP had just one connection, one lane to go from A to B, right? If there is any disturbance, something happened, guess what? Everybody is stuck. You keep waiting. What MLO is all about is that there are two lanes. Okay? I can either send half the payload here, half here. I can take from here to here. I can redistribute, balance, what have you. And that's a multi-link operation to you in layman's term. What you are seeing here is real tests run in Ruckus Labs. So we introduced interference is 6 gigahertz, and you will see that the throughput does not change. The same thing with loss. Look at this one. You do not see any throughput loss whatsoever. Why? Because, as I mentioned, the load went from one channel to the other one band to other, and you never saw it. This is real life Wi-Fi 7, okay? And everybody is implementing. Our customers are implementing 40% gain in throughput. We are able to reduce latency. Look at the latency at 99th percentile. Only one among 100 packets would see this kind of latency profile, and we got 19x improvement. Latency went down by 19, like 1/19. Okay, I have all the numbers if you like. I know that time's up, but the point here being, with Ruckus, you not only get great Wi-Fi APs or Wi-Fi from hardware, you are getting AI-driven management and control apparatus that delivers to you AI, that has AI engine at the heart of it, okay? And here are the real-life benefits of our AI. Right side, on right side here, what you see is one of our MSP partners, these are some of the benefits that they are deriving. If you see here, mean time to identification. If you're in IT, you already know what this means. And we delivered the lowest one of all. And here are some of the industry recognition as a testament to what we are putting together. And something to tickle you guys, we are not stopping anytime soon. Some of the things that we have already put into our apparatus right here. Thank you so much.
Thank you. I got a bit worried when you said you're not stopping anytime soon, because I was hovering by the side of the stage hoping it was going to wrap up. But do we have any questions? Yes. Tunchai in the front row.
Could you please share your intuition on this particular niche where it's a small enterprise use case or a small business?
There's a microphone coming, I think.
Thank you. How do you see the advances in Wi-Fi 7 and especially AI might be pushed down to the lower end of the market, right? So where this residential and small company and maybe the enterprise use cases kind of blur. Because I think that's an interesting test bed for a lot of mix of consumer-like behavior and enterprise. So do you guys see any advances coming in that particular niche use case?
We do. In fact, if you follow Ruckus, you would realize that exactly a month ago, we launched a line of Pro AV, professional AV, in Pro AV market with AI-driven solution for Wi-Fi. So I absolutely see we are in that market, but not home Wi-Fi market. It's a notch above that. So if it can come to Pro AV, it will get there. All the benefits of AI and Wi-Fi 7.
Okay, great. Thank you. I think I see another question in the middle of the room. I'm going to steal 30 seconds while we're getting the mic there. We talked about Wi-Fi and AI. Obviously, Wi-Fi is interoperable. Will Wi-Fi AI be interoperable? Are we going to see multi-vendor AI?
All right. So am I taking your question or am I answering yours?
Okay,
I'm open to both.
Come back to mine.
Yes, please.
My question is, in order to use AI, you need also a target. How do you communicate to your system? What is the target it has to look for? Because otherwise it starts looking around, changes. But how do you define the targets, possibly, which the AI needs in order to run?
Okay, so let me understand. Question is, how do you define the target that AI should be pointed at? See, that's the beauty of AI. It does not need to have a target in mind. If you had a target in mind, you could probably write if this then else, right? That says, if something happened to Tiago, do this, or if something happened to Mithil, do that. Myself being a target. The beauty of AI is that the whole contraption, your every network element, right? The system is sucking in telemetry in order to identify as to things are going wrong, where are they going wrong, how are they going wrong, how to fix it. Or on the other hand, if everything is good, it says, I still see there is an opportunity to optimize. That's the, and I did not even pay this gentleman to ask this question, but that's the beauty of AI, where you don't need to have a target in your system. It has a 360-degree view of your system at every single time, and that's why you are also just, let me give you a little more color on that one, is that you are going to see every vendor complain about, oh, I cannot be selling this for cheap. The reason is very simple. When you are collecting telemetry, sending it to cloud or to edge, crunch those numbers or those data points and make a recommendation, it's a costly operation because you are sucking in so much and you are delivering the goodness without having told this is the target. And that's also the beauty of intent-based networking under AI that says, my objective is to make everybody happy by taking in as many end clients as possible. No target in mind, no nothing. Then AI does the thing. Or my objective is very clear. I have few people, but I want to deliver them best experience. Remove all the hurdles. No target.
Thank you, and you've managed to escape answering my question because we're out of time. So with that, I'd like everyone to thank Mittal, and I'll pick up with you later on.
Thank you, everyone.
Thanks.
Thanks, man.
Thank you. Right, I'd now like to welcome some guest speakers to the stage from a company in Japan called Wire and Wireless, to talk about adoption of open roaming in Japan. Gentlemen. Thanks.
Hi, Hi, hello everybody. I'm Hiroshi Kiji of Wire and Wireless. Thank you for the opportunity of making presentation about the situation of open roaming in Japan. And also thank you for your attendance. In our presentation, first I will talk about the business issues, and after that, now to my colleague, will make explanation about technical matters. So let us start our presentation from the brief introduction of our company. Wire and Wireless is a Japanese operator belonging to the KDDI group As you may know, KDDI is the second largest mobile carrier in Japan. And actually, Y2 has 15 years business experience in Wi-Fi. So 10 years shorter than Wi-Fi Alliance. I know it today. And we have, as a result of that, we have several business domains in Wi-Fi. But today, I just talk about the public Wi-Fi deployment business, because this is closely related to open roaming. So, sorry, this is colorful and some stickers written in Japanese. But assets we have in the public Wi-Fi market is actually we have more than 100,000 hotspots in Japan, and also have more than 300 location owners clients. And we are in second position in the Japanese public Wi-Fi market. So we think those assets are very valuable and important because this has a potential demand to migrate to open roaming. And market situation on public Wi-Fi in Japan, in short, it's rather active and considered to continue growing. And there are several reasons here shown in blue, but actually open roaming is one of key factors to grow. And the situation of the expansion of open roaming by our company, Y2 has acted as a first mover of open roaming in Japan. And actually now our sales team is making proposal open roaming aggressively to become #1 in public Wi-Fi market. So as a result of that, we have in total 12 cities contract, which includes Tokyo and Osaka. As you know, Tokyo and Osaka is the two biggest mega cities in Japan. And apart from the business with regional government, we already started Auto Connect free Wi-Fi service with Starbucks Japan. And this service is provided by native application of Starbucks and Passpoint technology. Unfortunately, this is not open roaming. Actually, we proposed, of course, open roaming, but guys of Starbucks says automatic connection by native application is enough at this moment for their customer satisfaction. Open roaming is too much. So now this type of service we introduced. And let's move to on project in Tokyo and Osaka. First, Tokyo. Open roaming Wi-Fi deployment is one of the main projects of the Tokyo Metropolitan Government's strategic policy, Tokyo Data Highway. So objective of this project is to build up secondary wireless network, independently managed and separated from a cellular network governed by mobile carriers, to utilize freely and multidimensionally in Tokyo Data Highway project. In this project, our company provides IDP, and access networks are provided by various operators. Of course, our company, Y&W Wireless, is one of the major provider of access network too. And the goal of this project is implementation of the 1,300 location deployment by end of next year. So location is shown here in the picture: hospitals, library, community centers, high school, university, sports complexes, and stadium, and other facilities managed by Tokyo government. And And some part of the deployment will be made by conversion from the conventional Wi-Fi, existing conventional Wi-Fi. And project in Osaka. As you may know, Osaka is the host city of the World Expo 2025. So Osaka regional government has announced conventional Osaka free Wi-Fi service should be upgraded by introduction of open roaming and relocation of the place of the hotspots. And the objective of this project is to support of the internet connection of the tourists to Expo 2025. In this project Y2, our company also provides IDP, and in case of Osaka, we provide also access network of first phase. So concept of the first phase deployment is 3 places. First one is venue of Expo. Second one is a gateway facility of Osaka. It means a Kansai International Airport. This is a gateway to overseas. And Shin Osaka Station is a high-speed railway station. And the third one is transportation from gateway to venue. But actually, it's impossible to cover all transportation from gateway to venue, so we're focusing on the limousine buses and junction station of metro. We picked up 10 stations shown in purple. Okay, and issues remained. As I mentioned about, as I talked, open roaming project is now ongoing. Several projects is now ongoing in Japan, but we still have issues to be addressed. I indicate here 4 basic points. First one is to make open roaming more popular. Unfortunately, the recognition rate of open roaming among consumers is still low. And second one is to increase open roaming hotspots. In particular, we have to expand the private sector. First priority is coffee shops. And third one is increase of quantity of users and authentications. This is very important to drive the data business. And the fourth one is additional value easily comprehended by location owner clients to upgrade or to newly deployed open roaming. So recently we're focusing on the development of the visit detection solutions, for example. Anyway, we are looking for to find some hints or a good case example to solve for those matters during this Congress. Thank you very much.
まだ終わらないけど。
あ、そうか。
So to be continued. Hello everyone. So our company operates as both ANP and IDP for Wi-Fi services. This means we provide network infrastructure and user authentication. In addition to the municipal IDPs introduced in the first half of the presentation, we also provide a consumer subscription-based Wi-Fi services such as Gigazo and au Wi-Fi Access. Gigazo and au Wi-Fi Access combined have over 3 million users, while the main areas are non-open roaming. We have made them open roaming compatible as one of the onboarding applications for open roaming. At present, Gigazo and au Wi-Fi Access do not have open roaming enabled by default. We are considering the best approach to integrate open roaming into these services in the future. This graph shows recent trends in authentication numbers and traffic volume for ANP. TMG means Tokyo Streets, and Y2 are the main providers now. So global roaming numbers remain low. However, roaming is growing. Interestingly, traffic volume grows faster than authentication numbers. This indicates high usage by open roaming users. This slide shows the authentication count by realm from outside the Y2. It breaks down the data by realm, excluding the Y2 IDP. Looking at the graph, we can see that realms such as .scjp and Japanese University, and OpenRoaming.net and 3GPP have significantly higher authentication counts compared to others. This suggests that users from these realms are more actively using our open roaming services. Interestingly, we also see a variety of other realms with small but notable authentication count. This diversity indicates that open roaming is being utilized by users from various service providers and regions. This slide shows the time series data for each element. This is short-term data, so we can't make a final conclusion yet. We need to observe this data for a longer period. We will continue monitoring this data to understand long-term trends. This slide compares traffic in traditional free Wi-Fi area with open roaming areas. We observe this trend when transitioning from traditional free Wi-Fi to open roaming. Open roaming areas have about twice the average traffic of traditional free Wi-Fi areas. This suggests that the convenience and security of open roaming encourage more use. This could lead to better Wi-Fi networks, smarter investment, and improved user experience. Now, let's look at the current numbers. This graph shows the open roaming share of total Y2 traffic. To be honest, the open roaming share is still small. It's less than 1% for the authentication numbers and traffic volumes. However, we should see this as an opportunity for growth, not a problem. To increase these numbers, it's important for our industry as a whole to work together. We should focus on educating the users about the benefit of open roaming, expanding the partnership across the sector, improving infrastructures, and enhancing the overall user experience. The goal should be steady growth for open roaming adoption across the industry. A Japanese government survey found that over 60% of people avoid the free Wi-Fi due to security concerns. Open roaming addresses this issue and offers a safer, more convenient network experience. Creating a network that is user-friendly and secure is crucial for our digital society. Open roaming is a significant step towards this goal. We aim to maximize the potential of this technology and create a new era of Wi-Fi with all of you. Let's work together to build a better connected world. Thank you for your attention.
Thank you very much. Thank you, thank you. And I love on that last slide that the number one security concern was a vague sense of unease. which I'm going to be quoting that. I think that's fine. It's an interesting challenge of how one combats that. Maybe the panel might address that when we're going to go to. But thank you very much. Are there any urgent questions, or shall I press on to the panel for time reasons? Hopefully, are you going to be around for a little bit longer if people have questions over lunch? Are you here?
Yeah, later.
Yeah, great, thank you. Okay, with that, I'd like to invite now the panelists up to the stage for the remainder of this session. We're going to be having 5 people to discuss various of the key issues around Wi-Fi 7, some spectrum issues, and related themes. So please take your seats. Actually, we've got 6, so I might... Oh, we've actually got a timer as well. So, even more useful, everyone's, well, almost sat in the same line as the names on the screen. Not quite, but we'll work that out. You've already met, if you were here, actually, can I get a show of hands? Who was here this morning for the earlier sessions? So that's most people, but I think that I'll probably still get people to do some quick intros. So, you already heard from Metin Taskin, Matt McPherson, and Eric McLaughlin. But what I'd quite like to do is get the new people on the stage, so Brian and then Doriana, to do a quick sort of introduction of who you are and what your role is in Wi-Fi. And then Doriana, I know you also have a presentation as well, so I'll get you to come up in a second or so. Brian, if I'll kick off at this end.
Hi, everybody. Brian Shields from Boingo Wireless. I manage the software division at Boingo. Our teams manage the portals, authentication services, as well as the controller, software-defined network controller, as well as a lot of data collection. So my experience and my team's experience is more on the back end.
Hi, good morning, everyone. I'm Doriana Guiducci from the European Communications Office. I work for the CPT, the European, let's say, body for development of regulation in the 6 GHz, and I'm the spectrum expert in the various groups in Europe dealing with the development of technical studies and the regulation for 6 GHz band.
Doriana, if you'd like to go through your slides, that's probably good. And I know over the last couple of days, there's a few the European MNO operator CEOs, and I think GSMA have come out with some fairly demanding claims on 6 GHz, but we can maybe address those as well in the panel. But if the clicker is up here, but, or if you prefer, I can give you.
That's okay. I guess I can use this microphone.
Not sure, actually.
Yes.
Yeah.
Apparently. Okay, so. So very, very quickly, I have just a couple of slides to explain probably who we are. For the first thing, not always very easy how regulation is developed in Europe. And I work for the European Communication Office, which is the technical secretariat of the CPT. CPT is the Conference of Administrations for Telecommunication and Postal Services of 46 countries. So it's a little bit wider than the European Commission, and what we do is to promote harmonization in the communication sector and radio spectrum. What we also do within Europe in this, let's say, geographical sense is to conduct studies for the development of regulation dealing with spectrum, radio frequencies, and also to develop regulation, decision, recommendation, whatever we talk about, and these also form the basis for the consequent regulation in the Union. So just to explain that I'm not from the European Commission and the European Union. Sometimes it's a little bit confusing. And I think I've already covered this just to explain, as I said, we are part of the European framework, but we are different entities. And coming to the 6 GHz band, what I have here is simply a timeline to show that I've been working quite for long on the 6 GHz band. We started a few years ago on the lower part of the 6 gigahertz from 5945 to 6425 megahertz. And we have different groups doing different things in Europe. Basically, the different colors represent the activities in those groups. That's just to show that it's a little bit of a kind of articulated work. But to simplify that, the process is always the same. We start with technical studies, addressing basically coexistence issues with incumbent services or services that, or users that want to use the band as newcomers. And then based on the results of those technical studies, we develop the regulation for that. And as I said, we already did this process for the lower 6 gigahertz band, starting actually in 2017, many years ago. And for this band, we have a decision that regulates how to use the band for Wasserlan in the CPT and also in the Union, because as I said, the same process is then mirrored by the European Commission and develop decisions that are binding for the member states, of course. We are still working on this decision, actually, because we developed conditions in 2021, late 2000, and those conditions were for very low power devices and also LPI and VLP. And we are now considering if some of the limits that for very low power devices can be relaxed, I would say. And this is still ongoing, and the main issue, just for information, is the protection of different service operating in a different band, in adjacent band, which is urban rail, which is used in a few cities in Europe, including Paris. So this is what we are doing for the lower 6 gigahertz band. Then coming to the, I would say, juicy part, you always call it this way, the upper 6 gigahertz band. We started working on that, I would say, 2023, late 2022, first considering the issues, the possible coexistence issues that we might have with the incumbent services. And on that, we have just approved a report that gives the outcome of the studies, and it's under public consultation. And this is one part of the work done in a group, and then we have a different group which has started working on the coexistence studies between Wasserlan and IMT. To simplify, we use a different abbreviation in CPT, but that's what we mean, of course. And on that, the studies should be ready by the beginning of next year. And just to note, we haven't started yet any regulatory process, but mostly because we are waiting and are expecting, waiting is not really the right word, expecting a mandate from the European Commission, which is going to task specific studies, and most probably those studies are very much consistent with what we have already been doing, so we are a little bit ahead of schedule on this. And then, of course, this will define also the future regulatory process. And there's a lot of work to do. Also, studies are quite complex, as we all know. We are considering in the technical studies now many different situations and scenarios for the shared use of the 6 gigahertz band, assuming different uses for Wasserlan indoor and also for IMT indoor and outdoor, and considering if we need restrictions in terms of powers for mobile networks, if we need sharing mechanisms, if we need new sharing mechanisms, or if we can rely on, let's say, mechanisms based on existing ones. So there is still a lot to do, and as you may see on the timeline, it's actually a long process. Sometimes we think that things can be done quite, let's say, quickly, but not always the case. But we are on that, and we are actually progressing, and we do have results along the way. But those results can also be, you know, regulation is a live thing, so can be also, actually, it has to be improved along the way. And I think that's more or less what we're doing, just to give information where we are. Thank you.
Thank you very much. Thank you. So, just to give a little bit of context on that, so where we are with 6 gigahertz is globally, a number of countries, including US, Canada, many in Latin America, and also some in Asia, so one last week from Kazakhstan, have given the whole band of 6 gigahertz, which is 1200 megahertz for unlicensed use. China is probably the leading, most obvious one, which is trying to get that band just for 5G for licensed, what's called IMT use. Many other countries have licensed given the lower part of the band for unlicensed use that Wi-Fi uses, and then Europe is looking at this thing called dynamic sharing or hybrid sharing for the upper part of the band. It ties into a broader trend I'm seeing in looking at new forms of network sharing model in different bands in different countries. One of the things I've been trying to do is trying to get everyone talking about sharing to start at least talking the same language, but that's perhaps a topic for another day. So maybe we just sort of kick off finally with sort of Eric, Matt, and forgot the name. It's terrible.
Metin.
30 seconds each on intro, and then I'll dive into questions.
All right. Shall I start?
Go for it.
All right. I'm Metin Taskin. I'm the CEO and founder of AirTies. As AirTies, we are focusing on home Wi-Fi network optimization and diagnostics and data analytics system. We work with service providers exclusively, and we help them improve their broadband business by using our software tools.
And, Matt McPherson, I'm the wireless CTO at Cisco, and we've deployed a few networks.
Eric McLaughlin, I'm the VP and GM of the Wireless Solutions Group at Intel, and we've deployed several billion clients.
Yeah. So I mean, we've heard a lot about Wi-Fi 7 today. Where are we? I mean, obviously it's certified earlier in the year, but particularly in Europe, is it actually taking off, and what's it being used for? Anyone like to, Metin, are you seeing it cropping up on your dashboards, for example?
I can talk from residential Wi-Fi perspective, definitely taking off. One thing that I will say, Wi-Fi 6E was taking off and stopped as soon as the people started hearing Wi-Fi 7 is coming, and all the projects turned into Wi-Fi 7 projects. The ones that didn't deploy basically stopped dealing with it, and they basically started Wi-Fi 7. But Wi-Fi 7 is definitely taking off. We have multiple customers who are already deployed or getting very close to deployments. And of course, it will take time to replenish the install base and have more networks supporting Wi-Fi 7, but that typically goes quite fast with the residential market.
Great, thank you. And Eric, I mean, in terms of Intel devices and sort of laptops that you see, how fast is Wi-Fi 7 diffusing through the ranges?
It's actually growing faster than 6. So we see at this point, we launched our first product about a year and a half, a little over a year ago. We're on our second generation this month, just launched here in October. And we see about 600 total devices, not just PC, but phone, APs, etc. To put it in perspective, at this point in Wi-Fi 6, we're about 160 devices worldwide. And right now, Wi-Fi 6 has over 4,000 devices worldwide certified and working.
Right, okay, thanks. Actually, Matt, what are you seeing from Cisco's point of view? Are companies deploying 7? Are they using it? Are they using any of the fancy stuff you were talking about this morning?
So, I mean, the way I look at it is it's not unusual that I think the home and the consumer market takes off first. And I think oftentimes what you see is that there's a subset of features that are usually implemented on that. So it's easy to go to the next nomiker, Wi-Fi 7, and show some of the benefits, I think, in the home market. In the enterprise market, it lags a little bit because we have to go through all the full certification capabilities. And of course, there's a life cycle when it comes to our customers and when they deploy and when did they deploy last. So, just a comment on 6E, we were seeing a lot of 6E that's being deployed, and it was definitely overcoming some of the 6 that was going out there. But I really believe that what's going to happen with 7 is that 7 is going to drive 6 gigahertz adoption even more. 6E was to do it, but I think 7 with some of these new features are really going to push that adoption of the full 6 gigahertz.
And are you seeing that even with the only the lower 6 available in Europe, that's getting traction either with 6E or 7?
Yeah. So I look at it 2 ways. I think a lot of times when we talk about regulatory, we take into account what you might need in the home, and sometimes you might say something like, well, do you really need all of that spectrum when your backhaul is not actually going to give you that type of capacity? But we look at it from an enterprise. I mean, the second most largest use of Wi-Fi is in the enterprise and in the work environment. Home dominates, and then you have your workplace is the second most common place to use it. And when you talk about the enterprise environment, it's quite different because we're using the full range of spectrum, not for an AP or a couple of mesh APs. We're putting in hundreds, thousands, if not tens of thousands of devices. And when we do that, we have to do a radio resource management plan. And to do that radio resource management plan so that we're not interfering with each other in places like this, that what we have to do is we have to separate out spectrum. And so if we want to hit those higher bandwidths in an enterprise or in a venue like this, we're going to use that whole spectrum to get to those wider channels. And so this is a conversation that I think is oftentimes overlooked because the enterprise doesn't have a WAN bottleneck like the home does. They will put in as much capacity as they need for what they need to achieve for that particular enterprise for productivity. So if you take that into account, can we use the full 1200 megahertz? We absolutely can. Will we take the lower spectrum? We absolutely will. But there is going to be a difference on what you're going to achieve in peak rates.
Thank you. Doriana, is that something that you've looked at? Is how much of what's the early demand for lower 6? Is that something that's being factored into the discussions at ECO?
I would say that's demand is taken into account and is not taken into account explicitly, I would say, because of course we always start with use case scenarios, and use case scenarios, they go together with demand, of course. And then we translate that into technical studies, so that's the way we work. But certainly the demand for spectrum is the basis for development of that, And also, I would say also to define a little bit the timeline of, because we try to do our best to meet the timeline for, to have the regulation ready, because technology is coming and there are, of course, there is concurrent demand. That's actually the problem, of course, both from incumbents and from new users. You mentioned the MNO, of course, for the 6 gigahertz band, it's a very heated debate. But certainly demand is the starting point.
Thank you. Brian, from your point of view, we heard that Boingo is deploying Wi-Fi 7. Is it being used in anger yet? So, sort of.
Well, our Wi-Fi 7 network is deployed in, as Derek mentioned in his keynote, that we have it deployed in the Las Vegas Innovation Center. Yeah. And so it's being used right now at the Mobile World Congress. Besides that, we have 6E deployments. We actually have a large number of 6E deployments, but that's so far, that's the limited deployment in Vegas, and we're also waiting for consumer demand and devices to come on.
I guess I'll have to wait for the press release coming out after MWC that obviously will presumably have CTIA in its sights as to actually we used it this amount. But,
yeah, it'll be interesting to see.
I think there's some interesting options there. Yeah. Okay, so to sort of, rather than sort of go drill down right now on the sort of spectrum aspects, so I'll come back to that in a bit. What are the sort of key? Is it the enterprise or residential market that is really the driver of enhancements on whether it's Wi-Fi 7, future Wi-Fi 8. What's driving the industry? Is it historically it was enterprise led? Now it seems to be more operators. Anyone want to take that?
I can talk from the residential perspective. I think, in my mind, both. What Wi-Fi defines is the physical layer, the pipe, basically, and both enterprise and home requires the full pipe and shares with many different devices in the home or in the enterprise. So if you look at the Wi-Fi Alliance members, both of them there, chip vendors are there, manufacturers are there. So it is really interest of both markets, I should say.
Is there any correlation on the residential side with fiber deployment and what that means in terms of what types of Wi-Fi or the use of Wi-Fi?
Yes, definitely. I mean, with fiber, you get really fast broadband speeds. But even if your broadband, unless you have a 10 megabit per second internet, maybe it doesn't matter. But even in the DSL range or the cable or the fiber, you have 100 megabit per second or above. Wi-Fi still can become bottleneck and create this user experience issues. So fiber definitely is the biggest driver because you get gigabit, multi-gigabit now. Even 10 gigabit services are starting to appear in the residential market. Wi-Fi bottleneck is always there if you have fiber, but people are not so much interested in speed anymore. They're interested in reliability and the connectivity and the range and the coverage. So that is where Wi-Fi needs to be, providing that because most of the time that's the weakest link in the whole end-to-end broadband service. So this is why I think more spectrum, better technology, better connectivity is important to basically improve the user experience. Not everything is about speed. Speed is less important now.
I mean, possibly uplink is becoming more important, especially if they're moving from cable to fiber, but because the uplink is less limited. But Eric,
I think your question is a good one, and I guess in thinking about it quickly, I think users are driving, not enterprise, not consumer. That line's actually blurring a lot. How many here work full-time in an office anymore? Right? We're all working, you and me, okay. So I'm there 5 days a week, I admit it, but we're very unusual, right? And the office is everywhere. And the user who's an office worker is also a consumer. So I think the users are demanding these features, these capabilities, and all of us here from chipset to, to devices to products have to respond to that and deliver all of the things that we talked about just now that Matt explained.
On this, maybe I would just like to offer a different perspective from the regulatory point of view, because sometimes when we talk about regulation, we start when the systems are not there, or technologies are not ready, or are they just coming. So what we do is actually, the driver for us is innovation itself. Because, we usually work in terms of forecasts, of predictions, that sometimes they do not really fulfill themselves as they present themselves. But then the important thing is that we start this process and we pursue this, because this can lead to some, let's say, some kind of forward-looking approaches. Even talking about sharing, for instance, we've been talking about sharing for many, many years, and one might also argue that it's not really there yet, but it doesn't really matter. We need to do that, at some point. We will be able to do that because we have started when we were predicting something.
Actually on that, spectrum sharing is going to be absolutely essential for future bands. There's a lot of discussion at the moment. I was in the US at a spectrum event last week around the 7 to 8 gigahertz band, which was identified at the World Radio Congress as possible future 6G band for IMT. But also, I noticed last week the Wi-Fi industry is starting to talk about 7.1 to 8.4 as possible next horizon for Wi-Fi, and that's going to have to be shared because it has some incumbents that are difficult to move, notably NATO. which is going to be, I've been to a couple of events recently with NATO speakers on spectrum panels, which has been very interesting and sort of understanding the use for defense purposes. So we're going to need more sharing in the future, so we might as well start now, seems to be the logic. And if you can't share it in 6, then we've got real problems. On sharing, actually, Brian, the US is interesting because you've also got shared spectrum for CBRS as well. So you've got private wireless, or CBRS can be used as an extension by the operators. Are you seeing any trends around how that fits into the Wi-Fi story? Are people preferentially offloading to CBRS rather than Wi-Fi, or what are the dynamics there?
They're working in parallel, and it depends on the use cases. Our core is built into our alongside our Wi-Fi core as well, and so we've got it built into all the automation. So we're really focused on getting those converged even further so that we can see clients moving from one network to the next. But for now, they're kind of working hand in hand.
Okay. One of the things that Europe has, perhaps different to the US, is a lot of people living in what are called multi-dwelling units, MDUs or apartment blocks, which obviously have a lot high density of people and users and devices if you've got lots of separate apartments and the walls are potentially not that great for isolating one from the other. How does that factor into design of networks, the experience, and I suppose the regulatory aspect is do you consider sort of MDUs separately to single-family homes? I'll fire that down the line. Matthew, maybe you've got a thought on the...
That's not my area.
No, but presumably from a user experience point of view, do you see differences between people living in apartments where they're like quite dense together versus individual houses?
Yeah, so I mean, so now I can talk about that one. When there's apartments and every apartment has individual broadband connection, yes, then you have every apartment has a router, has Wi-Fi, sometimes even extensions, because some apartments could be large or thick walls and things like that. So the problem space changes a bit. It becomes more about interference and spectrum sharing. That becomes the main issue, and in that case, you need to manage the operating channels of Wi-Fi very properly. But there is another, this is why I said this is not my area. There's another way of deploying broadband in these MDUs is you're not giving everyone a broadband line, you're giving apartment, the whole building, a broadband line, and then you have almost like an enterprise Wi-Fi network where you have access points not inside the homes, in the corridors or whatever they're installed. So that I think Matt can comment much better than I do.
Yeah, I guess a couple comments. So, as far as the sharing, I just wanted to throw one little addition out there. When we talk about sharing, if you look at CBRS, it allows you to share across different use cases, but you're going to be running, LTE, or you're going to be running 5G in it. And what I'd like to see going forward when it comes to LLS, lightly, used spectrum, is that it would not have a stack dependency. Right. So one of the things that I didn't appreciate about the CBRS effort, although I think it was good as far as developing a lot of work around SAS, et cetera, is that they were allocating channels in 10 megahertz pieces, which was not conducive to a Wi-Fi stack. And if you asked for 20 megahertz, you might get 2 discontiguous pieces of spectrum. And if that happens, you can't put a Wi-Fi stack there because Wi-Fi doesn't do channel bonding. Right, so we've had some, discussions with the regulators, and should we make some changes in some of these types of things. But I think as we allocate this spectrum, especially in this range where, do we want to do a licensed piece of spectrum or something that you register or something that uses some central cloud database? What you want to do is make sure that you could apply different stacks to it, so the use case actually pulls how you want to use that spectrum, as opposed to the way that it was regulated prevents it.
So basically the spectrum management should take into account different stacks.
Exactly.
Or potentially different stacks should take into account spectrum management.
Yeah, they have to go both ways, right? So it's going to work both ways. Now, as far as the multi-dwelling unit, I've seen it implemented a couple different ways. So sometimes what happens is you go into a multi-dwelling unit, and Boingo has good examples of this for like military and whatnot, where you manage the multi-dwelling unit, in which case you have complete control over how the spectrum is used, and you can divide it up very similar to what you would do in an enterprise. Now, a lot of multi-dwelling units, if we're talking about an apartment complex, it's very different because people can put in their own stuff. And what I've noticed is that when you put in these home-type APs, what they'll do is they'll look when they go to allocate their spectrum, they'll try to avoid it, and then they'll try to go to the cleanest spectrum as possible. Now, a lot of these implementations are not real-time. In an enterprise system, for example, if interference changes, we'll actually manipulate how we use the spectrum, the channels, et cetera, to accommodate it. Oftentimes in these home environments, you don't see it. In fact, sometimes when you put in these mesh systems, they get kind of gluttonous about spectrum because they're using spectrum between the mesh nodes, and they're also using different spectrum for each node you put in. And so you get this experience where as you start to see this in multi-dwelling units, that there's this constant contention in spectrum. Now, that doesn't mean it won't work, it does, but what it means is that it moves away from this predictable experience and more into best effort again. And so we can do things in the industry to improve upon that. And we're doing some research areas in the WFA, WBA, Cisco labs, where we're saying, hey, as we allocate this spectrum, what we should do is we should do it more cooperatively. And by the way, I know that we're talking about 802.11, but keep in mind, 15.4 technologies are going in here. Things like Thread and Matter. You got Bluetooth that's going up into the 6 gigahertz now for these new sets of use cases. So you got 15.1 radio going in there, and so what you're gonna see is more and more contention. So I think the industry has a lot to do between regulatory and how we can use this spectrum and the standards on how we optimize that use. And I think this starts to get a little bit into the area of AI, because I think AI can solve some of these problems. But this is definitely an area of work.
Yeah, I tend to agree.
Yeah, and I would say also on the MDU side, we do manage the networks, and that becomes a challenge for a lot of the servicemen and women in the dorms and barracks where they're video game players. They're hanging out in their dorms, and that's where they spend most of their off time is playing video games, and they're all first-person shooters. They need low latency and high throughput, and that's a challenge. So that's really what we're looking for as an improvement that will come with Wi-Fi 7.
I mean, one of the challenges I'm seeing is that increasingly people will bring their own, they'll get a fixed wireless unit from a mobile carrier, which has got Wi-Fi on the inside. Increasingly it's using Wi-Fi 7, and that's completely unmanageable or uncoordinatable with the sort of built-in, whether it's a single network or the individual homes. We could carry on talking, but we're running a little bit late, and I know people probably want some lunch soon. I can't say that I'm standing between you and lunch, because if not, I'd have to be over by the door. What I would ask you, though, is do you have any questions to the panel? We've got Tunchai. See if there's a microphone I can get round. All right, we're going to steal one of your microphones and donate it.
Who's the first one?
It's Tunchai in the front row.
Thank you. So I just want to ask a question about continuing on the topic of better coordination, let's say, right, and sharing. So could you please, and this for everybody, mostly for Matt and I guess Eric, because you guys had mentioned billions of devices and a couple of networks. What is it that needs to happen to better share experiences, information, or solve the problem regarding the QoS, right? I'm specifically referring to the user preference plus the prioritization scheme that enterprise grade Wi-Fi has, but we're lacking that mostly on the Wi-Fi, right? So and also the bugs that got unreported, right, on Wi-Fi. So the real work of the Wi-Fi engineer is to call his buddy at company X, hey, are you aware of this bug? And this kind of gets, put under the carpet, but this is the real, those two things are the real source of friction and disconnects and contention, right? So we talked about the, the frequencies that can get opened up, etc. But there's another form of information sharing or coordination that may actually give another boost to quality. So what is your gut feeling about what is it that we have to change, what we need to do to attack these problems? Because it's about time, right? So this is not a technology problem anymore. It's a contention among, I guess, some players.
Yeah, I think this is a great question. So I used to say the difference between licensed and unlicensed was that in licensed, you have complete control over the spectrum, so you don't have to worry about it. You manage yourself. In unlicensed, one way to look at it is to say it's controlled by real estate. So for example, in an enterprise environment, the enterprise has complete control over what's deployed in that environment. And if somebody induces interference, well, it's their building, they can go shut it off, right? And if you can do that, and if you're within a single management domain, there's ways to design these networks. The problem is that when you get into these environments, like a mall or a multi-dwelling unit, where you have different uses of the spectrum and you have multiple management domains within range of each other. And when that happens, then the typical way that we work in unlicensed is we have a contention-based protocol that's listen before talk, right? And what happens is that everybody just goes, oh, we're going to do this regulatory and we're going to set these rules up, and then we're going to let all this stuff come into the spectrum, and everyone will just do listen before talk. And this conversation is actually happening with the Bluetooth community right now, because Bluetooth, nothing against Bluetooth, I love Bluetooth, by the way, but Bluetooth was just stomping on us in 2.4, and we didn't want that to happen in 6 gigahertz, and so what we're doing is implementing a contention-based protocol. So what I'd really like to see going forward is a next step to that. So the question is do we need new contention-based capabilities beyond what we currently have? And the fact of the matter is that if you're in the domain of 802.11, then you can do things like preamble detect. If you can do preamble detect, then you can interpret bits. If you can interpret bits, then you can send information element. And if you can do that, then you can better coordinate that spectrum amongst the players. Now, I'll try to be quick.
Yeah.
But so where you are, though, then, is that if there's multiple users, what if there's contention? What if the multiple users want to consume more than you have available to you on the air? Then how do you apply a policy across multiple management domains? That's harder. Cisco's looked at that for a long time. Can you do cloud-based radio resource management and things like that? The answer is technologically yes, but it turns into a business problem.
I would say that one of the things that I think we should be looking at is coordination between the managers, as in basically they speak to each other and say, you're the store owner, I'm the mall owner, we need to work together. But that's a discussion for another time.
Yeah. Well, what I would add is that there's this industry has got a surprising amount of cooperation that goes on way behind the scenes, right? Chipset manufacturers, I talked to Broadcom, I talked to Qualcomm, I talked to MediaTek, I talked to others. We do co-engineering work sometimes, on the standards, make sure that everything that is being implemented, whether it's optional or required, works. And we start things that just, one thing people don't always understand on the chipset side is we start doing things 4 years before you see it, right? And so that requires an amazing amount of coordination up front in the IEEE standard, spectrum, everything, in order to come out with a chipset on time for the standard that actually meets all those requirements and does interoperability. So a lot of the work you're talking about and that Matt's talking about is stuff that we do in labs 4 years before it even starts. More work to do, though.
I need to wrap up in very quickly, but we've got at least 2 questions. If you are going to take both questions and give everyone 8 seconds each to reply to both of them. Andy at the back.
It's going to be difficult on my question, I think. My question would be, we've seen a lot of literature recently from the IMT community saying why they need access to mid-band spectrum, including the upper 6 gig band in the future, and what it would mean to them if they didn't get access to that spectrum. I suppose the question would be for the panel is, if Wi-Fi only had access to 500 megahertz in Europe in that spectrum and didn't have access to any more mid-band spectrum, would that impact things like the latency that could be delivered by Wi-Fi long term? And then what's the alternative going forward, and what would be the cost to Europe PLC in kind of short term, long term, of not having that spectrum available?
Okay, so that's a question on what's the economic hit if we can't give the top 700 to Wi-Fi. And there's a question here, I'll take them both simultaneously. So it's just the second row here.
Yeah, it's kind of related actually topics. So, Doriana, sorry if I said your name correctly there. You talked about IMT and Wi-Fi coexistence. So in that world, the priority is always given to IMT. So I'm curious a little bit about, the efficiency and the efficacy of that on the Wi-Fi band and usability in the Wi-Fi in that band. And a related question to that quickly, just how all of this impacts the Wi-Fi ecosystem in terms of cost and scale. The major benefits on Wi-Fi has always been common adoption around the world that gives it scale and cost efficiency. Now it starts to get fragmented in terms of spectrum, but also complicated in terms of coexistence costs and features and capabilities. So how does that drive the costs impact?
A couple of very, very, very quick responses. Doriana.
Yes, I wouldn't start, let's say, assuming that IMT will get priority, because we do not know yet, so we are still discussing that. Of course, it's still too early to understand. But certainly the sharing framework that we are expecting is not easy. And also to, let's say, to make a link to what was said just now, I mean, it's complex. We don't have a solution. Even if we find a solution, it is not only about regulation, and it's also about standards. That's actually quite important. It's supposed to mention here. But, the cost is, I would say, a political question, of course. This kind of decision has to be made by policymakers. It's one of the elements of the equation, of course. And everybody can understand easily that if a technology doesn't have spectrum, it will be a cost, additional cost. It can be also very burdensome to achieve certain results. So it's a kind of balance that we need to find, and it is always about that. It's also about, but this is also why I think at this point the role of sharing is kind of crucial. I mean, we've always spoken about sharing, also between technologies like IEEE based and IMT based, but not really achieving a very good, let's say, finding very good solutions in terms of sharing. We had to work around those.
Yeah, we are going to, everyone else, 5 seconds, yes. Last comment.
So one of the advantages to Wi-Fi for many, many years is harmonized spectrum. When you don't harmonize spectrum, chipsets become way more expensive, front ends become way more expensive, right? And we're talking dollars, not pennies. And so, huge sharing is much easier. A lot of that stuff can be done in other parts of the stack and don't have to be hardware related specifically. So to your question on cost, it's exponentially impactful the more we fragment spectrum for these radios.
I think we're going to have to sort of pause it there and pick up conversations over lunch. I'd like everyone to thank the panel, and thank you for your patience as well. Thank you. Thank you all. Cheers.
Well, good afternoon, everybody. The select few, those who didn't stand in a long, long queue by the look of it, apart from a couple who've clearly got some
some food, but thanks for coming back in. My name's Steve Andrews. I've been involved in the industry some 30 plus years. Also, I was part of the founding teams who set up the WBA when it was about 20 people. And now you can see fantastic array of involvement, participation. And our vision was always about the experience of customers. A lot of industry bodies focus on tech. We were, how do we link and create, which you've heard a lot about this morning, a fantastic experience for consumers, for businesses, and make sure that the best tech is applied to it. So this next topic that we're covering is very much focused on the home. It's focused on the connected home. We have a series of speakers who are going to really all talk about that experience side of our industry. And then we're going to have a panel where you get your opportunity to challenge, question, and obviously give your views as well. And we're going to aim for about 3:20 to finish so that you've got it in your heads what we're doing. So we're going to kick off in a moment with Matt from BT EE. My history at the moment, I'm doing a lot of chairmanship NED work in fixed mobile fiber companies and data centers. I did well over 25 years in exec at BT, so I'm intrigued to see all the great foundations that are evolving from it. And now my interest is very much about building companies and developing companies. But I am a board advisor to WBA. Passion's always been there for Wi-Fi as part of my role in BT as a managing director on fixed and mobile. So without any further ado, I'd like to introduce Matt. Matt is passionate about customer experience. He's had some 15 or so years in the industry pursuing that agenda about innovation, the juxtaposition between tech and experience. And Matt's going to talk us through actually how do you deliver that exceptional customer experience. So thank you, Matt. Thank you for joining us. And do take the stage.
Thanks, Steve. I definitely got the lunch slot, didn't I? Well, welcome to our small and perfectly formed group. It's good to see you, and it's great to be here today. I want to start actually by saying I think we're all pretty lucky, and why am I starting with that? Well, because we all work not just on technology, but this group, members of this alliance, but everyone in the room and everyone dialed in is shaping directly the future of connectivity that doesn't just touch tens of people, touches hundreds of millions of people around the world. And I personally think that's pretty cool. It also means, though, that as operators, we've got huge responsibility to bridge that gap between what is amazing technology and decompose that into the hands and the homes of many people around the world as simply and as contextually as we can. So who am I? My name is Matt Hughes, as Steve said, and I have the privilege of leading the product teams across BT Group's consumer, broadband, and TV businesses, so BT, EE, and PlusNet. And if you'll allow me today, I'd love to share with you a very short story just on how we've launched something that we've called New EE. New because EE is very famous for being a mobile company, less famous for the things we're trying to do with it. Try and make it number one for broadband in the UK. Try and make it more than just a telco and carve out new segments like gaming and some of those exciting new markets. And one of the things that we've really focused on when we designed what we call New EE is the customer experience and very specifically customer needs and how they use our services. So I'll show you this. I've got some of the team in the room who were responsible for building this. On face value, it's a Wi-Fi router, right? Hopefully you agree, a pretty good looking one, but ultimately a Wi-Fi 7 router. Okay, so why am I showing you this? Well, because what it represents and how we designed it from start to finish, from the product to the experiences to the journeys, and ultimately actually the Marcoms campaign that went out on TV has been quite different. And if you think about as Steve said, maybe 15, 16 or so years that I've had in telco, every single product launch, every single router launch has largely centered around a specification. A great specification, this thing's powered by the latest, greatest Wi-Fi 7 technology, 320 megahertz, ultra-wide spectrum, et cetera, But what does that mean to an average customer? What does it mean to the millions of people sitting in homes around the UK? And when we designed New EE and we thought about these experiences, we tried to think about them slightly differently, because if you think about the router and you think about it in the lens of the router and the tech, you come up with pretty cool looking spec sheets that mean a lot to people in this room. But what you miss is how people interact with that router and use it in their everyday life. If you take a look at this is a pretty typical family scene. What really that is people using the router. It's people chatting, it's people streaming, it's people doom scrolling, it's people sitting and watching TV, having a laugh and a joke of an evening with their friends and their family. And these images aren't just stock images. These are genuine customers that we worked with to understand how they use their broadband, how they use their Wi-Fi, and we actually used them in our Marcoms activity. And if you take a very specific use case that I'm sure everyone can relate to and get your head around, it's gaming. And if you think about gaming, it's really easy to generalize and say all gamers need low latency, low ping, low jitter, et cetera, And it's also really easy to generalize gamers and say that they all sit with hardcore gaming PCs in rooms for hours on end with headsets on. Some people do that. But fun fact for you, 40% of the world's population, almost half of the people on the planet, identify as a gamer. Almost half the people in the world. Now, they don't all sit and do this kind of gaming. Some of them sit on an iPad and do Sudoku, right? But gaming means so much. And when you put yourself in the mindset of how people are using that Wi-Fi router, you start to think quite differently about the experiences that you can curate with the amazing technology that people like you build. And if you think about the way we launched New EE, we call it our made-for bundles. So made for gamers, made for people working from home, made for people learning, made for people using the internet to run effectively busy lives and busy households. And it's landed so well with our customers. Our NPS is materially higher on our New EE brand than on any of our previous brands and product launches. It's landed really well with our people. So if you look at our engagement across our teams, people feel much more connected to customers. They feel like they're much more in tune with how people are using technology, how people are using services than they were before. And if you read general reviews about the products and the services, most of them talk not about the technology, because we've set the tone. They talk more about how people actually use them in their day-to-day lives. And we carried this actually through to our marketing execution, and quite a lot of people, I think, were quite surprised. It's quite different, it's quite bold in the way that we landed New EE as something truly different. We never talked about products. We didn't talk about services. We talked about use cases: work, learn, home, game. And we ran this across huge campaigns. This is one from the London Underground. You can see this in billboards across the UK, and you could see this on things like the London Underground. And if you sort of take the the key lessons from this, from my point of view, the first is that you might be sitting here going, hey, that guy on the stage is saying some really obvious stuff. You'd probably be right. But what I've learned is that it's so easy, terrifyingly easy, to forget this stuff. When the budgets spiral out of control, or when the deadlines are getting loomingly close to being missed, it's so easy to forget about the real customers and those contextual use cases. The second key thing for me is, if I think into the future, and I think about networks in particular, the emergence of things like XGS, PON, fiber are unbelievably reliable access technologies. And as operators, the way, therefore, that we win and that we differentiate can't be just on the access layer anymore. It increasingly has to be on the in-home experience and the in-home services that we provide. But I'd take that a step further and say it's not just about differentiating in the home. If you think about things like quality of experience, measures and metrics as a good example, it's about how you contextualize those experiences and genuinely land them into the homes of the millions of customers that we serve. So I said I'd keep it brief. I'm going to leave it there, and I know Steve's going to moderate some questions, but I'd love to have a conversation about this and hopefully some useful takeaways.
Thank you, Matt. Takes me back to the very first BT Home Hub. Well done. I remember, Matt, way back, this first hub, the marketing director of the time says, we've got to treat this like the fire in the corner, that people go like this, worship this.
Yes.
And that's important. And the whole goal at the time for customer experience is not to have that router stuck underneath the television or stuck in a box somewhere. So it's really good to see that it's coming alive and becomes relevant, and that design is important. Yeah. So questions from the audience, your opportunity. Please do pick up on any of the threads Matt's referenced.
And if you're in my team, you're not allowed to ask any questions. I'll squeeze over there, Steve.
Question down the bottom here.
Matt, Andy here. How difficult was it to convince your marketing team that for a change you don't do spec sheets, but you do use cases? Were they open, or was it a tough battle to get them there?
Yeah, that is a great question, and we're very lucky actually. We've got an incredibly visionary CEO who was brought in and driving this from the start, and I think it gave us license as product leaders. We've got technology leaders in the room with us as well who ordinarily wouldn't have been able to think like this and work like this and genuinely spend time out and about with real people in real homes and bring that to life. So we were very fortunate to have that. I would say if you don't have that, push for it, agitate for it, because the power of really bridging that gap between amazing technology and then how people use it day to day, when you say it out loud, it's actually a really convincing and compelling case to make. But no, we were very fortunate on that.
Any other questions? Matt, I've got a quick question.
Go for it.
How in a world of legacy routers and then exciting ones like this, how do you transition people to upgrade, bring in new?
It's a brilliant question, and one that I spend quite a lot of time talking with our finance team about, because it'd be amazing, right, if we could just give people this technology and light their homes up. The reality is we have to run the business and make the economics work, and we're approaching this in a fairly simplistic way, actually. We've built a brand on New EE, and we've said that we're going to put all our investment, all of our new product development, things like the Wi-Fi 7 router on that flagship brand. That doesn't mean we stop investing in the other brands, but it means all of the new great products and services exist on New EE. And by doing that, we can give you great reasons to move there. So the Wi-Fi 7 router and the bundles that you get with that, not just the technology, but those experiences I talked about, the gaming experiences, the busy home experiences, are only available on our New EE brand. And that gives you a hook to move across if you want to move.
Terrific. Any other questions for Matt?
You're all too
Matt's
busy eating after your lunch.
Yeah, Matt's going to be on the panel, so feel free to build up these very incisive questions on the topic. Matt, it's a real pleasure. Thank you very much for coming out and doing this. So our next speaker is Lily Thomas. Lily is the Chief Scientist at the Wireless LAN World Application Alliance, and very much focused on the experience around the applications. It's fantastic today. We're on devices, we're on networks, applications. Lily, welcome. Thank you very much. Lily's instrumental, by the way, in numerous standards bodies, innovation areas, and it was a pleasure to see that you are a bridge for us between all these organizations to make all this happen. So welcome to the stage.
Thank you. Hear me? No? Good. Okay. Thank you. Thank you. Okay, thank you, Matt, for introduction. So this alliance called WAA. So people would ask the question, why another new one? We have Wi-Fi Alliance, we have WBA, now we have WAA. So this name is called the WLAN Application Alliance, majorly focused on the, I can use this one, I believe so, okay. The topic today is chasing best WLAN application experiences. So this is a quite new alliance that built as the year of 2022. It's very new, it's the baby right now. The mission is to promote the healthy and sustainable development of the world WLAN industry and the build of the best WLAN experience of applications, specifically from the point of view of the end users. Because I heard the whole morning presentation, people present a lot of things that in the airport or in somewhere, it's very difficult to use WLAN. It's always some problems. From the end user point of view, even in your home, you always find some place that you cannot connect, or when you're playing the gaming, suddenly you lose your partner, you cannot go on. So there is always problems here. Experience is not so good. Now this structure over here is very normal, easy to understand, similar with others. I don't need to emphasize. And we have a lot of members already existing. Unfortunately, right now, it's majorly focused on the China market, but we are expanding to the globe. So I don't need to emphasize these numbers here, because everybody knows how important Wi-Fi it is. It's everywhere. Everybody is using. And the pain point is that, at least here in the home network, we have multiple, just like the previous speaker said. In the home, everybody have at least one or even two or three devices working together. And this is sometimes confliction coming and the quality of services going down. And also in the office, it's sometimes unstable. I believe many of people have the experience in working in the office. You use the office WLAN, it's sometimes got lost connect, and you cannot send an email. And for public network like in the airport, sometimes we are worrying about the security issue. And also, everybody has the experience in the airport of Munich and Paris, everywhere. The connection is not so stable. Sometimes you cannot connect, right? And for the high density environment, like in a huge hall that have a game playing, soccer playing, it's everybody is doing video and upload and download. It's a disaster. So the problem is that everybody is in this meeting. The vendors are talking about they have a very good solution for the improvement of the experience. But actually, we don't have any standards and certification to say so in the third-party neutral way to tell the customers, say the users, if you have this certification, you'll be guaranteed good experience. Nobody's saying that, okay? So this WA is doing something like in these four aspects. First of all, is a general application experience, and interaction experience is very important, especially for the game playing. And the connecting experience is that password-free or seamless roaming. We already have solutions in the marketplace, but how to evaluate the real experience in a standardized way is still a question. And also, we're going down to the leading innovation, technological innovation. We should include the green issues, energy saving, and the cybersecurity inside. So these are 4 things we are focusing on. We already have a lot of things going on here, but the problem is that missing that double lane performance testing certification. It's a lack of it. We all know Wi-Fi Alliance is doing that. They are doing a very good job to have interconnection with devices between different vendors. That's a great progress, achievement. But here, from the point of view of end users, how to make sure the end users feel very good. This, I think, in the market, in the industry, is already missing. So that's why the AA is focusing on. We define how to define the performance or the application experience. We have 6 factors here. When we measure this, we are focusing on the real-world difficulties. Like, for example, in a home, you may face the problem of the penetration through the wall, and that experience could be very bad. And if you're using the frequency of 2.4 gigahertz, it's good for get around, right? But the bandwidth is limited. You use 5 gigahertz, it's good for bandwidth, but some corners you cannot cover. You always have some problem here. So whatever it is, we use these 6 directions combining with different scenarios to evaluate the experience here. So the establishment of this alliance only 2 years. We already published 8 specifications, and some other things are ongoing and under planning. Now, the first 8 specifications majorly focus on the home scenario, and we are going to expand for more scenarios. This is already most important thing that in this year, 2024, we already built the complete system of the certification and testing. We already have a procedure, and we have cooperated the certification authority and the test labs, and also, most importantly, the testing devices for the performance. So we are going to use the 3 directions of the certification. First one is that the product-based. Of course, it's very similar. Everybody doing that. Every vendors can do it by themselves, but we have scenario-based. Like we will design or define that the typical scenario, like in a home, we have different style of the home structure. An office with multilateral, or maybe some strange structure. And also, most importantly, the field-based means that one aspect is experience, but we also counting on the green and the serviceability and the cybersecurity in the future. It's all on our planning. So this is our stages. We already have the phase 1, that's the 2024. We have a very basic, easy-to-use certifications published. All the system procedure already have. And we're going to go into the phase 2 in 2026. We're targeting the great user experience. That means if the vendor has passed the certification of AA, have the logo and the vendor, in 2026, we hope that we can achieve great user experience. If you have that vendor, you don't worry about the experience. Okay, it's very challenging. And now, we already have a first authorized certification body, the CQC. We may have another one joining us as TUV in Europe as a certification authority. And also, we have 2 authorized laboratory testing. One is the China Mobile Digital Home Lab, another is the CICT. And we are expanding to globally in Europe, other places, for all other new test labs as well. And we have the first certified testing equipment. This is developed by the company HBTE, called HC2600. This is very good for us to have a really commercialized device for the other testing, because in the past we don't have that one. We already announced a batch of the certification products and issued the first certifications as well. And we also have the first testing platform also announced by the Breed Semiconductor. Okay, so this is all these testing platform and the devices. These two are already ready here, we can use. And these another two companies are probably under preparation to support WAA. Now, we have the three steps. First of all, from the beginning of 2020 to 2022, 2022 to 2024, we already announced a lot of standards or specifications. And also, we have, in this year, built the testing certifications. And we are going to have the accreditations of the market. And most importantly, 3 major telecom operators are going to use WA's certification in their massive acquisition of the Wi-Fi devices. It's already ongoing. Okay, we are trying to expand into other operators globally. Now, there is a first demonstration and pilot project by China Telecom. It's already there. If you have interest, we can introduce you to take a look here. So this is all I'm going to present today. And frankly to say, I'm doing recruitment for members. If you want to join, contact me also from the website. I think I'm not running out of time. I'm ready for questions. Thank you.
Thank you, Lili. Very informative. Any questions for Lili? Question here.
How applicable for non-China deployments is WAA? For example, do you cover 6 gigahertz, for example?
Actually, this question is out of scope of WAA because we don't think about the spectrum because majorly it's a government agency. It makes the decision using I heard the debate of the 6 gigahertz for Wi-Fi or for IMD, right? In China, I think the regulatory agency is more likely use the upper 6 gigahertz for IMD. That's the major intention right now. But I think people are still struggling on that. I'm not sure it's going to be successful or not. But I have to say it's difficult. Yeah.
So Lili, just to follow on Dean's question, is the work you're doing relevant for the US using 6 gigahertz? So if members join you, is it relevant?
Of course. Every alliance should be member-driven. The members join in WA and ask for the requirements that we need this, and we can submit and we can discuss and support. That's the general way of any alliance is what it's doing.
Right.
Okay.
Dean, is that? Any other questions for Lili? Lili, I have one question.
Yeah.
The WFA clearly are involved in standards on the technology. it obviously crosses over a lot about what you're focused on and what they focus on.
Mm-hmm.
So how do you collaborate with them so that you have a common view, maybe use common test facilities?
Yeah. In the very beginning of the establishment of WAA, we keep very close discussion with WFA because my company also already the board member of WFA as well. We know the differences and the cooperation between these two alliances. So we're not going to overlap. And this alliance more likely focuses on the user-centric experience and performance, not only for the products, but also for the solutions as well. For example, recently we have a solution we call the FTTR, the fiber to the room, because if a backhaul is weak, no matter how strong Wi-Fi it is, it's not good. You know, you have a poor backhaul, you cannot do it. So FTTR is a place that is a solution that to put all the fiber direct to the room and make sure every AP in the room can coordinate with each other and to provide the best experience for the office or your home usage. So this is what the WA is focusing on that, but WFA's major thing is working on interconnection of the different vendors' devices. Because that's the major value over there. Maybe they will do that, but I remember several years ago, there is a big discussion in WFA on are we going to do the experience certification? The final result is no. So that's what I know.
Okay. Well, thank you, Lili, for coming up and sharing the WAA, and I'm sure people will pick up with you after your session to talk further.
Thank you, everybody.
Thank you. So our next speaker is Bob L. Hawari from Cognitive Systems. Bob's been very much at the forefront of sales development, complex solutions, and I think it's really important actually looking at Bob's profile that is all about relationships. And that's what I think this is about, actually, you do more together. We're going to actually focus again on new applications, monetization of Wi-Fi sensing, so bringing in the commercial angle. And it's wonderful to have you here, Bob, so thank you very much for coming.
Okay, good afternoon, everybody. I hope you're all well, enjoying Paris. I don't think many of you have been out during the daytime, but you're probably enjoying Paris at night. So welcome again to the event here. As indicated, my name is Bob L. Hawari. I work at Cognitive Systems. I look after the sales function. So I'm very much engaged with a lot of service providers, whether they're tier 1, tier 2, tier 3 service providers, but not only them, also organizations that want to leverage Wi-Fi sensing and the technology that Cognitive Systems can bring. So what I'm going to talk to you about today is really sharing the experience that we've had to date since we've been engaged with all these potential customers and the customers that we've deployed with, and try to help you get some ideas around how you could harness the value and benefits of Wi-Fi sensing, because it's actually truly amazing. I have to give credit to the business, the industry, everybody else in the whole ecosystem that helped get us to this point, and hopefully we can continue to scale and grow. But the big challenge, of course, is how do you make money from these things? It's not just the technology. So that's what I'm going to talk about today. And feel free to ask any questions that you feel you'd like to ask at the end of my presentation. So as we all are probably aware, most people have a lot of devices in their home. The addressable market's actually huge, amazing, like 20 billion Wi-Fi connected devices around the globe. They all have their own value, their own capabilities as a device, whether it's an Amazon Alexa or a smart light, they do what their things are. But one of the common things there is that they are connected by Wi-Fi. And what we want to do is, as a company, is basically add more value to that Wi-Fi connectivity and also add more value to that Wi-Fi connected device beyond the actual capability it provides itself. And that's where Wi-Fi sensing comes in, to basically enable those Wi-Fi connected devices to do beyond what they do today, but actually become motion sensors in the home. So leveraging what you already have in the home. And like I said, as you can see on the slide, there's over 20 billion around the globe as a total addressable market. So that's huge opportunity. And that's primarily fed through a lot of service providers who provide Wi-Fi and internet. So it's not just me saying that there's an opportunity here. Key industry players today are actually saying this. So as you can see on the slide here, there's a number of use cases, and I'll talk about some of those use cases later on in the presentation. But we have one partner in the US called Electronic Caregiver that's really harnessing, using Wi-Fi sensing to advance the capabilities that they have today in digital health. And I'll talk about that later on. We have a huge cable operator, the biggest cable operator in the US, that's actually launching it today across millions of their broadband customers. And I'm going to talk about how they are extracting value from this and providing value internally and obviously to the customers. We have partners who are not only big customers as tier 1s, but also partners who help serve tier 2, tier 3s, such as what we have here from Plume. They've offered this service to hundreds and hundreds of tier 2, tier 3 service providers and millions of actual end customers using Wi-Fi sensing. And I'll talk about the value that they've been providing to date. And finally, there are more tier 1s coming on board who are actually saying that Wi-Fi sensing is a game changer to the same level as what you hear as new technologies such as Matter and such as the buzzword of AI. So they're actually putting Wi-Fi sensing at the same level as these new technologies. So that's very, very encouraging to hear as a future emerging technology that could address that addressable market. So it's not just the future, we actually have it deployed today. You can see here on the map, everything in blue is a dot on the map. We have over 15 million Wi-Fi deployments where those Wi-Fi devices are enabled to become motion sensors. And that's in over 110 countries, served by over 10 tier 1 service providers and over 150 tier 2, tier 3 service providers offering this service today and trying to monetize that and get value for them as an organization, but very importantly, value to the end customer. And I'll talk about that in a little bit more detail shortly. So it's not just dots on the map. Here's just a snapshot of some of those 150 tier 2, tier 3s in the Americas, over here in Europe, Middle East, Africa, and also in Asia Pacific. So the meat of the presentation is really to just run through, at least at a high level, but we can always go into more depth with you if you'd like to afterwards or separately, into some examples of how some of these service providers and organizations and businesses, not just service providers, but anybody who leverages Wi-Fi, are actually looking to monetize or are monetizing Wi-Fi sensing. We call Wi-Fi motion from the company I represent, which is Cognitive Systems. So the first area I'm going to talk about is around them using it as a competitive advantage. How can they as an organization be a differentiator? How can they go first to market with an innovative technology that nobody else has or are still developing and show value to the customer, something that's new from an advanced feature capability? From a feature perspective, we've got partners who are actually looking at monetizing specific sub-features of Wi-Fi sensing. Wi-Fi sensing isn't just one feature. It's made up of individual features. And I'll talk about some examples there. The third area, what one of our big partners in the US is doing, is using Wi-Fi sensing as a means to actually upsell to a higher value premium service that they're not necessarily able to extract enough value from. So they're including Wi-Fi sensing as part of that premium service, as well as an introductory service to then be as a channel to upsell to. Then I'll talk about two key areas of examples of use cases. One is around home awareness, home security, and the other is around digital health and wellness, what we call remote elderly care monitoring. So I'm going to step through the first one, which is around that competitive advantage. What we call it is the most advanced Wi-Fi. A lot of service providers today are really, really pushing Wi-Fi 7 as that advanced offering, higher speeds, lower packet loss, all the benefits that Wi-Fi 7 bring. But a lot of service providers today are looking to associate not a feature like Wi-Fi sensing and a use case to that offering of Wi-Fi 7 as an example. So they see associating a new advanced feature such as Wi-Fi sensing as being hand in glove with Wi-Fi 7. So rather than maybe, for example, a cybersecurity feature, which you have today, having something like Wi-Fi sensing, which is on the forefront, associating that and becoming part of that overall most advanced Wi-Fi offering in the market. So that really helps show that value to the customer when broadband routers are sold to the end customers via subscription, and encourage them to upsell to that from their old legacy devices. The second area that I mentioned before was around monetization of features. As I mentioned earlier, Wi-Fi sensing isn't just a feature in itself. There are a number of features in there that actually can be monetized themselves individually. So, for example, we have features where you can actually see the live motion in real time of movement in the home or in the premises. We have motion alerts and notifications that can come directly to your phone that customers see value of them. We even have new features such as motion replay, where you can actually go back in time and look at the motion that's occurred, just like you were doing a video replay if you had a camera. So as an example, if you had a house cleaner who was scheduled to come to your house and clean for 2 hours, you could go back in time to see, well, what time did your cleaner come into the house? What time did your cleaner leave? But importantly, which areas of the home was the cleaner in, and how much time did they spend in there before you go and pay, your weekly pay to your cleaner. That's just an example. Or your child who comes home from school while you're working. Did they spend the time that they said they were going to spend in their bedroom studying, or were they downstairs in the living room playing on their PlayStation? So those are examples of Wi-Fi sensing and the use cases and value from a home insight perspective. But those individual features themselves could be monetized and marketed accordingly. The third one I mentioned earlier was around upsell, using this as a channel to upsell to premium services. As I mentioned before, we have a service provider in the US that's offering a basic do-it-yourself home security solution. It doesn't have all those features that I mentioned earlier. It has a subset of those. However, they want to use this as an introductory way to get people familiar with monitoring your home, getting peace of mind, having a basic level of home security as a means to then upsell them to more sophisticated, more premium professional security services, for example, 24/7 monitoring or getting a camera. And you could actually use Wi-Fi sensing in the context of that premium service as well. So they're working really, really hard to get it deployed, get it adopted, get people familiar and comfortable with having a non-intrusive Wi-Fi sensing service without having cameras in the home as a means of getting them comfortable with having that service available. The two use cases I was going to talk about, which I've already started to talk about, was around home awareness. Home security is the first one. So that really is the foundation and the basis that we're seeing as the most popular use case to start off with. It's simple to understand. It's intuitive to understand that, hey, if you're detecting motion in the home, really it's to protect your home or find out what's happening in your home, whether it's from a family perspective or from an unintended intrusion perspective. Okay. And we've had some service providers who've actually actively surveyed customers before they've launched and asked them by showing them in focus group studies, showing them the apps that we can provide to them, asking them, would you be willing to pay for a service just for that? And in some markets, those customers, over 50% of those users have said they'd be willing to pay for a basic home awareness service. Anywhere in the range of like €5 or £5 a month. But it really depends on the market. Every market's different. But you really need to understand your market. You need to understand your customers. You need to understand your own plans, whether it's a premium customer plan or if it's a mass market plan. There's so many variables to help you decide how you charge for it. But the key thing is marketing and making sure your customers are aware of those features and having them understand the value of that can bring in a way that they don't feel threatened by it, okay? People are concerned about privacy, for example, but when you think about it in your home, people have cameras. They have Ring doorbells that can see what's happening in the street. Some people have cameras in the home. You have smart speakers in your home that can listen to everything you're saying. So this is no different than that. In actual fact, it's probably less intrusive. So we make sure that we work with our service providers to give those customers reassurance of that before they adopt this service. The final use case, which has grown in popularity tremendously based on the experience, especially that we've had in the last year, is around digital health and wellness of elderly people and remotely caregiving for them. So that caregiver could be a family member, like a son or a daughter, or it could be a remote healthcare organization, such as health assistants, doctors' offices, care homes. They could actually remotely allow people to age in place at home longer rather than actually being in a care home or having to go into a hospital. So there's a lot of potential in that because it's actually very personal. Everybody has their parents, and of course they want to have peace of mind that their parents are doing very well at home. So what Wi-Fi sensing can do is actually provide an understanding to that remote caregiver of those insights, provide them a view of the behaviors, the activities, such as what time did they wake up in the morning? What time did they go to sleep at night? How many sleep interruptions were there? Did they go to the bathroom more often than normal? Understanding those trends to then hopefully proactively take some action if necessary to address, for example, an underlying health issue. Did they go to the doctor on time? So things like that are insights that Wi-Fi sensing can bring into a product offering centered around elderly care monitoring, around digital health and wellness. So it's not just me telling you this on Chartware. We actually have, like I said at the beginning, we have live customers in the field. Okay. Now is the time to really, really look at this seriously and understand how you can capitalize on that. There's not a lot of innovative features that are coming out on a very frequent basis. We have our customer, as I mentioned before, that have helped us get into those 150 plus service providers who are tier 2, tier 3 ones. Come and tell us that Wi-Fi sensing has become an efficient way through software, by the way, to integrate onto the access points that broadband service providers provide to those customers. And it allows them to enhance motion detection and security features which they believe is a new standard in the market beyond what's available today. And that's from the Chief Commercial Officer at our partner at Plume. The final one, which I talked about a moment ago, was around remote elderly healthcare management. Again, we have a partnership now that's public with Electronic Caregiver in the US, and they're in the digital health space. Anthony Dorman, the CEO, has gone on the record to say this has brought him more value than what he's offering today. You can read his testimonial here, that they are a leader in digital health in the US, and there's many, many other organizations in the US. They're small organizations. They're not service providers from an internet perspective. But their offering is called CareAware, and they believe that's pushing the boundaries of wellness monitoring to complement what they already offer to their customers today. So this is something we can demonstrate to you, to your customers, very easily. We have reference apps. We have people who can help guide you in terms of our experience, like I said today, in terms of how you can monetize that, because people actually see the value of this considerably higher than some of the other features. Like I said earlier, maybe around $20, 20 euros a month, 20 pounds, or even more, depending on what you bundle it in with anything else that's offered to those customers. So hopefully that gives you at least a high-level insight in terms of ideas of how to monetize this. There's obviously a lot of detail. There's a lot of analysis behind it to get to this. But we believe it's worth investing time and effort to look at that, especially with developments like Wi-Fi 7 and beyond that are coming over the coming year. That's it. If there's any questions, I'll be happy to answer them.
Thank you, Bob. Thank you, sir. Any questions for Bob? Down in the middle. Thank you.
Hi, just a basic question. because I'm not very familiar with the technology.
Yes.
Is just a basic router enough, or do you need like a mesh with many nodes to make it work?
It can work with a basic router, as long as the chipset is compliant. So most of them are. With our technology, we're on all the major chipset vendor brands, the usual suspects that you would know of. We also work on mesh routers as well. And what that would do is any Wi-Fi connected device in the home automatically becomes a motion sensor in addition to the mesh router or in addition to the single access point. Yeah.
Other questions?
Quick question on regulations. You know, in many countries, when you're deploying video cameras, you may have to require authorizations if you're in public spaces and even in office spaces and so on. What's the current situation for Wi-Fi sensing on that?
Yeah, well, our technology isn't geared for outdoor spaces. We need to be deployed, for example, in a home where the Wi-Fi signal can reflect off of walls so you have maximum coverage. Okay, firstly. So the only regulatory thing that we actually end up having to look at more closely when we talk to service providers, for example, here in Europe, is GDPR, which is a privacy regulation to make sure that you have end user consent before they take on that service. So if the end user agrees to it, through terms and conditions, you all know of all these apps and you see a scroll of terms and conditions and you just say yes. They say yes, it's no problem. They just have to have the ability to say yes or no, that they're happy to be monitored in the home through an application using Wi-Fi sensing.
Any other questions? I've got a question, Bob. In your sales role, there will be a number of people here who've got either innovations, applications. How engaged do you get? Because I imagine you've got distribution and partners, as you've said with Plume. How engaged do you get to be actually involved at their end customer level to translate this sensing into their products? And is that something that you offer?
Yes, absolutely. One of the things we start off doing with a lot of service providers, especially in the initial engagement, I know some of them are in this room, is we'll provide them evaluation and demonstration kit with a reference app. So we have 2 reference apps. We have a reference app around the 2 use cases I showed you a moment ago, which is home awareness, and caregiver aware. So we can get the service provider, people that we're engaged with, to become familiar with those features so that when they engage with the end customers, they can help explain the value to that. We've had some of these service providers go into the field, do field trials and proofs of concept with live customers to get their feedback so that they can really refine their product offering and their app before they actually deploy it to scale at production level.
Right, and if somebody's innovated and created their own app, is that something they could bring to you and say, how do I marry this capability with that app?
100%, 100%. We typically integrate into a service provider's app. So think of your service provider today, they have their own app. We provide APIs and we can guide them and help them integrate those APIs so that they can have a custom experience from an app perspective in their own app using Wi-Fi sensing. But what we do show them is, through our reference app, is what's the art of the possible. So that's why we developed this app, to distribute to you as a service provider so you can get an idea of how to implement that when you go to the field. Alternatively, we could provide you the app and you could have it white labeled and you could put your brand on it and sell it as is if you don't have all the application resources or a digital team to support that.
Bob, thank you very much. It's given us insight into some real applications, real services to that. That's terrific. Thank you.
Thank you.
Okay, we're moving to the panel session. We've almost got a full room. This is getting exciting now. Lots of opportunity to ask questions, so please do. I'm going to bring you in on it. I'm going to invite Rita Zawi to the stage, please. And do just take a chair wherever you wish. So Rita, do join us. Bruno Thomas, which a number of you will know. So come on up, Bruno. Feeling like a game show already. Matt, who you've met, Matt Hughes. Do join us, Matt. And Christian Gabetta from Heights Telecom, Christian, do join us, and Pramod Gurmaraj from Apricom. And I will get everybody to give 30 seconds intro, apart from Matt, who's already done it.
Oh, thank you.
So if I could kick off with Pramod to just give us a quick 30 seconds, who you are, your role, and it'll help us test the mics.
Yeah, this is a different one compared to the others. So I'm Pramod, founder and CEO of Apricom. So we are into end-to-end experience management systems for operators, mainly to improve their operational excellence. We have seen these protocols evolving over time. People like OEMs like Heights, etc., who are here, trying to build more and more faster systems to these customers. Operators trying to deliver a better experience to the customers as well. So we are in that area where we can give a better visibility to these operators and then reduce these churns or reduce the customer support calls so that they are able to deliver that experience to these end users.
Thank you. Have you got a mic or do you want? Yeah.
I think, can you guys hear me? Yep, perfect.
I can hear you, sir.
Yeah, thank you. Yeah, I know. So I'm Christian Gebetz. I'm the managing director of Heights Telecom. I'm based in Switzerland. And what we do at Heights Telecom, we manufacture home gateways, so fiber home gateways and Wi-Fi extenders. And I think to Pramod's point, I think we are in an inflection point. You know, the industry is going through a lot of evolution, and I think, you know, we are seeing operators trying to come up with new services, new functionalities, and it is key for service providers to be able to embrace. You know, early on we heard Cognitive talking about Wi-Fi Motion. That's a good example of an app, a service that would run on a gateway that needs to be deployed quite rapidly. And this is what Heights is all about. You know, we're able to really implement in a containerized software architecture those kind of solutions.
Thank you. Bruno?
So Bruno Tomás, I work as the CTO for the WBA. Very warm welcome to all of you. So Connected Home is a big part of our working program. So our mission is really to solve business problems related with this topic. When it comes to Wi-Fi, you know, data collection, Wi-Fi configuration, Wi-Fi installation, and network performance. We have around 7 programs tackling this topic, so lots to say. So looking forward to it. Thank you.
Terrific. Last but not least, Rita.
So Rita from Orange, can you hear me well?
Yes.
Yeah.
Okay, good. So Rita from Orange, I'm part of the, no, you're not here anyway, so you need to switch on probably the
Test 1, 2, 3.
What's up? No? Okay, I'll use with this one. Okay. Part of Orange corporate group, so I'm involved in the wireless domain, so in charge of the new services and technology. Wi-Fi is part of it. For our home services, we have a lot of countries which we help developing the new services and technologies, but also on the mobile side as well.
Very good.
That's terrific. Thank you. Sorry about the mic. Can we have another microphone down the end? Otherwise, we're going to be spreading one way to the other end. We've got 3 in the middle with headphones. Or get Rita live, one of the two.
Beauty was you were mentioning about these microphones before this panel as well.
That's right. Right, well, whenever I've sat on a panel, the thing I always think is, God, are they going to ask me a question that I don't know anything about? So I'm going to do my best to make sure that it's something they all know a lot about. So I'm going to start with Wi-Fi 9. Only joking. Only joking.
We are already on that.
That's right. So now I'm going to go to the heartland of what we talked about throughout the whole session, and that's about customers. And I want to start with the topic of, are we expecting too much of our customers? We talk a lot about the exciting things to come. AI, the network can do it. We saw the excitement of Eric this morning about intelligently analyzing what's happening. But the reality is out there, people have got 5, 6, mixture of both, all sorts. And I want to talk about the role that we have as a body, as providers, to educate our customers. And I'm going to start with Christian, because I know it's a topic close to his heart, but I'd like to touch on a few of your experiences So what's the role of ISPs, of innovators in technology and apps to educate our customers? And any good examples of where you've done it would be really great for the audience.
Sure. No, that's actually a very good question, and thank you for raising it. Obviously, the biggest challenge that we have as an industry is that we bring fiber to the home, we bring connectivity, and we think that everything is fixed. You know, we connected to home, we're all happy. But what we know is that the biggest issue is what's happening inside the home. And the home is becoming more and more complex because when we look at what has happened as well with COVID, now the enterprise is an extension, the home is an extension of the enterprise as well. So we end up having environments where Wi-Fi has become even more important than water and electricity. I mean, if you talk to a young person today, they would probably prefer to say, I'd rather have Wi-Fi than water or my heating system working, but make sure that my Wi-Fi works. So what we need to do is make sure that we ask ourselves, what are we doing to really make sure that we are delivering that user experience? And early on, we were having a conversation with Pramod, and getting that visibility into the house is key. You know, before the customer call, if a customer calls you, it's already too late. You know, you already have an unhappy customers calling you. So I think, connecting with AI, AI is very big, but I think we need to understand, and when you talk about educate, is, I would say, how do we educate ourselves? The ISPs and how we deliver that service is important. So getting those systems in place to be able to recognize patterns that can actually affect the Wi-Fi, things that can actually, it's a key element.
Pramod, do you want to add to this?
Yeah, rather than we saying that we want to educate the customers, let's look at it as an opportunity to make sure that we meet those demands of customers. So as an end customer, I really don't care about whether you use AI, you use Wi-Fi 6, 7, 8, 9. I really don't know what it is. I just want to make sure that my customer needs are met, my needs are met. So if these networks work in that fashion, then there is no reason for me to even call these operators. If you should feel lucky if these customers are calling you, because most of the times when the customers are frustrated, they are not going to call you, so they are just going to churn out. So understanding their needs, as Christine was mentioning, about visibility makes a big piece, and if the networks can be intelligent enough to adapt to the needs, so intuitively, just like how your phones are so intuitive, doing things what you need, if the network is able to do those elements seamlessly, then you have a better experience as such.
Terrific. Rita?
Yeah, thanks you, Pramod, for that. I would like to add on that and echo on that. So, as Orange, we do a lot of surveys internally and to our customers. We have a lot of countries in Europe, in Africa, Middle East. And what come out of these surveys is that customers, they don't want to be educated. They just don't expect that. They just want Wi-Fi to work. So we usually have this kind of question, how can you educate customers? I think it's a lost battle. We don't need to educate them. However, as you said, there is a lot of expectations on the home network and Wi-Fi technology and so on. So we all talk about the homework and all this kind of stuff. Yep. So as an ISP, what we need to do is to make sure we deliver the right services to the right experience to the customers. So we're taking care of that, and they know that. So they rely on us to give them the good the good experience. Mm. And if there is anything, we can explain them how we can improve that. But education, I don't think we need to put too much on that. They're not willing to be educated.
It's such a good topic, this, and so relevant for everything that we do. Matt, I'm going to ask you your views on it and what you found from BTE and Plus now.
Yeah, it's a great topic, and I'll tell you what, there's nothing more uncomfortable than a microphone nestled in your back to start the afternoon. But I think if you take today as a really good example, walk out there and you'll find hundreds, probably thousands of incredible technological innovations. People will be painting a picture of the future types of tech that can power it. But I think Rita has hit the nail on the head. It's how do you then contextualize that for customers, I think is the key. And certainly from what I was talking about earlier, we learned that with New EE. You've got an increasing and almost growing an exponential rate, a huge number of technical solutions. And you'll melt minds if you try and explain all of those and educate customers, but picking and choosing the right ones to contextually solve for real customer problems in daily life. And then I think how you manage that, so how you surface that through companion apps as a real example, to put the control in the customer's hands as simply as you can, I think is how you crack it.
And what about the WBA? What role have the WBA have got to actually project how we get that experience?
Yeah, I think if we put it in a context for the connected home, you need connectivity. And there are many options today where you can get sometimes some cellular coverage inside the home. But let's face it, ITU says 90% of the traffic is fixed, whether it's Wi-Fi or cabled. So I think the challenge that we got to improve the baseline service provided to customers, that was the request that both operators, router manufacturers, IT companies put on the WBA, and we started by, okay, let's baseline the standards we have, let's make them work together, things like Wi-Fi Easy Mesh, Broadband Forum, USP, and that was the result of the operator-managed Wi-Fi residential architecture phase 1, and now we tried at least to have a consonant perspective when you go to market, and if you are to add something new, that should align with this architecture. And I hope that the comments around, oh, customers bring a new IT device and they call our customer service are reducing now, because then this architecture evolved also to cover IoT. So that's really a phased approach that I believe can help, mitigating customer, service complaints.
But I'd like to emphasize something, and not to point out of WBA, but the industry in general. One of the key messages since we started with the customer experience, I wish whatever work we start, we need to put the customer first in the center of our focus. Because it's easy to go into technology and push for new service, blah, 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 use cases. But as you said, I think you said it in your presentation, it's easy to forget about the customers, but this is the key point.
It's very easy.
Yeah.
The tech can be so exciting that it consumes you.
But we need to make sure whatever we do is for a clear demand. Even for AI, there is so much things about AI now, but we need to focus that it's on the purpose of that is really to serve a human behind.
Yeah, of course. Yeah.
I think can I just add to that, because I think, again, at an event like this, it's hard to sort of convey, because we're all quite technical. Like the brightest minds that shape this stuff are largely here, right, in Paris over the next few days. And I think it's easy, because we all talk a language that we, generally speaking, understand, to forget actually that the millions of people that buy our products and our services, or your customers' products and services, don't live and breathe that every day. They don't sit in project meetings, they don't sit in panels like this talking about it. And I think it's so incumbent, particularly on operators, but I think on everybody, to just put yourselves back in the shoes of those customers and translate that into sort of real world use cases.
Yeah. It certainly is, and I know from quite a number of experiences that Wi-Fi, if the broadband's down, it's my Wi-Fi's down, not the broadband's down. So we have a massive responsibility. I do take only one or two issues really with your point that we don't have a role to educate. I agree we should fix it, but there are some fundamentals that we own, like you don't put the router under a television, that we do owe it to our customers to give them some advice when they're engaged.
That's definitely what we're trying to do as a service provider. The first thing we help them is to identify where will they put their Wi-Fi.
Yeah.
So this is where we can somehow educate them in terms of the best place to put Wi-Fi is not in the middle of home, but in the middle of your usage.
Yeah.
Which can be in separate places. But yeah.
That's good.
This is where we try, and we have some applications as well where we're trying to explain why things are working or not working, and they can, of course, work with that. But yeah, we go along with them.
I will tell you, I had a wonderful experience this week. My biggest shareholder, hundreds of millions of pounds of their money put in, has our Wi-Fi installed. And he said, why didn't you tell me that my walls are so thick in my nice house and my router was put next to the wall and I'm the other side of the wall? So it's good to educate. Let me move on a few other topics. Again, about perception, it's about customers. Most of the industry of broadband will promote 1 gig, 10 gig, 5 gig. Yeah. And most customers probably still use a router that doesn't give them that. And they're sitting there, and the ISP sitting there, with expensive calls if it's not doing what it should be doing. And what do we do to bridge that? What is there that has got the opportunity to bridge that perception and that marketing message?
I would like to comment on that perhaps. As an industry, and I think Matt made the good point, we feel comfortable selling technology. So the way we position, and if you look at how it's been sold, 200 meg, 500 meg, 1 gig, 2.5 gig, 10 gig now. And now we're talking about Wi-Fi 7. So we seem to be very comfortable, and we're expecting the consumer to really latch to those kind of messages. When you talk to simple people, they don't really understand and they don't mind, because they say Wi-Fi 5, Wi-Fi 6, 6E, 7, it's all the same. I think that there is an opportunity, and again, I like to challenge a little bit us as an industry, is how we can be a little bit more creative to say, when we talk to our customers, not just try to sell on the price, because that's how ISPs competes, I'm cheaper and cheaper, but actually try to sell on differentiation. And the quality of the Wi-Fi is probably one of the key things. All the services, being able to go beyond that, because this is going to be needed to maintain this business. Otherwise, we will erode the revenues. And people like Orange as well, I'm sure you guys are already coming with all these great ideas. But that's something we as leaving this conference, I would say this is something how we can actually be more creative on how we position this with consumers.
I think you've got
some of this education can come here. The mobile applications which the operators roll out can always identify such kind of incidents and then indicate to these, both to the operators as well as to the customers, saying that, you know what, you have an 10 gig connection, but you have a router which is really old school, so which needs to be replaced. So these things can quite easily be solved from these operators' angles too, or from some kind of software intelligence that we can put in.
I think as operators as well, I'll share maybe a personal example to bring this to life. I think we have to take some accountability to think about the ecosystem end to end. So if I think in my own career, 15, 16 years in telco, I can cite moments where I've not done this well, right? Where we've sold eagerly, we've got an access products out there, super fast, ultra fast, 1.6 gig is maybe a real example. And we've launched and convinced ourselves that we've got hardware that can support it because it's got an Ethernet port on it that can provide a wide experience. But to your point, Steve, on wireless earlier, we've not really joined the dots there and said, how do you truly give the customer what they think they're buying, which is a wireless and a wide experience around the home. And we did a bit of sort of looking in the mirror, probably 2-3 years ago when we started designing new EE that I was talking about earlier, and said, actually, as a core design principle going in, we have to hold ourselves accountable and in some cases exercise a bit of self-restraint and say, we will launch products and services when we've got both of those two things together, and then we deliver on the need of the customer. And it does take a real self-check and a bit of self-discipline on it.
Yeah, a very important aspect, because that's what the customer sees.
Exactly.
Yeah. Okay, I'm going to lift ourselves up to the environment that we operate in terms of standards, open source, regulation. I'd be interested in views on what role regulators, standards bodies play in making this customer experience a reality, and how much we can champion that to happen.
Yeah, so maybe I could start on this one in terms of the history. So after we have this common architecture, I think the next step is the different frameworks that we look outside. There are, I don't know, maybe 100 vendors that can give you a router and a gateway. How we go about coordinating this and making it work. So the WBA and the invitation we did to the industry is let's come together in merging some of the leading frameworks. So Purple Mesh, RDK, all those now are aligning on this common set of reference architecture and what this means. For instance, microservices. So if we were to innovate on an app, that app will work across many service providers. So imagine the engineering effort, the R&D that goes into a single deployment versus collaborating on the baseline and then innovating on top. So things like user onboarding, now we have the Mac randomization. I think you are all aware about iOS 18 rotating Mac that breaks parental control and so on. These can all be addressed through microservices. And I think is an opportunity for companies that compete to also cooperate at least to get the baseline right.
Pramod?
Some cases, these regulators are more trying to identify speed as a metric and say you need to give, let's say, 50 Mbps of speed at different parts of the room. That is one kind of regulation that we see here and there getting applied. But speed alone is not experience. So maybe it's possible that you're giving the speed, but it is not able to really deliver that experience. Because we have seen cases where operators complaining that they have doubled the speeds, but the support calls have gone down, not gone down, but it in fact has increased drastically. So customer demands are growing, their experiences are going to also be growing in that direction. So if there is a metric which can measure that, just like how you have the signal strength, where you indicate it with 4 or 5 bars, can we indicate experience with such kind of ways and then standardize that? That could be one way to an input that can go into these regulatory bodies as well.
I would like to comment on the work that the WBA is doing, which we are a member and we are very proud to be able to contribute and participate. I think we as an organization and as an industry should try to go as much standard as we possibly can, because we are seeing a lot of great companies coming with great ideas. Sometimes they're a little bit on a silo, and it would be great to really have some sort of common interfaces to allow these services to be onboarded. And I'm thinking, a little bit of the ISP of the future. I envision, or I think that an ISP could actually have like a portal where you can actually have not a lot of services, but just a few services, and to make it simple for everybody to understand: cybersecurity, motion, parental control, and then just by clicking, like you would normally download an app on your phone, but just downloading an app on that gateway, which will enable you that service, but also it will give an opportunity for the ISPs to generate more revenues, right? But in order to make that happen, we clearly need to work as an organization and have more open standards so we can embrace smaller companies, startups to connect to this ecosystem easier, in an easier manner.
I think we'll add one thing also to that. We're all seeing that Wi-Fi is not anymore the simple wireless connecting, replacing the cable. It's more than that. We're having services, we're having a lot of technologies behind it. And to help the standards, I think standards are crucial to help that, because there is a lot of things coming into our customers' hand. But I also think that as an ISP, as a service provider, as an operator, we can help them to face the reality of life, which is that our customers keep in their home old devices, which they mix with new devices, and then you have to take care of all this heterogeneous ecosystem. And probably one thing we need to challenge with part of your question is how we can challenge the standards, forums and associations, is how we can help the transition between all those technologies without having a gap or without having a big lack in terms of experience. That's a big challenge.
Yeah. It's a really interesting topic. I think you could do probably a whole conference on the juxtaposition between standards, standard bodies, and innovation. And I think what we've got to do is navigate as a grouping to make sure that standards are there, but are not inhibitors to speed and innovation. And Wi-Fi was born. I had this debate yesterday with a good colleague. Wi-Fi was born unlicensed. It went out there and was one of the fastest growing non-standard wireless technologies. And I think we've matured a lot. We've got billions, so we've got to have some standards. But I think it's a great topic to keep considering and know what the important standards are.
Most of the innovation happens in the non-standard way. And then once you see the momentum picking up, that is where everything gets standardized.
Yeah, so Steve, maybe one example is in fact sensing, right? So it started in the WBA, so with the leadership from Cognitive and others, and then eventually we went to IEEE, and is now going through a standardization process. So sometimes going to the field and doing demos, it's great. The same for MDU. We are starting a new project on MDU and trying to come up with new ways of managing that type of environments, and eventually becomes an MDU standard. So
terrific. So customer-led, innovation-focused standards to follow on from all that innovation. Brilliant. We're going to do some great things with this panel, I can see. Any questions from the audience?
Not a question, but just...
Yeah, I can.
Yeah, microphone at the back. Be with you in a second, going like lightning.
Yeah, so not a question, but I'll start, by the way, just for a quick announcement and request your reaction to it. So just a month ago, Charter Communication, which I am part of leading the wireless engineering and technology development, announced publicly the launch of Bright IQ, which is a development platform, an API platform to expose Wi-Fi network services to third-party application developers and really innovate on a platform for innovation around the wireless. In line with what Camara is doing on the 3GPP side. So that's actually public information available, and it's an open forum for people to join. I invite you to check it out. It's Bright, B-R-Y-T-E space IQ. And there is actually a developer platform onboarding. You can develop your application, simulate them, onboard them securely, and launch them to different customers. So just in the context of that, I'm a little bit, curious about the reaction of the panel, because you brought all of these aspects, but I don't think anybody has been looking really. How do we expose APIs and make network assets available for monetization on the Wi-Fi side?
Any comments on API exposure? I know the mobile world's actively following that at the moment.
So to your point is, how do we expose, or how are we willing to expose?
Are we willing to expose?
That's, okay. So, okay, that's not an Orange position, that's my own view. We already announced we're doing this in the mobile world, so we have some announcement recently with the joint venture where we expose our network on the mobile side, and I think most likely this will come into the home as well, because we need to open up to new type of services, and definitely you will have more and more of those questions coming up with the API exposure. So I believe this is going to come up soon.
Any other comments on? Yeah. Thank you. Oh, sorry, go on.
No, I just want to thank you for sharing this with us. I didn't know that Charter was doing these kind of initiatives, and I think it would be good if you're part of the WBI that actually you share that with the community, because I'm sure there will be ISPs like yours in the US, but probably in other part of the world that will be interesting to be part of that ecosystem. It's a great initiative.
Yeah. No, Ahmed, I will just say that there is a thin line between what's being done on APIs exposure and collecting data to just improve AI systems. So maybe we have a blend of some real API exposure that is AI/ML for Wi-Fi systems that we are coming up with an architecture, and we make it a practical use case. So that would be nice. Then I think, of course, for Wi-Fi, we need to avoid islands of connectivity. So if Charter is doing it, maybe other operators would follow on the fixed sides, and we come up with something relevant that developers' time would be useful to cover countrywide. Because some apps, if you use at home, that's fine. But if you want to do maybe some location, we need others to expose as well APIs to their systems.
For us, it's very important because some of those providers, like we have a use case with Airbnb, for example, with Uber, but these are international players, and you want to have access to those APIs across the footprint, not just one, more market.
Got it.
Considering that 80 to 90% of the traffic, mobile traffic, is going through home, so one could expect at some point we would ask this kind of things.
Good.
Thank you for your promotion. That was very welcome for the world to know about the API aspects, and it is important. I can see that, having talked to our dear friend Cedric, who leads it on the mobile side for Orange last night. So, I want to talk about IoT, and I want to talk about security, not security necessarily in cameras and secure home, but security generally. So I'd be interested to hear views on how now the propensity of different extremely important services that are running over Wi-Fi, how do you look upon that and make sure that that environment has got an increasing level of attention given people are relying on it, health, security, etc. So views, welcome.
See, more and more IoT penetration is going to happen. It has not really taken that shape. So this is something which we could see happening in the next couple of years. Latency sensitive applications coming into picture, edge AI coming into picture. This is the way we are also looking at things. Even yesterday we had partnered with Qualcomm in prioritizing these applications for such kind of IoT sensitive, latency sensitive approaches. If you ask me, are we there today? I don't see that we are still at that penetration where it's a big problem, but this is something which is going to be the case in the next couple of years.
I think to add like maybe a operator perspective as well, I think it's quite unknown, right? Like there's IoT and there's IoT, and if you take maybe an example everyone can relate to, baby monitors. A device that you stick in your home and you're putting the thing most precious to you in front of that camera, your child. And then there's I won't name any brands in here, but there's reputable brands who take security super seriously, and you can therefore trust that your child and your device is pretty secure, not infallible, but with high confidence. And then you've got cheaper, usually devices where the investment in security is either not there at all or not particularly well tested. And I think it gives us an interesting question to answer as an operator, right? Like, what is the role that we play in that ecosystem? Is it our role to protect the customer and those devices? Is it our role to guide a customer and tell them that the bad actor, for example, has got into the network? Is it our role to help the customer isolate that device on the network? You know, there's a ton of questions there, which I'm not sure that we've sort of answered. And I guess looping back to the role that the WBA plays in standardization, I think we need to have those conversations across the industry, and I think certainly, if nothing else, we have a role to play to try and help our customers be as safe as they can. Can we control everything? No, we can't, and I think that's the one to crack.
I think your point's right, Matt, and I knew I was throwing a ball in the middle, that there was no real answer, but I can tell from my own experiences that it's quite often, whether it's the camera's down, I only know it when I want to look at my camera. The Wi-Fi's off, but nobody's told me it's off if I'm remote. So we've got this whole positioning of extremely relevant, important applications running on a Wi-Fi network, and there's got to be a solution that actually gives prompts, knowledge, and there's almost certainly a role to play in that.
Yeah, I see three concepts in what you're asking here. Number one is the quality of experience, quality of service. So how to make sure that whatever is connected is well served. So we all know that. But it's becoming more and more crucial. Number two is because of all of that, the concept of carrier-grade Wi-Fi is becoming more and more essential. We need to have, as I said, Wi-Fi not just a cable replacement, but real carrier-grade service there. Mm-hmm. And probably when we think of that, to the best of my knowledge, we don't have a SLA on Wi-Fi, do we? Mm-hmm. So maybe this is something for the industry to start to think of. Shall we start to introduce some SLA in Wi-Fi services because of what you're just asking?
Yeah. And the relevance of convergence in this question, because the mobile's still up, your Wi-Fi's down, you can still tell somebody something, because you've got a converged opportunity.
Well, and take your security one, right? Like great example on convergence, where you say we talk about Wi-Fi as if it's the ecosystem, or we talk about mobile as if it's the ecosystem. But in daily life, I take this thing into my house, I take it out of my house, and how do I know if this is my kid's phone, for example, that it's protected to the same degree with the same profile, the same settings in all of those environments? And I think, again, as operators, as partners, as suppliers, as WBA, I think we need to think about that end to end. The whole thing needs ecosystem thinking to truly solve for these problems. We can't do it in a Wi-Fi or a mobile box.
No, it's a holistic, connected service. Pramod, I could see you had a point.
No, SLAs, to add to what we are talking about, the SLAs are more and more looked at link being up or not, but it is not more about the end customer is able to really use that link. It could be a case where link is up and still customer has issues. That is what the predominant cases are. So if you can standardize that on the SLAs, then it is going to be a bigger boost to the customers.
Yeah.
I would actually like to turn it as an opportunity, perhaps. You know, we're looking at a threat, right? But perhaps if we look at the home today, the last device that the CSP, that an ISP controls, is the gateway. And that's probably the Trojan horse to connect more things. Obviously, security, one of them. So one thing that every year we talk about IoT, and every year we say Matter is going to take off this year, and every year we say the same thing. But in my opinion, that is an untapped opportunity that we need to crack the nut. We probably as an industry, we need to find a way how we can enable customers to be closer to the ISP, because today, as consumers, we go and buy. We go to Amazon, we go to IKEA, and we buy all these devices, Alexa, and we love them. But it's a rather complicated system. You plug a lot of devices behind your gateways, and this is where there are security problems as well. Some of them are protected, some of them are not. So there might be an opportunity for us as an industry to say, why don't we create a hub, which is Wi-Fi, but on top of that, enables other IoT services, right? Then devices can be bought somewhere else, right? But there is something there that we still need to think.
I agree with you. I think there's a huge innovation opportunity. Yeah. I always think that the hub, if it's a true hub, is talking about items talking within the home, not just in and out. We often focus here that it's from out to in or in to out, but it's an intriguing thought process to think just how many innovative services and what relevance there is for that hub, router, whatever you term it. Can we talk a little bit then more about security and security for the customer in dealing with the services from the home, within the home? And at the moment, we know a lot was done on hotspots, for example, because it was a public environment. You are going to be safe. So what threads now should we be following to ensure that customers using the Wi-Fi network are safe? Bruno, I'm going to turn to you because I know you did a lot on that.
No, yes, thanks, Steve. And maybe just to paint the picture with the IoT topic as well, I recall that on the incubation of our smart home for IoT, people were questioning how can we add value, and operators would come and say, well, people is calling me because the baby monitor is not working, and I don't even know the company that sold them that. So I think to answer to the request here on how we can make the bridge between these onboarding security aspects, we are building a framework that is open roaming that includes some type of privacy and policy mechanisms that can give you a certain SLA. By the way, Heights, Plume, AirTies are some of the first companies on the residential market to certify their equipment. So this means off the shelf, we are building this possibility across a multi-vendor ecosystem. Another example is how can we put an identity on an IoT device? How can these guys know the footprint of IoT devices if there is no user interface? So we are trying to have a provisioning-based mechanism that can be using certificates where once you turn it on, the IoT device in your home, it gets the CPE lat long, knows it's your house, and allocates it to your account, and you see it on the app. So this can completely transform the way you interact not only with your users, their devices, but also the IoT world, and make it all secure. Latest and greatest, WPA3, all the onboarding mechanisms we have on Wi-Fi across the home.
Terrific. I was intrigued myself. I became technically literate for a period and managed to get into my router, 192, whatever you guys will recite it. And I found that there were 5 unknown devices. And these are the sort of things that customers worry about. And I think we do have a duty to be able to realize more engagement to explain. Anybody else want to touch on security at all?
I mean, we can look back on your previous question about what role standards can play. And again, we just say that is how we can identify better the devices, how we can transition to a better technology, a better security, and we need to have all the industry all working together to make this, to give the best of the security to our customers. I mean, as part of Orange, this is our promise. We say to our customers, we will deliver the security, the best one you can get in every life box you have, but there is a compromise with the customer experience as well. Yeah, it has to work.
Of course.
Oh, go on. I was just going to say a couple of quick thoughts. I think just your example of unknown devices, it's a great example of something simple we could do better, where you take a MAC address or an unknown device and you fingerprint it and you say to the customer, hey, Steve, that is your Xbox or whatever it is. I think when we think about security, for me, if you sort of zoom right out on it, there's broadly 3 different layers we've got to crack. There's the network level security, which I think is fairly evolved in terms of the, across the industry, how we think about it. There's device level security, which again is probably fairly evolved, and then there's application level security. And I think really the coming together of those 3 things is what we've got to crack as one ecosystem.
I agree. You can't have one alone. You've got to have them integrated. I'm going to let the audience have the last say, because we've got 1 minute left. Question at the front. Microphones coming. They will be down right at the front, please. We're keeping everybody exercised today.
Thank you. The question is really how do we balance the narrative between having insight into the experience that the customer is having with security? How do you ensure, how the customer gets secured in terms of intruder from the service provider? The service provider wanted to see what kind of device you're having and what kind of experience or performance of those devices. At the same time, as a user, I'm talking from user perspective, and I'm saying that I just bought some Wi-Fi devices, plug it into my network, right? And realize that a service provider just called me that, oh, boom, you're having an experience, maybe. Perhaps the device I bought is not Wi-Fi 6 compatible, Wi-Fi 7 compatible, it's Wi-Fi 5, so to speak, and I can't get the feel experience. And then the service provider is giving me maybe 300 megabits per second of service, and I won't be able to get that experience because the Wi-Fi device that I bought is not that capable. And I got that call to say, you bought this type of devices and all that, you're not going to get this experience. And I'm like, oops, I'm open. But how do you balance that secure, at the same time having insight to give the right experience to the customer? I don't know if that question.
Well, no, you've covered a couple of topics there. One thing I do know, and it was raised in a presentation this morning, that having devices that only work on 2.4 or only work on 5, and customers aren't educated to move around channels. This is a repeat of my daughter saying, you're an expert, why can't you fix it? It is very relevant. But any quick comments on that experience and that ability to be able to communicate and bridge this challenge?
If I understand this question correctly, he's talking about how much of insights is okay, how much of insights is intrusion.
Absolutely.
Yeah. So we face this question all the time. As long as we tell these customers that we don't know what kind of website you are going through, but we just know that you are running an application and you have a degraded experience, that is the boundary we limit to. Most of the times customers are fine. Ideally, as a service provider and as an operator, they know more details than you could think of. They know even the website the customers are accessing. But in general, they don't share this information as long as it is not a legal threat. But if we can limit it to the application level, it is still fine, as per my opinion.
Okay. Thank you for the last question. Really appreciate it. Well, thank you very much, gentlemen. Very informative. Really appreciate it.
Thank you.
Thank you. Well done.
Thank you, sir.
Cheers. Well done. Thank you, Matt. Appreciate it. Right, it's break time. 3:45 back, and thank you for your participation. Really enjoyable.
Industrial manufacturing, but also mining and ports. And they present unique challenges which you don't find in your typical enterprise environment. So first off, you have lots of environmental hazards. So extreme temperature variations, maybe lots of water, dust, fire maybe, chemical exposure. And the equipment in these networks needs to be able to withstand these challenges. A second key difference of industrial networks from enterprise networks is the life cycle of the equipment. So in the enterprise network, typically you put the if it's an access point, a Wi-Fi access point, you might put it in there, and 3 to 5 years later, you might be refreshing that equipment. So maybe moving from Wi-Fi 5 to Wi-Fi 6, Wi-Fi 7 every 3 to 5 years. In industrial networks, they're in place typically, at least 10 years, often 15, maybe out to 25 years. So it's in place for a lot longer. So the life cycle of the equipment is considerably longer than what you find in the enterprise networks. That's another key difference. And a third key difference I think is really important to highlight is that the requirements of the machinery and the robotics in these environments they have very high performance requirements. And key to this is they are mission critical, so they cannot accept any downtime or disruption. So consistent reliability is really key for them. Obviously, if they go offline, it's very expensive for the facility and also very dangerous as well, potentially, because the cobot could go off and hit someone in the face. So it's obviously the consistent reliability is really key for these networks. So because of these requirements, historically, industrial networks have really prioritized wired over wireless. And this is actually still the case today. Last month, I was in the Industrial Manufacturing and Technology Trade Show in Chicago in the US, speaking with a lot of industrial manufacturers. And pretty much everyone reiterates that if possible, they're going to go with wired over wireless because they view it as offering the highest reliability. But that doesn't mean there isn't a place for wireless in industrial networking. And on the screen here, I've outlined some of the kind of key drivers of wireless adoption in industrial networks. And importantly, many of these are actually on the rise today. So first off, we've got increased automation. So automation, this has been driven by several different factors. So on the one hand, you've got the challenges of finding skilled labor. So we're all hearing about, challenges finding skilled labor in kind of manufacturing facilities. Automation can help overcome this challenge. Another key one as well is the high costs of the kind of labor. So as the cost of robotics come down or other kind of automation technologies come down, eventually it comes to a point where it's more cost effective to use automation than actual kind of physical labor. It's quite topical at this point. I think it was last week or maybe a week before there was some strikes in the east coast of the US. And the last I heard, I think they were settled, but they agreed to raise the salaries of the port workers. And at a later date, they're going to discuss, what their views on automation are and if they're going to bring it into the East Coast ports. Obviously, for the managers of these ports, this is something they want to avoid. Obviously, they don't want to have to keep discussing and renegotiating the costs of the salaries. And also, they don't want strikes, which are disrupting the operations. So this is one of the key drivers of automation, of course. That leads on to the second point, which is new applications. So if you need to use maybe AGVs or AMRs as a replacement for perhaps human labor, then of course you can't. It's not practical or feasible really to connect that with cables. Obviously, there'd be cables all running all over the place, and they might come unplugged and things like this. So really, you need to use wireless for these applications. And there's quite a few different points on the board, but I'll just summarize a couple before we move on. Basically, many of the kind of shortcomings of cable are also becoming increasingly more apparent as we increase the number of devices in these networks. So cables, they use up a lot of floor space. They have wear and tear during the use, which increases the chance of them going offline. And I think also as well, when you are refreshing or you're troubleshooting the network, wireless, of course, it offers some advantages because if it's wired, you've got to turn it offline, you've got to perhaps replace the cables, things like this. Wireless is, you don't need to do that because it's, you can do it all remotely. So when an industrial facility is looking for their wireless technology of choice, we've found that typically Wi-Fi is the technology which they are turning towards. To kind of reinforce this point, I've shared some recent survey results from a survey that ABI Research conducted of industrial manufacturers. We conducted the survey in the US, Germany, and Malaysia to give that kind of broad global coverage, but these are results from the US participants. We asked them of the deployment levels of different technologies. So you can see there's loads of, I don't know, digital twins, for example, private 5G on there, machine vision. Of all the technologies, industrial Wi-Fi was at least from the responses we got, it was the most deployed technology. So I think this really highlights the confidence that industrial facilities have in Wi-Fi and also their familiarity with the technology. So when they are deploying Wi-Fi, what is the technology which they're deploying? This is one which may be a surprise potentially to some of the audience here today. The industrial market is really divergent from the enterprise market. It's vastly different. Often the key vendors are different players. They're deploying different technologies. And what really highlights this is that the majority of the shipments are still of Wi-Fi 4 today, so 802.11n. I think it was first introduced in 2008, so obviously it's considered a really legacy technology in the enterprise. But in industrial markets, this is still the predominant technology today. If you're looking at some of the key vendors in the market, like Siemens, for example, most of their shipments are still of Wi-Fi 4 in their ruggedized industrial wireless LAN access points. So this is still the majority of the market in the industrial space. So over 50%, just over 50% in 2023 were of Wi-Fi 4, and about a quarter for Wi-Fi 5 and Wi-Fi 6 respectively. So you might be wondering what happened to Wi-Fi 5. That's in orange on this graph here. Still significant numbers, but it never really took off in large scale in the industrial market. Several reasons for this. One is the life cycle of the equipment in the networks. If you installed Wi-Fi 4 clients in, say, 2010, and they're going to be in place for 15 years, which is maybe quite a short time frame in the industrial market, then obviously you're not going to replace your access points with Wi-Fi 5 in 2015, for example, because all the clients are going to be Wi-Fi 4. But more importantly, many of the features of Wi-Fi 5 introduced are very beneficial for enterprise and residential networks, but they weren't so closely aligned with the needs of industrial networks. So that was why many vendors within the industrial wireless LAN market chose to bypass Wi-Fi 5 in their product portfolio and jump straight from Wi-Fi 4 to Wi-Fi 6. And many Wi-Fi 6 access points, ruggedized industrial wireless LAN access points, so that's quite a mouthful, they're coming online now. They're being introduced to the market. And we foresee that Wi-Fi 6 will see rapid adoption in the industrial market because it has many features which are closely aligned with the needs of industrial networks. Key amongst those is compatibility with the 6 GHz spectrum, which we'll talk a little bit more about in a moment. After Wi-Fi 6, which we foresee in shipment terms will become the predominant technology in 2026, we've then got kind of Wi-Fi 7 entering the market. And then further down the line, you've got Wi-Fi 8. A couple of words on those two technologies. Wi-Fi 7 is introducing loads of really beneficial features, including MLO, which you've probably heard a lot about in the show. And it's focusing on really delivering extremely high throughputs. This is really valuable for many enterprise applications and also residential applications, but it's not so closely aligned with the needs of the industrial networks. Because industrial networks are really focused on reliability. So Wi-Fi 7 will see some adoption, but of course the access point vendors want to get ROI on their investments into Wi-Fi 6, and there's a development timeline. It takes a little while to develop Wi-Fi 7 equipment as well. So what we foresee is Wi-Fi 7 will probably see a similar trajectory to Wi-Fi 5, and then Wi-Fi 8 will see really significant levels of adoption because of its focus on ultra-high reliability. If anyone wants to dig into these dynamics a little deeper, we can discuss it maybe later on because it's a little bit complicated to get across. But basically, in the industrial market, we're seeing like a skipping of the protocols. So Wi-Fi 4 to Wi-Fi 6, most likely then to Wi-Fi 8. I want to spend a minute or two discussing about 6 GHz. I mentioned that this is the most exciting innovation within wireless LAN for industrial environments. You can all imagine why, because of the additional capacity which it is offering and also helping to reduce interference and increase reliability. What we've done here now is shown our shipment projections for the industrial wireless LAN APs, but in terms of 6 GHz support. Last year, it was a very low number, obviously, just under 3%, but it's going to rise very rapidly over half, I think, in about 2027. And in 2030, it's going to be about close to 3/4 of the market. So rapidly going to adopt 6 GHz in industrial markets. The reasons why, I think, are pretty straightforward. But there's two things I want to note within 6 GHz in industrial. The first is that AFC systems are going to be really important in industrial networks. This is because automated frequency coordination systems, I'm sure most people in the room know, but they essentially scan the 6 GHz spectrum, check for incumbents first before they enable standard power 6 GHz transmissions. These are at 36 dBm, so they're a higher power than the very low power indoor requirements, which are set on standard on normal transmissions. AFC systems, they enable those higher power transmissions, but they also allow for external antennas, and these are really important in industrial markets. So without AFC systems, yes, you can't transmit at standard power, but you're also not allowed to have external antennas. So obviously this is really vital for industrial environments because you need the external antennas to fine-tune the transmissions. So AFC systems will be vital in industrial networks. And also, we're seeing that it's more of the space, not the cost, which is a key determinant of 6 gigahertz radio inclusion in industrial networks. So basically, in enterprise, they're very more cost sensitive. Yes, aesthetics is important and performance and everything, but cost is a real key driver, maybe probably the key determinant whether you're going to include a 6 gigahertz radio or not. In the industrial market, probably the outcome is really key. They need to make sure they get the best solution for their needs. But because they've probably got additional funds to pay for an additional radio, but the compactness of the equipment is really key because you've got to put it, maybe install it on an AGV or an end of a cobalt arm or something like this. So it's really the compactness which is key. So you're going to be seeing that it's the size, not the cost, which is the key determinant of the 6 gigahertz radio inclusion. Wrapping up, I wanted to quickly discuss some of the other kind of hardware and topology trends in industrial Wi-Fi networks. The first one we've already touched upon, compact designs. I think I will maybe highlight 3, just in the interest of time. Enhanced security, this is really key. At the beginning, I mentioned about how industrial networks, they often prioritize wired over wireless. One of the key reasons is because they believe that wired networks offer a higher degree of security. Obviously, this means that Wi-Fi or industrial wireless LAN vendors, of course, need to bring in enhanced security to alleviate these concerns. Ease of implementation is another key one. When we've got the challenges finding skilled labor and maybe system integrators who can install these networks, if we're using zero-touch provisioning and auto configurations, this can be a way to both accelerate the deployment and also to overcome any challenges you have perhaps in finding the skilled engineers to install the networks. Simplifying installation is beneficial in many regards. So this is why it's one of the key focuses of innovation. And a final key one is sustainability. So this, I think, is globally, Europe obviously sees this as a major concern. It's one of the top kind of priorities, but it's also important in other regions as well, both for the meeting of ESG targets and then also for bringing down costs of running the network. Obviously, if you can reduce the energy consumption of the equipment in any way, that reduces the costs which are involved in powering the network, and that just improves the bottom line basically. So helps move the needle for the business. So that's why it's a key KPI for the development of new industrial wireless LAN equipment. So thank you for kind of listening to the key takeaways there. We've probably got maybe a very short amount of time for any questions if anyone wanted to jump in. And yes, please shoot away.
So the economics don't really support, shall we say, a fully redundant AP. It just, I notice you have a redundant power supply put up here, but in the past, telecoms and whatnot have looked to fully redundant CPU stuff. It doesn't exist for this. Is that right?
I mean, I think what I'm referring to here is redundant power supply within this individual AP. But yeah, I get your point about having a redundant kind of second access point, right, for a fully redundant network, basically. I think that has been something which is redundant power supplies and a redundant kind of networking equipment. They have been around for many years already. But I think what we're seeing now is just an increase in the redundant power supply in power supplies in individual access points. I think potentially the driver behind this is it's a way to kind of lower the costs while still increasing the kind of reliability of the equipment. I don't think it's going to replace the need for redundant equipment, but it's maybe just a trend which increases the reliability. So, yeah.
A question here.
For this particular market, is there a separate set of suppliers? Could you talk about sort of suppliers, market shares in this market, access point, and then maybe also client side? Who are the players in this particular segment?
Yeah, I mean, I could probably do a whole presentation on that because it's a completely separate market from the enterprise market. So you've got key kind of vendors. I mentioned like Siemens, for example, is a really major vendor in the industrial wireless LAN access point market. You've got other, HMS Networks, for example, is another German vendor, which is actually a very large position in this market. Phoenix Contact, for example, is another major vendor. So these are vendors which you won't really see in the enterprise market, right? Moxa is another one. So there's a whole range of vendors out there. Unfortunately, I haven't got any kind of data with me today to kind of show you the kind of market shares of them, but you have got some enterprise players who are active in those markets, some of the members of the WBA. And some of their strengths are of converging the industrial markets with the enterprise markets. So what the industry might call converging of IT and OT. So vendors who are active in both markets, they're really good at converging the two. But this also is sometimes not wanted from the industrial facility because it then again adds additional kind of concerns for them around security, right, and vulnerabilities into the network. But to summarize, yeah, it's a completely different set of vendors for the most part between the networks. Yeah, I'm not sure we've got time for more questions, or do we have to run on to the... Okay, right. So unfortunately, we've run out of time for this section, but we can catch up later on if we've got any more questions on the industrial market. I'd be happy to answer them. So great. So now we move on to the second presentation. Yeah. So, and my apologies for hurtling through. I tried to cram so much into a short space of time, so might have moved faster than needed. But next up, we have Christian Holz from Deutsche Telekom. And yeah, please.
All right, thank you for the introduction. Those of you who don't know me, I'm Chris Holz. I'm a senior product manager at Deutsche Telekom in-flight. And I'm here to talk to you about operator requirements for in-flight Wi-Fi challenges and opportunities today. So for those of you who don't know us, we are a dedicated in-flight Wi-Fi business unit called In-Flight Services and Connectivity. We sit within Telecom Global Carriers, and we are part of the telco startup that is Deutsche Telekom. Just some key facts about us. Most of you probably are familiar with us, so we are the largest MNO or telco company in Europe, and then we also have T-Mobile US, sort of our crown jewel in the company. We have been doing in-flight Wi-Fi for almost 15 years now. We are the ISP for several large airlines, including the Lufthansa Group, Cathay Pacific, and other airlines. At the moment, we have around about 500 aircraft where we're operating the service. We do offer, together with our satellite partners, the ISP service, so paid portals, apps, building in-flight Wi-Fi roaming, and all the good stuff that is related to in-flight Wi-Fi. So to sort of give you an overview, what has happened since the pandemic, because, I mean, the pandemic and COVID has been traumatic for every one of us. A lot of individual things that have happened and impacted a lot of industries, entertainment, sports, etc. But also the aviation industry was heavily impacted, including the in-flight connectivity section of the industry. So since the pandemic has sort of faded away and we have returned to some kind of new normal, the IFC market has grown significantly, and there are, as you can see here in the chart, projections that it will keep growing for the foreseeable future, which is a good thing for all of us in that industry. We do see some growth, and I just took out a random example, could have also been Intelsat or Panasonic. We do see a significant growth with the so-called legacy carriers, the incumbents, the Viasats, the Panasonics, the Intelsats, offering their services on more and more airlines. So sort of the last unconnected global space is being connected as we speak. But quite recently, in the last several months, basically we can see our industry being disrupted in the front of our very eyes because Starlink has decided to enter the market. Those of you who are not familiar with Starlink, it's basically Elon Musk's satellite LEO constellation. They have won several airlines. It started out with Hawaiian. People sort of noticed, and then they continued with Air Baltic and another small carrier, I think WestJet. And then the two big bangs happened. So Starlink's going to take over 2,500 airplanes from the existing MSPs. Wi-Fi will be for free. Starlink is promising very good user experience, very good throughput, low latencies, and all the things that are related to the LEOs. And then I think 2 weeks ago or last week, Air France announced that they're cooperating with Starlink, and Starlink is going to replace all the existing MSPs on their entire fleet, so long haul, short haul, and whatever fragmentation they have had, Starlink will take over in the next couple of years. Obviously, that's not going to happen overnight. You need the aircraft to be on ground, obviously, to do any new installations. It will probably happen more during wintertime, especially with the continental fleets where you have less frequencies in your flight schedule. But this was a really big announcement, at least for the people in the IFC world. So we'll need to see how it pans out, what the impact is on us as DT in the ISP role, but also what will happen with our partners, and then also how will the MNOs react to in-flight Wi-Fi potentially being free everywhere. Because, excuse me, in a nutshell, what happened since the pandemic, it's growth and disruption, that we can now see. Because there's a telco opportunity, so I strongly believe in-flight Wi-Fi, free of charge in-flight Wi-Fi with high speeds, unlimited data, basically like a at-home experience, is a perfect differentiator for MNOs, and also churn prevention. For those of you who are US-based and are T-Mobile US customers, you're probably familiar with this. T-Mobile US is giving free in-flight Wi-Fi to all of their customers. They have a tiered approach. Every customer gets a unlimited messaging sessions per year. If you're on the highest tier, so in their top 5G plans, you get unlimited streaming passes per year. If you're in the lower tiers, you get four full flight passes per year. So T-Mobile US has been leading the way here. We also, as Telekom Germany, have a proposition at the moment for our B2B customers. They can sign up for a flat rate, what we call in-flight Europe flat rate. So everything that in the Lufthansa group that flies within Europe is included here. And then moving outside of the Magenta world, there's, for example, Bell in Canada, on Air Canada offering free messaging. So I'm here today in a dual position, sort of almost a little bit schizophrenic, because I'm part of a very large MNO, and I'm also part of a business unit that deals with IFC. And there are certain challenges why MNOs are hesitant to sign up to promote in-flight Wi-Fi even further and to make it free and expand the footprint. So I obviously know why it is like that and what can be done, but for MNOs, especially for people on the retail side, marketing, and then also for management, it can be very challenging. So my message today is also to the MNOs that are here. I know you're interested, but we are also acutely aware that some of our potential partners lack the capabilities in terms of Wi-Fi. Wi-Fi platforms with MNOs have been unfortunately discontinued, at least in Europe. We are one of the last ones that have dedicated Wi-Fi platforms. And also the willingness to invest is not there at the moment. So here are some challenges. When we talk to our management outside of our global carrier organization, everyone's super interested. They think Wi-Fi is sexy, in-flight Wi-Fi is sexy. T-Mobile US is leading the way. They're getting very good feedback on the benefit itself, on churn prevention. But then you start talking to them about, okay, what comes with in-flight Wi-Fi, the complexity. You know, their eyes sort of glaze over and you lose them, yeah, when you start talking about things like Passpoint and open roaming and roaming standards and RICS ID. So it is too complicated simply for MNOs at this point. So there's no simple plug-and-play solution. There's proprietary onboard components, onboard software from the MSPs, also the ISPs. And seamless access is required and requested. So everyone's sort of waiting for Passpoint, but it's not yet readily available due to implementation. It takes time, and also some of aircrafts having old hardware. And then it's the benefit communication, externally and internally, because if you want to offer it for free as a fantastic benefit for your customers, it's a cost case. Yeah, airlines will fight you if you want to resell that, and rightly so. So it is a cost case. You need to have marketing budget for that. That's what T-Mobile US is doing. But the benefits perceived by their customers offset the marketing budget they set aside every year for in-flight Wi-Fi. And then it's internally difficult. I said the cost and also the implementation, so you might have to invest a little bit of money there. And then also towards your customers, because it's another challenge, and that I'll speak to that in a moment, of the fleets being fragmented. Yeah? So your message will be, if you are my customer, I've got you covered, I have fantastic 5G Wi-Fi, I have fixed broadband, I have all the good stuff, and I'm also covering you, 30,000 feet in the air. But you can't be telling them, okay, on this flight from Frankfurt to LA, you have connectivity, because we have an agreement with Panasonic and it has in-flight connectivity, but on the flight from Frankfurt to Palma de Mallorca, because it's a different airline, different vendor, you don't have connectivity with us. So it's very hard to communicate that. And then that feeds into the scalability point. It's just hard to scale everything. And then my message here also for ourselves and our partners is in-flight Wi-Fi needs to be simple, robust, and then the MNOs will sign on. So what are some of the challenges in the industries? I'm going to speed it up a little bit. Airlines have multiple ISPs, like for example Air France I think had 3, and also multiple ISPs. That creates a need for multiple commercial agreements and also multiple technical implementations, something that for such a niche but sexy topic not everyone wants to do. And then the user experience can be clunky. As you say in German, you have to touch your own nose. For example, we do offer still a portal that has, for the user to reach it, they have to go through a captive portal, through an airline portal, and then they reach our portal. That's the way it is at the moment. That is the industry standard, but that doesn't mean that it's necessarily good user experience. T-Mobile US is a little bit further ahead of Telekom Germany. While we have this credential-based login on the portal, they just do a number verify on the airline portal, for example. I think this is United, what you see here. Yeah? So the customer journeys are not intuitive. That is the most feedback that we get. Legacy access methods like CNAs and apps are a good thing. They work. But they can be improved upon. And seamless connectivity, Passpoint, open roaming is wanted not only by MNOs to offer good user experience and to have security by the customer, but also by the airlines. A lot of airlines have woken up to Passpoint because then they can enable their loyalty customers, for example, to have an additional perceived and actual benefit from their airline. They have a Passpoint profile on their phone. They can connect to the Wi-Fi on Lufthansa, and when they reach their destination, for example, in the US, they can roam with additional Wi-Fi networks. Yeah? So those are some of the challenges and the opportunities that I see from our viewpoint. I've spoken about the retail advantages, but in terms of technology, it's a neutral access hub alternative authentication methods. So basically a spider in the web that's connecting everyone. From a technology point of view, yeah, so an entity, for example, us in Europe, someone else in Asia, someone else in North America, that is connected to all the MSPs, but also in some extent to the airlines, because some airlines run their own connectivity business with Passpoint, with open roaming, and what I call a managed Passpoint service, where you enable MNOs who do not have infrastructure anymore to be able to distribute Passpoint profiles and then authenticate against that. And then in terms of business models, what we foresee is brokers for the MSP. So we facilitate the business, take a fee or revenue share, or we resell ourselves, or we become a wholesaler, buy certain capacities and then resell that at our own risk. So those are the opportunities that I see in terms of technology and business. And then some ideas that we're working on. Unfortunately, my colleague Deep is no longer here. So you've heard about Passpoint, you know app access, you know number verify. We're also thinking about using some telco standards to use them in the in-flight Wi-Fi context, at least for Wi-Fi authentication. For example, KYC matches, so know your customer matches, where your customer provide a phone number and then their birth date or their last name. Those are API calls. It's all standardized. Telcos can sign up to this program, so it's pretty straightforward. And then also the number verify. Thank you for your attention. I appreciate you being here at this late point of the day. So yeah, if you want to get in touch with me, please feel free to reach out, be it by email, phone, or LinkedIn, OWL, or whatever. I'm looking forward to hearing from you. Thank you very much. Are there any questions? We have 10 seconds to spare.
Thanks. Hi. So who owns the main portal on the plane? Is it the airline or Starlink or something? Because presumably the airline is going to want to say, well, first off, if you're a frequent flyer, enter your code number or you do it in your app on the phone. Yeah. Then we've got a roaming deal with these MNOs, and maybe if you're, I don't know, a Marriott, Premier, whatever, we've got to deal with the hotel companies as partners as well.
So the portals are owned by the airlines. They do think still that their content is so attractive that passengers will stay and they can make some money out of that. I'm just being blunt. I don't think that has transpired for a lot of them. So I think with the additional access methods, Passpoints, which they can also engage in and give their users or customers a better user experience, I think there's an opportunity for them to say, okay, if someone comes along with a Passpoint profile, I can have an interstitial page with some advertisement that is curated for higher, even though I hate that term, higher valuable customers of higher value, because I know for them in-flight Wi-Fi is somehow included either because they are a super duper customer with Telecom Germany or they are my HON Circle member. So I can show them, you know, a Rolex or a Ferrari advertisement rather than what to get for lunch in Paris, right? So, but to your point, the touch point is usually owned by the airline. I do think with the roaming conversation, you can shift that a little bit. You can show them, you know, it's a good thing. You're offsetting your cost if you're providing it for free. Yeah. No, that's true. At the moment, it's purely for phones, for smartphones. I mean, but laptops are also Passpoint capable, so that's something we can look at. But to speak from experience from the data, on long haul you see more laptop usage because people tend to work more. But especially on continental flights in Europe, it's 95% phone. Yeah. And we had this discussion when we spoke to our retail people, and they were like, no, we're giving them that for free, but it needs to be in the phone in our app so we can keep them there. And that's the benefit of being a Telecom Germany customer. Okay. think last question, and then I'll leave.
Thank you very much, Chris. Fantastic presentation. A very quick question to yourself. What you believe is really the number one point hindering the adoption of in-flight connectivity? I could name a few, right? I mean, from the satellite capability, right? The competition, the business models, the operators, pass point technology. What you would say is really the number one?
I would say it's the clunkiness of the access methods and the lack of knowledge. Because I say clunkiness and it sounds negative. You need to be able to do certain steps until Passpoint is readily available for everyone, or open roaming. And they're simply, it's like, I don't know what I don't know, right? So we need to create awareness that it's there, that it's a perfect benefit, and then we need to make the journey to that benefit as easy as possible. Because, like I said, it's a perfect benefit for your retail customers. It is proven to improve loyalty and prevent churn, right, which we all want to achieve, because sort of MNOs are sort of interchangeable these days. But it needs to be easy. Yeah? So we need to reduce the complexity. Yeah. All right. Sorry.
Great. Thank you, Christopher. And I'll add... Yeah. And I'll just mention that we'll have a panel session later on, and if you've got any more questions on that topic, you're free to present them to the panel at that time. So yeah, there'll be another opportunity. So next up, we have Christian Gilby from Juniper Networks.
Good afternoon, Christian Gilby here. I run product marketing for our AI native campus and branch at Juniper. And yes, I'm going to talk more about AI. But I think what's exciting is we're starting to see more signal than noise. I mean, a few years ago, a lot of noise. Everybody was jumping on the AI wagon and talking about, AI algorithms, but not tying it to the outcomes. And I think that's what I'm going to talk about, outcomes, and I'm starting to see more vendors doing that, which I think is great. Because ultimately, it's not just, hey, I want a cool technology to deploy. Yes, that gets you visibility in the company, but I think it's all about delivering better outcomes for a customer. When I first started here at MIST 2018, a lot of the fear we had from customers was, well, AI is going to take jobs. I think what people have realized is it's an enabler. Yes, the IT teams your teams need to get comfortable with AI, how you can use it, where you can use it, but it's allowing you to scale. More devices come in. Maureen was talking about 21 billion Wi-Fi connected devices. That's 2.5 devices per person on the world. How do you support those devices? And that's where I think AI Ops can really help to support those and scale your teams. You look at every connection counts. I mean, what can you do in your day without having a great wireless connection? Wired connection as well, if you're coming in that way. It's become business critical, as well as for your personal life. If you're not connected, you can't get things done. So it counts a lot, but there's some challenges. If you don't have a great connection, somebody like an Amazon, an hour outage in their distribution center can result in about 33 million euros in lost revenue. Or somebody like a BT, if they lose 10 seconds of video coverage during the Olympics, you're going to miss the 100-meter dash. Or somebody like a school district, Capel ISD here, a lot of learning has moved digital online. If the network's down, 13,000 students can't take a test. Huge impacts if the network doesn't work. And I've heard that today from a lot of vendors. There is a lot of focus right now on understanding the experience. It's not just about, do I have a great deployed network, do I have good coverage, but are the apps running well? Veterans administration, healthcare, you lose visibility of your patients for 30 seconds. Somebody from the mental health ward could get themselves in danger, walk out of the hospital. They're fundamentally broken. I mean, how many times do you talk to your employees, customers, and they just don't have a great connection? So we really need to step back. I mean, a lot of these I've resonated with at times. You connect to the network. I've got 4 bars of Wi-Fi, but my Zoom call, my Teams call doesn't have a great experience. Or the internet's down, but there's no outages. I can't get to the network. And it could be anywhere. That's why you've got to really have this client-to-cloud view. It could be the wireless network. It could be the mobile device. It may even be, let's say, a DNS server somewhere on the network. And you need a different approach. You really need to start looking experience first. And ultimately, what's the experience the user or a device, in the case of IoT, where it's a headless device, and ask these questions, to understand what the experience is going to be like. Ultimately for end users, you want to have flawless experiences. Things like in an engineering environment, be able to share code quickly, or in a retail, customers, shoppers can find what they need, or in an enterprise or financial space, you can get your business apps up and running. And in the education space, students, can connect, collaborate, do online testing. But it's not just the end users, it's also got to be a great experience for the IT teams. You want a network that optimizes itself, reduce the trouble tickets. Do you really want your IT team spending all their time doing packet traces trying to understand an issue? No. The technology's there to look at the data, the telemetry, and find the root cause without having to spend all this time looking into it, or even doing a site visit, doing a truck roll where I've got to actually drive to a store and go and actually troubleshoot that issue. You also got to you want to speed up. How long does it take to roll out a network? Especially in the Wi-Fi space where the technology is changing. 6E came out a couple of years ago. We've got Wi-Fi 7 now. So there's a constant cycle as you look at upgrading the technology. You want to make it seamless as you migrate. And then when you have issues, because they'll happen, it could be, the network infrastructure, it could be the client. You want to speed up the time to get to a resolution and find that problem. And that's where, we believe, and I'm starting to see this, throughout the industry, is you really want to focus on experience first. What does it need to deliver for the end user? Can it adapt if there's issues coming in, for example, interference? And you really need to start from, you've got to have the right infrastructure, so a secure infrastructure, the right data. So I've got to get the telemetry from the client devices, from the network infrastructure, so that ultimately my AI engine can then find the right response, i.e. it sees there's an issue, identifies an anomaly, and then can actually look at what is the root cause of that issue. What part of the network or configuration is causing the problem. And it really needs to span, in my mind, client to cloud. You've got to have, you can't just look at Wi-Fi or wired. You've really got to look at the full end-to-end picture, from the client all the way up to the cloud or the server where the application's running. I'm going to dive a little bit deeper next into AI for networking. That's where we use AI ops to make the network better. The other area that's getting a lot of attention right now is networking for AI. So a lot of customers are starting to build these AI data centers. You've got to have a great network to interconnect it, because there's a lot of data moving around the network. So let's jump into AI for network, and more specifically focus on Wi-Fi experience. Where does it all start? You've got to have great data. As our Chief AI Officer, Bob Friday, always likes to say, he makes a couple batches of wine every year, and he needs good grapes. He said, for AI, it's all about the data. If you don't have great data and telemetry, the AI engine is not going to be able to find the problems and root causes. So it starts with the data. And then you feed that into what I call AI primitives, or an event timeline, basically taking knowledge of the wired network, the wireless network, and making some sense, coalescing this telemetry into a service level expectation. Basically, a graph looking at what's the quality of experience, be it roaming or an application. And then leverage a data science toolbox. You've got to have a rich toolbox to look at detecting things like anomalies, optimizing channel settings. And then how we've started to see it evolve even further is, now how do you interact with that, with the AI engine? We're starting to see more conversational assistants come out, where instead of having to go to a UI or read a manual and look at CLI to understand what's going on, just ask an AI assistant. Are there any users having an issue right now? And then it can actually go and look into the system and find those issues and allow you to troubleshoot it fast without waiting for the help desk call or help desk ticket. I think ultimately it's going to this self-driving framework or self-driving network where the network will find a problem, identify the fix for it, and then actually apply it. Are we there yet? No. And I think in two ways we're not there. I mean, we're starting to see a few self-driving things where the network can actually go and resolve it. But I think also IT teams, to be honest, are not completely ready for that. You know, you've got to have trust in the AI engine that it doesn't detect, you know, a false error and then makes a fix which actually breaks the network. So I think there's a trust element as well. So I think it's important to bubble this up in when you find a root cause and an action, allow the administrator to look, you know, is it the real root cause of the issue before you unleash and have the system actually go and do everything for you. AI is the new electricity. I believe that. There's a lot of buzz around it, but I think it's really changing, you know, not just the networking industry, but even our lives. You know, I had actually been playing around with ChatGPT. 2 months ago, I was going on vacation up in Western Canada for 5 days, and I asked ChatGPT, plan an itinerary for me. You know, I like to hike, I like museums. It was mind-blowing what the systems are able to do now, to actually, you know, take your inputs and then basically craft something for you. And we're starting to see that, you know, across our business lives as well. So I really see there's 4 areas. So there's supervised learning. This is where you actually go and train the AI engine. So what to look for, you know, what the data means, basically tagging the data. You've got unsupervised learning where the AI engine is not getting trained on what to do. It just figures out, you know, how to proceed and what to look for. Reinforcement learning, this is where basically it's getting rewarded to optimize something and basically starts to learn. And then Gen AI, a lot of buzz around that with things like ChatGPT, but being able to interact with a user on par with a human. So the first area is supervised learning example here. You know, we're seeing it in the networking space, being able to identify issues. So, you know, I see this and I look at this as kind of like my cup of coffee view when I come into the network dashboard. You know, there's 37 issues in the network. I can then go click on these, see what the issue is, and go and assign that somebody to resolve it. You know, other areas we're seeing this is where, you know, service level expectations, trying to understand what the application experience is, and then reporting that back to end users. You know, the second area around unsupervised learning, I'm seeing this used in technology such as indoor location, like Bluetooth Low Energy, eliminating the need to actually go and do a site survey to calibrate the network or map before you go and deploy. Deploy it, the system, the AI engine starts to learn as the user's devices walk around the network to triangulate location. Reinforcement learning, see this used in AI-driven radio resource management. What is it if you're not familiar? Basically how you tune and optimize the Wi-Fi settings. You know, we heard about it this morning. There's a lot more channels, which is awesome, spanning 2.4, 5, and 6 gigahertz. But it does mean a lot more configuration. You know, now we've got channel widths up to 320 megahertz. I don't think you'll see 320 in an enterprise environment because there's not many channels available. But, you know, even if you talk 80 megahertz channels or 160, there's a lot of channels. And how do you optimize those? You know, back when I started in Wi-Fi 2002, we had 3 channels. Well, some people use more than 3, but 1, 6, 11 that were not overlapping. It was a lot easier to, you know, tune those so that you minimize interference between neighbor APs. It has gotten so complex now. You know, you're talking 3 bands or frequencies, multiple channels. We have things like different channel widths, and then power settings. So how do you optimize that? And that's where I think it's really tuned for, you know, AI technology to basically look at, tune the network, observe what's going on. Did the settings actually improve the experience or make it worse? Also, we see things like in the 6 gigahertz and 5, where you have, you know, things like AFC and DFS, where they overlap things like public radar. And if there is a radar event, you have to avoid that channel. Well, wouldn't it be great if the system would learn that and now start to avoid that? At this office, I quite often have radar trigger events, and then I can tune the network for that. And then Gen AI, which is, I'd say the newest area that we're seeing is, being able to interact with the user interface just as if you were talking to one of your peers. I mean, I think of it as having an assistant as part of the IT team. When you're trying to troubleshoot an issue, just ask the AI assistant, or documentation. Instead of having to go look through documentation, just ask the assistant, how do I go and configure WPA3 settings or something I haven't actually gone and configured in the network. So those are kind of the four big areas. I'm not going to dive through here all the algorithms, maybe just highlight a few. I mean, one area that I'm seeing in terms of anomaly detection, this is when you've got, for example, the network's running great, the performance is great, but all of a sudden I have some event happen. That's what we call an anomaly, and let's say the performance or experience drops. Using things like long short-term memory neural networks to detect that accurately, so you don't get false positives, but you identify it. Things like, k-means clustering is an algorithm you can use to basically look at scope analysis. For example, when there is a problem, does it affect one user? Is it a whole site or maybe an access point? So being able to identify these root causes of these issues. And then, as I said, reinforcement learning, using that to do things like tuning the Wi-Fi settings. It's gotten more complex, and it's only getting more complex. You want to be able to automate that, so your IT team isn't chasing these configuration settings. The other thing you want to do is, once you have the AI engine running, is you want to checkpoint it. So basically, when there is an issue, start to look at, did it find the right root cause of the issue? And if it didn't, did it have the data? Because you really want to feed that back so that you start collecting the missing data. So that ultimately you'd get to 100%. Every time the AI engine finds a problem, it is a problem and it doesn't miss anything. Will we get there? I don't know. But you want to try and basically monitor your engine and have the feedback so you start updating it. This also drives trust. As you see that the AI engine is finding the problems, and when your team goes and investigates it, is a real problem and that was the root cause, you get more confidence then that ultimately we can move towards a self-driving network, where now you flip the switch, the network goes and changes the configuration when it finds there's a problem. For example, a missing VLAN. Let's add the VLAN config so that you don't have to go and do that manually. Some of the examples, just, kind of wrapping up here, a few examples of outcomes, as I've talked about. I mean, save money. For example, when you're going and deploying, reduce the time to deploy APs, effort when you implement it, reduce trouble tickets. I've seen, as I talk to some customers, 9 times faster to deploy. Fewer truck rolls, example there. When there's a problem, have the AI system capture the data so the IT team doesn't need to send an engineer on site with a laptop to go do a sniffer trace. The technology's there today. Leverage it. And then self-detecting. You want to ultimately cut down when an end user calls the help desk. So if I can have the network find the issue, root cause it, resolve it, it's going to be game changing. Your users are going to have a better experience, and you're going to spend less time chasing ghosts trying to find these issues. So ultimately it's about delivering better connections, better experiences for users. And I think that's where, things are moving as we start to get more insight into the network and leverage AI ops. So with that, I'll open it up. I think maybe just a couple questions here, if anybody's got one. Otherwise, you can find myself or Ben Wom on my team after the session or in the evening events. All right, thank you.
Thanks, Christian. And you can, we'll have time as well in the panel to answer any questions. So you can have a think about what you want to ask Christian, and then you can present them then. So next up, we have Manish from HFCL, and he's going to talk about Wi-Fi 7 in the enterprise.
Good evening. This is, I don't know, by design or by accident, this is the topic that we're talking towards the end of the day, as if we are wanting to summarize the whole day's processing. And, through the day, we have been talking about Wi-Fi 7, the new kid on the block, and many, potential, the great capabilities that Wi-Fi 7 is bringing to the table. So what I intend to do is to really give a summary to the whole conversation on Wi-Fi 7 and try and see how the enterprises, have evolved over a period of time and how they can use the capabilities that Wi-Fi 7 is bringing to the table. So let's dive into the journey. This is sort of a little bit of evolution of Wi-Fi as a technology, but I've tried to superimpose it with how the enterprises and their requirements of Wi-Fi have evolved over a period of time. More or less, if you see the timelines, they coincide. For example, now we are talking about Wi-Fi 7. Going back 2020 was Wi-Fi 6. Before that, Wi-Fi 5 and Wi-Fi 4 and so on, right? Enterprises have been evolving, looking at Wi-Fi to begin with, right, was only a wireless LAN connectivity, right? You get into the office, most of the time, so you would have a laptop, you would like to get connected. From wired connection, everybody moved into talking about, connected over wireless, and you can move around. So the user mobility, and before that, when we were looking at how do you basically sign in, there was a little bit of a conversation around security, and initial WPA and some of those standards came around to address how do you join. The situation became complicated as soon as BYOD came into the play, right? And enterprises now were allowing not only the enterprise provided computing devices to the users, but users were bringing their own device, which is coming in with no security posture that the enterprise could think through. And when you brought in that into your network, wired network always had a great network admission control onto the devices. This network admission control became a sort of a need for on the wireless LAN network as well. So we started to address that, and then came in the problem statement, right? That the LAN, the cable LAN, was always higher speed than what the wireless connections could offer. So the next Wi-Fi 5 and Wi-Fi 6 that we looked at started to address how do you increase the speeds, and came in new channels, the bands that we needed to open up to get higher bandwidth, which could allow higher speeds. And then came in the large, this is like coincident with the 4G launch, right? 2017, 2018, when a lot of venues started to show up, right? Stadiums and conference halls like this, where the user density was extremely high. And people were always, wondering, what kind of reliable connectivity that you could get. So the client density increased, number of people coming into the network increased, and then other thing that happened was that how do you basically extend the range of these Wi-Fi access points so that you could you can cover the large areas, large spaces fairly efficiently. And now we are here today and for the last few days that we've been talking about, last few quarters we've been talking about, how can we address the capacity, the latency aspect? How do we ensure that there is a lot more reliability into the Wi-Fi connectivity than what has been on the offer, right? And that's why in that connection, Wi-Fi 7 became extremely important. And I always try to draw this analogy of development of the 3GPP technologies along with the IEEE technologies, and I always felt Wi-Fi 7 is fairly equivalent to what 5G is, and therefore it has to get its own place into the marketplace, right? We have had massive hype on 5G, where we've been talking about how the industries will get transformed with the private 5G and things like that. But I think everything that 5G can do, possibly Wi-Fi 7 can do. And let's look at it how, right? So high capacity and high client density, right? With the 320 megahertz channel, on 6 gigahertz, we are talking about the peak rates going, extremely high. These peak rates that we're talking about are, not realizable even on the 5G network today, right? But we should be able to realize them if 6 gigahertz regulations, across the globe are taken into the consideration in favor of, unlicensed band, requirements. More users can be scheduled into the same frame because of the same, widening of your channel. 320 megahertz, you can have a lot more users coming into that. 4K QAM, a step over 1K QAM that we used to have in Wi-Fi 6, and that basically is giving us 20% more throughput, but at the same time, it's allowing us to schedule a lot more users in the same time. The technology on MIMO has been around quite some time, even in Wi-Fi 6, but multi-user MIMO is the one that really starts to gain a lot more prominence when you have a lot of bandwidth and the channel available for you to put the users into the same frames and be able to service their bandwidth needs. Then the other aspect that we've been looking at, how do you bring in the efficiency and the reliability, right? This is one aspect that we talked about, and though Andrew talked about earlier in the presentation that industrial environments might basically jump from Wi-Fi 6 to Wi-Fi 8 and may not adopt Wi-Fi 7 as much. My belief is that the kind of reliability that we're talking about makes a very compelling case for industries to start to adopt Wi-Fi 7. I would say, depending upon what's the cycle of refresh that they're going through, they should really start to consider deploying Wi-Fi 7 instead of doing Wi-Fi 6 or Wi-Fi 5, moving from Wi-Fi 5. So capability-wise, the multi-RU capability, this is a very key, capability that Wi-Fi 7 has brought in. You can give multiple RUs to a single user, which was not possible in Wi-Fi 6. Other than, increasing the size of the RU, if you are able to give them a user who's hungry, whose applications demand more data, you can give them multiple RUs and reduce their latency as well and channel access times. There's another beautiful concept that has come into Wi-Fi 7 is about the puncturing. The preamble puncturing is very key, from the perspective that our networks are getting more and more dense. There are many devices, many networks are showing up. So the interference is on the rise. As we're seeing a lot of public networks being rolled out. In fact, MNOs, telcos are trying to roll out their broadband networks or Wi-Fi or unlicensed band Wi-Fi using certain extensions, right? But the outcome of that you're going to see is a lot more interference, and therefore, interference mitigation techniques are central for us. Puncturing, allowing us to avoid the interference specifically without giving up the channel entirely is a brilliant capability that Wi-Fi 7 has brought in. So if you have 160 megahertz channel, 20 megahertz is seeing a lot of interference. You can just puncture that out, and rest 140 is available, which would have reduced to 80 megahertz in the Wi-Fi 6 or maybe 40 megahertz, depending upon where the interference is. So that's the second thing. And the third, another wonderful development on Wi-Fi 7 is the MLO, right? And it has got multiple flavors. Ability to select a channel on the fly is great, right? If my phone can use a channel depending upon is it 2.4 is more interfered, I should pick up the 5 gigahertz, and likewise, is one thing that will help us reduce the latency because your channel access is really, really fast. And then this is the case where you have only a single radio, right? So your multi-link single radio configuration gives you ability to access the channel really fast. The other capability, which is multi-link, multi-radio scenario, is even more, I would say, path-breaking, because now you can actually combine. In 3GPP, there is something called carrier aggregation. You could basically aggregate channels across all the bands that you're deployed and create a fat channel, right? You can do this with MLO and increase your, both the capacity as well as, the latencies, reduce the latencies. The other thing is about the implicit band steering, right? This is, band steering has been a challenging topic in the real deployments, right? The devices and the APs, right? APs, advertise what bands that they're operating in. The clients have to basically pick up the signal from the APs to be able to steer to the right band and things like that. The way implementation have been around, right, the band steering does not work as well as we would like it in theory. I think the MLO is going to help us make band steering a lot more deterministic, and therefore the experience is going to improve much further. Finally, let me come to the low latency part. This is the characteristics that basically directly puts in contention with whether a private network that we're going to deploy is going to be based on 5G, or it should be based on Wi-Fi 7, or should we, there should be a convergence of that, right? But the capability on low latency, sub 10 millisecond latencies predictably is the key for a lot of applications that we're going to see. And we'll talk about the applications as the different verticals have been looking at, but fundamentally what we're saying is latency anymore should not be the criteria for choosing whether you deploy a 5G network or a Wi-Fi 7 network. There are good cases to deploy the 5G networks, and you should look at that horses for the courses kind of opportunities. But the general statement that used to be given is that Wi-Fi latency is unpredictable, very high, cannot deploy critical applications. I think we need to relook at this with the arrival of the Wi-Fi 7. Of course, the implementations have to be really good. We have to pay attention to how the networks is going to get implemented to get the predictable latency going fast. But all these 4 capabilities that I talked about are actually adding to getting us a more predictable low latency scenario. And I wanted to now bring back as to what enterprises are looking at. I mean, the requirements have gone up from being just a connectivity provider for your day-to-day functioning. We're talking about most of the enterprises. And look I've used the word enterprise in a very generic terms. There are many enterprises that will fall into this bucket very easily, and there are some who will not fall into bucket, and we'll try and address them separately. But almost all enterprises have started to move their productivity applications from data center-based deployments to the cloud-based deployment. And when you move things into the cloud, your number of people who are accessing the cloud over the internet, over your Wi-Fi networks, have gone up dramatically. So large number of concurrent sessions, low latency, making sure that the productivity applications work very well is something that you can address. Collaborative working, another key aspect, right? Post-pandemic, we are now looking at a lot more people working from home, working from cafes, working from different places. So this is another application that has made the case for Wi-Fi 7 extremely important, because now high capacity, low latency, you can do telepresence, rich telepresence applications very, very easily. There's one common theme across the enterprises that you would keep seeing is the immersive usage of the XR, right? Both AR and VR technologies. And there's, by design, they require a very, very high throughput and predictable bounded latency numbers for you to be able to make difference. And the last one is the IoT integration. We will hear from our friend Shrikant about the IoT, so I won't go much detail, but fundamentally, the number of devices that are coming onto the network is increasing. Higher concurrencies. How do you make sure that the power consumption can be reduced, from the AP perspective, right? So this technology existed, target wake times, this was there even in Wi-Fi 6, but in Wi-Fi 7, with all the other things combined, we're really looking at, creating a difference for the IoT applications. So I would like to stop here, and if you guys have any question, I can answer, or we can answer through the panel because I've run out of time. So, Andrew?
We'll save the questions for the panel.
Yeah, we'll save the questions for right? Thank you so much.
Hello, everyone. Good evening. I'll give you a quick introduction to a new technology some of you may already know, but it's called Wi-Fi Halo. I work for a company called Morse Micro. We are a fabless semiconductor company out of Sydney, Australia, and we are the pioneers, leaders in Wi-Fi Halo technology. The company is growing. We are privately funded. Mostly engineering today, almost close to 180 people in the company, primarily focusing on Wi-Fi Halo for IoT applications. Some of you may already know about Wi-Fi Halo technology, but just to give you a quick overview, Wi-Fi Halo is a new standard, or it's an additional lane, I call it, on the highway of Wi-Fi, where you see 6 gigahertz, 5 gigahertz, 2.4 gigahertz. It's all about connectivity and speeds and feeds. Everybody's talking about high performance AI applications in your home, in your enterprise. But there is a fundamental change happening in connectivity in the industrial and enterprise space. There are many other verticals that we are trying to address, but based on the topic, I would like to touch base more on the enterprise connectivity challenge we are trying to solve. So Wi-Fi Halo fills a gap that exists today between where 2.4 gigahertz or 11N drops to where LoRa kind of technologies can take you. LoRa goes all the way to almost 10, 15, 20 kilometers, but at a very low throughput. So there is a gap in between for applications which require higher throughput at a longer distance. And in this case, we are talking about reliable 10 to 15 megabits per second at kilometer, which is fundamentally did not exist. So Wi-Fi Alliance has made an effort to define a standard that will fill that gap and address the need of the hour, which is connectivity around the industrial space, which industrial and enterprise space where every device, every building, every industry, and every machine, you can call it, is trying to get smarter, more efficient, and to improve the operational efficiency of the enterprise. So in terms of just the standard, it's a sub-gigahertz standard. It operates between low to high 900 megahertz range. It's fundamentally extends the range. Because of the sub-gigahertz nature of that, it's much better in penetration across the walls. As I mentioned, it provides much higher data rates than any existing technology today at kilometers. So this is the gap which we are talking about. It's a Wi-Fi standard. So in terms of for enterprise or industrial access points and in terms of software management, it's just another Wi-Fi technology. It's not a new radio that they need to implement. It's a different technology, different radio in the same access point, but like Wi-Fi, because it's Wi-Fi. In terms of implementation, this technology has gone and fundamentally addressed the low power nature of Wi-Fi for battery operated devices. So a lot of sensors, cameras, anything that are required in industrial and enterprise space can work on batteries. Today, AAA battery, in near future on coin cells, this will operate at almost 1.5 hours, 2 years of battery life. And that's how the technology has been implemented. It's security, it supports the same security as any other Wi-Fi technology, like WPA3. It's highly scalable, and to the point that standard allows over 8,000 clients simultaneously. Again, it all depends on its case-by-case basis in terms of throughput requirement. But today at Morse Micro, we have built a lab that we have over 2,000 clients already connected to the same access point. And we are pushing this envelope every day. And in terms of, again, because of the AI and various needs, these clients need firmware updates, not constantly, but over time, and OTA firmware update facilities also available. So just to kind of summarize, it's a new Wi-Fi standard addressing the IoT, highest data rate at range, and in this case, we are talking about 10 or 15 megabits per second, which sound very different from Wi-Fi 7 conversations. But this is reliable 15 megabits per second, 10 to 15, where there was 0. That's the fundamental change in terms of connectivity. It is Wi-Fi standard, so in terms of management, it's nothing different from IT management point of view, from industrial management point of view, it's the same standard. And there are many, many features which are very, very IoT-centric, especially on the low power side of things, which is very critical for these applications. That's it for me. Any questions? By the way, Andrew, do you want me to take questions right now, or?
Let's answer one. Yeah.
Okay, all right. Sure.
Okay. Who wants to be first?
Yes, hello. Thank you, it's very impressive. How do you position yourself against Zigbee?
I would say we don't position ourselves against Zigbee. I would say we are complementary to many technologies like Zigbee, Z-Wave, BLE. We are just a different standard in terms of addressing higher throughput at long distance. We are seeing, in terms of managing, or even in some cases power profiles, we seem to be, Wi-Fi Halo seems to be better. There are a lot, especially in case of access control, where Zigbee was one of the most common technology used. Now we are seeing transition to Wi-Fi Halo. And every customer, just, with all the attributes, it's very difficult to pinpoint, say, oh, for these 3 reasons, almost every customer is coming with a different problem they are trying to solve. And one of the most common, I would say, attributes seems to be, hey, we didn't want just another radio and figure out how to manage with a separate hub. If we had just another Wi-Fi radio, it would have been much easy. So that definitely there is underlying message. Thank you. All right, Andrew.
Yeah, great. Thank you very much, Srinath, for the presentation. And don't go anywhere, you've got to join the panel now. So. Yeah, so if we can invite all of the speakers from this session to join us on the stage. We'll have a brief panel session before we then move on to the awards ceremony for the WBA. So yeah, please take a seat. Don't get too comfortable because it'll be quite a brief session, I think. We're going to cram it into about 15 minutes or so. Yeah, so I think I've got tons of burning questions which I'd personally like to ask all of the panelists, but seeing as we had so many hands up during the sessions, are there any kind of really burning questions that any of the audience has? I thought it might be a good place to start with those first, seeing as we've got really limited time for the panel. Is there anyone who's got a burning question they'd like to ask the panelists on the stage here?
Where is beer? Maybe that's the burning question right now for everyone.
Yeah, please.
Okay, thank you. I think it's a question for Christian, because when you were setting up your presentation, you were talking about building networks, to enable AI, like all these data centers be getting connected. So I thought, oh yes, that's great. We're going to hear a lot about that, and then you didn't really talk about it. Is there anything that you guys have seen or are learning about that set of unique requirements in that environment?
For running an AI data center, do you mean, or?
Yeah, you said AI, using AI for the network management for Wi-Fi, that was one part, and then the other part was like, okay, well, actually, all these AI needs a lot of networking, and there's very unique requirements for running AI over networks. But yeah, do you have any color on what that takes, or what the unique requirements are there?
Yeah, I mean, leveraging AI for networks, I think the big thing there is looking at your infrastructure, make sure it's pulling the telemetry. I think the clients as well, like, Eric talked through Intel, just being able to pull that telemetry. And then in terms of building these AI data centers, the big thing there is it's a lot of data that you're moving around, right? You're pulling all this telemetry from the edge, feeding into, in a lot of cases, these private data center clusters where you've got, the AI engines and the GPUs. So I think the big thing, customers are looking at is how do we get the throughput and how do we do it? Is it over Ethernet? Is it other standards? So I think that's where we're seeing a lot of development right now between vendors. And, it's a new area, so there's a lot of collab between, the GPU vendors and the networking vendors.
Great, thank you very much for the question. And,
yeah, I have a question for Srinath. Wi-Fi Halo, your presentation didn't say what frequencies it uses? So
different, you can say, spectrums in different countries, but just to give it as an example, in North America is 902 to 928 megahertz. And there are 26 individual channels to work with, individual 1 megahertz channels.
Okay, so if you were deploying video surveillance as an example, the alternative could be microwave point-to-multipoint, right? So how does that technology compare to microwave?
I would say it's more to do with, I think, significantly much better range than microwave in those cases, and higher throughput to deliver the video. Because video, I think, definitely is one of the key applications we are kind of dealing with, or the most premier application we are dealing with today.
And in terms of having a not perfect line of sight?
Not necessarily, definitely. Line of sight, you get much better range. We just did some testing in one of the deserts where we were able to go over 15 kilometer line of sight. But in reality, realistically speaking, I would say 1 kilometer is the sweet spot to get more anything which is more reasonable for camera, live video.
Great, thank you very much for clarifying that, Srinath. Yeah. Any other questions from the audience?
Okay, I hope you can hear me. Thank you. Maybe just to Srinath, trying to find out a typical example of application of Hello Wi-Fi. Is it possible you can use that on, I call it oil and gas industry environment, whereby they want to do remote monitoring and like you mentioned camera, but as well as weather and in terms of security. How far can we apply that Hello Wi-Fi against the point-to-multipoint microwave link in that regard?
So as I said, we just finished some testing in the desert environment for about 15 kilometers. That connectivity, we were able to get about 3 megabits per second at that range. But as I said, mining and oil and gas, definitely we are recently getting a lot of queries in that application. We do not have any particular product today shipping in that, you can say, application. But that definitely seems like a very, very viable application for Wi-Fi Halo.
Thank you.
Yeah.
Great, any more hands? Anyone want to pose a question? Okay, well, I've got a couple of questions myself, actually, I'm really eager to ask. So one topic which didn't actually come up in any of the presentations, I don't believe seeing, was 5G. And 5G, obviously, if we go back a couple of years, there was a lot of hope for 5G, a lot of promise there. You could say hype, and there's a lot of promises which were made, and then in the delivery, maybe there was some misunderstanding, and people maybe found out they couldn't deliver everything which they thought it might be able to do. And we've kind of gone from a position a couple of years ago of competition between 5G and Wi-Fi, where there was maybe talk of one replacing the other, whereas now it's more about collaboration, and the coexistence of the two inside kind of networks. So it'd be really interesting to hear a bit from the panelists on your views on maybe demystifying 5G and your kind of views on exactly what 5G's role is in networks and how it can collaborate potentially with Wi-Fi to bring the best overall experience for the end customers. Maybe Deutsche Telekom, Christopher, have you got anything to perhaps comment on that?
Sure. Excuse me. I think for us, what's happening right now, we have sort of reached the height of the tidal wave in terms of 5G rollout. Standalone cores have been selected for all the NatCos, including in Germany and the United States, and we're all at sort of very advanced level. You now see the good speeds and everything. So now it's time to develop those use cases everyone has talked about. I don't think they're there yet. We're doing some stuff with network slicing for TV stations, and there's talks about bringing that feature into the gaming world. And I think in terms of convergence with Wi-Fi, I think that will come at some point in the next 2 years, to be honest. That's what I see, because the rollout, especially in Germany, is not done yet. But I think there are very viable use cases that also sort of need to come from the bottom up, bring them to the management, because of course we are super proud of our 5G network. We have the best 5G network in Germany. But let's be honest, you never have 100% network coverage. So I always give the example of, I have great network coverage 5G as long as I drive through my supermarket, but when I enter it, it's just a large metal box. And if my Wi-Fi is on, the captive portal from the chain pops up. So why is there a break? Yeah. And I think it's also sort of has to do with awareness that users think, oh, okay, yeah, it's like that. There's metal, there's concrete. 5G is not going through, but they don't know what they don't know. And the same sort of, to some extent, with the business side. So I think there's a lot of potential for 5G and Wi-Fi convergence in these kinds of scenarios, user experience, and then we need to see what other 5G use cases can be realized and what Wi-Fi's role can be there.
The smooth handover, right? So when you go from indoors to outdoors, right, they get the seamless experience for the end customer. Yeah, that's really key. Perhaps from sort of like an equipment vendor and potentially HFCL, I know you've done some work in this space, kind of converging Wi-Fi and 5G. Is there anything you could share on this for the audience here?
Yeah, I mean, look, the 5G's hype was mainly because everybody thought the kind of throughputs that 5G would offer, the kind of latencies that 5G has to offer, a lot of applications which otherwise rely on alternate modes of connectivity will basically start to fall into the 5G bucket, right? Now, this made an assumption, right? A couple of assumptions, right? So first assumption was that the 5G will work on all spectrum bands available in all the countries, right? Now, as things stand today, right, and the way the 4G has evolved, right, a lot of bands on which people could run 5G and provide a great indoor experience has not been available because the 4G traffic on those spectrum band is still significant, and people haven't moved their devices to the 5G, and therefore those 4G bands are not free. So once those bands, which are typically, we call it sub-gigahertz bands, which is basically 800 and 900 megahertz bands, 1800 megahertz band, 2100 megahertz band. These are the bands which penetrate well through the walls. And the idea was that these will become available for everybody to start to deploy 5G and the applications start to become well. That was one aspect. The second aspect was that there would be private 5G networks. The private 5G networks relied solely on the fact that there would be a liberal spectrum policy across the board, across the world, where people will be able to use this premium 3.3 gigahertz band, 3.3 to 3.7 or 4.1 depending upon where you are. This would be easily available. People can easily regulate that and things like that, right? Things didn't happen, and for the right reasons, that the telcos don't want these to be made open to everybody, and they want their share of the pie because they really wanted to start to monetize the 5G based on those private 5G networks, right? And there is a constant struggle going on between the regulator and the telcos and the enterprises as to what would happen, right? So these are a couple of complex issues that they needed to deal with. They haven't been dealt with, right? Having said that, running a private 5G network inside an enterprise is a very difficult proposition. 5G is an engineered network. It's not a network that you can just put an AP somewhere and start to radiate and you start to connect. That doesn't work. It needs a certain bit of planning. It requires a certain bit of knowledge. The equipment is very, very complex. The operations is even more complex. So it won't be easy for 5G to start to get into the enterprise network. IT teams of the enterprises will be able to manage. This is not going to happen anytime soon, at least in my understanding. And therefore I said, Wi-Fi 7 is a great opportunity, right? Indoor coverage, when the Wi-Fi coverage stops at the outside of the door, Wi-Fi 7 is a great opportunity. You can have the same experience inside with Wi-Fi 7. You can do everything pretty much. Most of the applications that were thought will be addressed by 5G can be addressed by Wi-Fi 7. So I think now they're going to start to realize that these are more complementary. You need to converge them. You need to move users who are using the network outside or 5G, they should be able to seamlessly get onto the Wi-Fi 7 network inside and then use the the resources the same way. I think that's where we're heading because there is reality sinking in for everyone.
That makes a lot of sense. In a way, the goalposts of 5G are always moving, right? Because Wi-Fi is moving very fast, and obviously when 5G was first introduced, we're comparing it to Wi-Fi 6 maybe, right? But now we're already on Wi-Fi 7. And by the time we get Wi-Fi 6G, we're going to be on to Wi-Fi 8. So Wi-Fi is evolving very fast, and the goalposts are moving for 5G. And I suppose what you're touching upon there was for enterprises, they're familiar with Wi-Fi. I mean, actually, the survey which I referred to, right, we're talking about, this is for the industrial market, but I'm pretty sure it's the same for the enterprise market. They're familiar with Wi-Fi, and they've got confidence in it.
Yeah.
So if you are going to introduce 5G into the mix, you probably want to be managing it the same you're managing a Wi-Fi network. You don't want to have a shadow network or learn some complex new skills or bring on a new team really to manage the new 5G infrastructure. So we've probably got time for one more kind of topic, which I was really eager to learn a bit more about. Srinath, during your kind of presentation, you spoke a little bit about Wi-Fi Halo, right, which is sort of IoT for Wi-Fi. It'd be good to delve a little bit deeper into how a Wi-Fi and IoT can also coexist. So we're seeing an increasing number of sort of IoT radios, right, with inside access points, and we're starting to get kind of dual IoT radios in there. We've got technologies like Bluetooth, Zigbee, ultra-wideband. Srinath, could you give maybe a couple of comments on your views on the other kind of IoT technologies and how they can also be incorporated into the mix?
Sure. First of all, my view on that topic is there's no one size fits all, because it all depends on the problem you're trying to solve. And all these technologies which exist today have been developed with some fundamental understanding of a problem that they've gone and solved. So in terms of, if you remember, the MIMO radios have gone from 1x, 2x2 to 4x4 to 8x8. So the problem continues to get complex. Maybe with Wi-Fi Halo, at least there is a one bucket of problems are going to get converged into being solved through Wi-Fi Halo, but some of the other technologies will continue to exist. I mean, their function is not very easily replaceable, and that's why we strongly believe we are another efficient lane in the highway. We are not trying to replace a lane at any point. Over time, maybe there will be some changes, and some of these will converge because provisioning becomes easy with other technologies. Then BLE kind of gets competition in that sense. But overall, I think at this point, as long as semiconductor technology continues to improve and you go to smaller geometries, these devices will continue to get smaller and smaller, and coexistence will continue to happen. The only thing is, eventually what will change the game would be rules of physics, that how long can you make it compact, how these can coexist, same frequencies, the channel interface and whatnot. So I believe we are nowhere close for total convergence, but we definitely feel that there are different quadrants which different technologies continue to address, and Wi-Fi Halo or UWB or let's say Zigbee, Z-Wave will continue to coexist for some time before there's a fundamental change in the usage. Yeah.
Makes a lot of sense, yeah. And maybe finally, Christian, maybe a few words from your side on what your views are towards kind of IoT within the Wi-Fi networking space.
Yeah, I mean, I see the same thing. I mean, it's really depending on the application, and we're seeing different applications. So, I see the AP is starting to become a gateway, not just for Wi-Fi, but also, tying in some of the location technologies. I mean, BLE's been around for quite a while. We're seeing things like electronic shelf labeling, where you have these smart labels in a store, so that's big for retail. Ultra wideband, is starting to get more interest there, increasing the accuracy. Doing things like AP placement or tying into, safety within a manufacturing environments, because where a product or a person is, a forklift. So yeah, I just see that we're starting to see it become a convergence point, for these technologies. And yeah, I mean, as Srinath said, I mean, it's multiple technologies because it is, an evolving area. People are, depending on the application, certain radio technologies are, what's going to solve that problem. Things like Matter, Zigbee, or other ones out there that we're starting to see. I'd say more from the consumer side, but, a lot of this stuff does start in the consumer and then comes into the enterprise.
And of course, all of that will require AI operations, right?
To simplify it, right? Because it's getting more complex. Yeah.
Excellent. Great. Well, thank you so much for your insights. And I guess you guys will be around perhaps afterwards for the cocktail hour. So if anyone's got any further questions, for any of us, please feel free to ask during the cocktail hour, which I believe is straight after the awards ceremony, which we're going to jump into now. So, yeah, thanks
Thank you.
everyone. And,
Thank you.
yeah.
Hello everyone and welcome to the 2024 WBI Industry Awards. You are the brave ones staying until the end of today's session. Thank you for that. This year the awards from WBI are special because it's the 12th anniversary of the WBI Industry Awards. So we have been running these awards for more than for 12 years. I want as well to reinforce all the work from our panel of judges. We receive a significant amount of candidatures for the awards, and I know that our 11 experts that are part of the panel of judges, they dedicate a lot of time to evaluate all the candidatures, so a big thank you to them. And I want to make a recognition as well to all our panel of judges. So I will ask just a round of applause for our panel of experts. Before I jump into the announcement of the different categories, I would like to invite my partner in crime, Mr. J.R. Wilson from AT&T, that is the chairman of the Wireless Broadband Alliance Board of Directors. J.R., please. And without further delays, I know drinks are waiting for us after this ceremony. I would like to go through the different categories. We have 7 categories for these industry awards in 2024. And the first category is the best Wi-Fi network operator.
We built the world's first CastPoint network to make getting online fast, easy, and super safe.
We built the world's first CBRS private network for smart business and smarter living.
We built the world's first Wi-Fi 6 network to deliver speeds that will blow you away.
And we're pioneering 5G, the network that will change the world.
We love first, and we also love big.
Boingo is the biggest indoor DAS provider in the U.S., connecting millions of people at iconic venues throughout the country.
KT provides gigabit speed Wi-Fi service based on our ultra-high-speed wired internet infrastructure and the deployment of Wi-Fi 6 and 6 Echo. We are also collaborating with Intel to commercialize Wi-Fi 7. Leveraging this advanced Wi-Fi technology, KT is at the forefront of supporting small business through digital transformation and addressing social issues such as the digital divide.
We plan to the first to launch Wi-Fi 7 service in Korea using frequencies of 6 GHz up to 320 MHz in this fall and has named it True Wi-Fi 7. And this is our new Wi-Fi 7 router. We have completed a lot of trials with Wi-Fi 7 pioneers such as Samsung and Intel to find point of differentiation and are contributing to the global rollout of Wi-Fi 7 by participating in the Wi-Fi 7 trial test of WBA.
congratulations for winning the award. So I propose that we move on to the next category, Best Wi-Fi Network Technology.
This solution leverages Cisco's existing wireless infrastructure that includes Catalyst access points that have integrated IoT radio, Catalyst 9800 wireless controller, and IoT orchestrator as its core component. IoT orchestrator is actually deployed as a Docker container on top of Catalyst 9800 wireless controller. This solution greatly simplifies the onboarding, authorization, and control of third-party BLE devices through the APIs exposed via IoT.
Once more, congratulations to all the shortlisted companies, and in particular to Qualcomm for winning the award. So we move on to the next category, number 3, Best in-Home Wi-Fi Network.
우리 집 와이파이가 어디 있더라? 찾았다. 와이파이 공유기. 이제 숨기지 말고 드러내자. 디자인과 성능을 다 담은 와이파이 60 공유기. 공간과 취향에 맞춘 디자인으로 인테리어도 마음껏, 디자인은 취향껏. 강력한 내장 안테나로 속도는 더 빵빵하게.
LG U Plus AI ML-based home Wi-Fi quality care system consists of 3 main steps: data collection, AI ML-based Wi-Fi quality analysis, customer care, and upselling. In the data collection phase, we collect data from the customer's environment, pre-process it, and store a total of 373 types of data. In particular, interference levels have been rigorously tested in real-world environments to establish a uniform standard. Of this data, we utilize 12 statistical.
Congratulations, Turk Telecom and Quant Wi-Fi for winning the Best in-Home Wi-Fi Network Award. Next category is the Best Enterprise Wi-Fi Network.
In Baidabetu, HFCL solution is making a significant impact by benefiting not only students, but also the entire community.
Through this PM1 Wi-Fi connection, our school, our staff, our people, all are connected to the world.
Wi-Fi use करते हुए हम पढ़ाई में आगे बढ़ रहे हैं.
There will be a collaborative learning across the globe where teachers will collaborate to teach the students. Students will collaborate together to do new things.
In a big campus, there are many wireless APs with high power consumption and leads to much waste of energy during nights and holidays. Therefore, campus networks require a more intelligent energy saving solution to guarantee the energy saving effect. Huawei takes one step further by launching the Intelligent AP Energy Saving Solution. This solution adapts AI technologies to fully explore the value of historical network data, intelligently identify energy-saving APs.
To simplify visitor access, companies are deploying secure passpoint networks, enabling carrier offload and open roaming solutions. Passpoint and open roaming provide simple, seamless, secure connectivity to Wi-Fi networks. Single Digits, on behalf of AT&T, has developed the AT&T Auto Attach app in the Cisco Spaces Partner Marketplace. The app is available to networks that are customers of Cisco Spaces. This service provides seamless and secure connection for AT&T devices on open roaming networks.
Congratulations to Huawei. Unfortunately, the representative of Huawei is not present here today to receive the award, but we'll deliver to them. Anyway, congratulations to Huawei for winning the award. Next category is the Best Wi-Fi for Social Impact.
So why do I think Helium Mobile should be considered for a best Wi-Fi technology for social impact? Well, we recently announced a partnership with Telefonica with their brand in Mexico called Movistar. And what's the interesting part is that we got to see the impact of what a decentralized network can do in places where connectivity is pretty poor. So wherever the carrier does not have the ability to reach those customers, because for a variety of reasons.
We also connect hospitals in urban areas and rural areas. We wirelessly connect mobile units so that they can serve the population in remote areas. We provide free internet access so that all government services and social programs can be accessed online, because we want the state to be recognized for offering digital services, technological resources, and access to knowledge, and not only for being the passage of the Mayan train or oil extraction. The Connectivity for All project has a great economic impact by reducing the cost of telecommunications services.
Congratulations to Cognitive Systems and Caregiver for winning the award on Best Wi-Fi for Social Impact. Next category is Best Wi-Fi Innovation.
Wi-Fi uses electromagnetic waves to transmit signals on the air. This offers convenient Wi-Fi access for users, but it may be exploited by hackers who capture user packets through wireless eavesdropping. Traditional approaches enhance Wi-Fi data security by encrypting data and making them hard to decrypt even if being eavesdropped. Unlike other vendors, Huawei takes one step further by developing the unique Wi-Fi shell technology on Wi-Fi 7 APs, which safeguards wireless communication.
We're here at Ocean Beach in San Francisco. Imagine a wireless technology that can connect to devices that are kilometers away, consume minimal power, and seamlessly penetrate walls and buildings. Well, that's precisely what Wi-Fi Halo brings to the table.
Today we are performing a long-range Wi-Fi link test between Morse Micro's AP and station to demonstrate the incredible reach of 802.11ah Wi-Fi Halo. Where are you?
Hey, I'm at 250 meters.
Hey, how you doing? Where are you at?
I'm at 1 kilometer.
Oh, that's amazing.
Congratulations to Morse Micro for winning the Best Wi-Fi Innovation. And we are at the end, so final category, Best Wi-Fi Customer Experience.
You're providing connectivity on all of the platforms, all the way through the tunnels. And does that include underneath the East River?
It does. There's 2 new tunnels underneath the East River. So where we're at here, we're 18 stories below ground. We run hundreds of miles of cable, 10 miles of track, and 3 million square feet. So this is a very complex connectivity build. They all are. This one is at the top of the scale, and what the Boingo team and engineers have done a wonderful job.
Tata Communications as a single managed Wi-Fi provider across India, I think has set us up for a great future going ahead in this space. I think as Starbucks expands its footprint in India with the rapid expansion across various cities, I believe that having a partner like Tata Communications with that penetration, with that market reach, that technology strength, that customer centricity, and forward-looking investment in technologies like private networks, cybersecurity, conversational commerce, I think it's great to have a partner like that while we take this journey. So I think we are really looking forward to further collaborating.
So big congratulations to all the winners. Thank you to all the participants on the 2025 WBI Industry Awards. I invite all of you to celebrate and be part of this awards ceremony. Consider for 2025 as well to submit either again, or if you never submitted and participated on the awards, consider to be part of this initiative from WBI. And with this, I would like to close these awards, recognize as well all the sponsors of this event. Without their support, we will not be able to manage and deliver this event.